Yes, I hope all of you can see my screen now. Is my screen visible
Yes,
to everyone? Okay,
yes,
thank you
yes,
guys.
yes, yes.
So guys, this is what I have designed for you guys that I'm going to cover in the next 3 months or so. Okay, so we'll start right from the scratch and we'll go to SD-WAN and wireless. Okay, SD-WAN we'll cover the fundamental, and wireless also we'll cover the fundamentals of them. Okay, apart from that, fundamentals of networking, entire switching, entire routing, including BGP, RSTP, MST, everything I have included. Port security
नहीं मुझे
also
उनका
we'll study.
अब हाथ पकड़ना क्या ही पड़े और माल के
Guys,
चक्कर में
please be on mute.
हाँ देख रहे सीमांत कल्ला
Guys, please be on mute. Yeah, thank you. Okay, so we'll go ahead with all of these topics gradually. And when I'm saying I'll go all of these topics, so they won't be any overview kind of thing. So we'll start everything from its base and we will study till CCI level. What is the like foundation of Cisco? Start from CCNA to CCI level. So that's how we are going to go ahead in this session. Though it's a CCNP based session, but now you don't have any CCI written exam. So whatever topics I'll cover them to the extent of CCI level. That I can assure you. Okay. And as far as the material is concerned regarding this, so I will share Cisco guides itself with you. Okay. I'll share the PDF of the Cisco guides itself, Cisco switching and Cisco routing PDFs, so that you can directly relate to them. You can read them. And when I'm telling these things, so let me tell you, they are one of the best books in the market. You won't get a better material than those books. If you want to clear out your basics, they are the best. For network fundamentals, I won't recommend you to go for any material or any book. Okay, whatever we will be discussing in our class, that is more than sufficient for you. But switching onwards and switching and routing, I'll definitely share some books with you. Okay, and every topic which we will discuss over here, that will contain its t-shoot part as well, that how to t-shoot that specific issue. Okay, whatever topic you can see over here like VTP modes, they don't just contain simple theory. Okay, so forget about it. They don't say you contain simple theory, they contain theory, configuration, as well as troubleshooting part as well. Okay, so I'm going to make you guys pro in the next 3 months. So get ready for it. This particular batch is only 999, as you all know. We are not getting anything out of it, to be honest, guys. This batch I'm specifically doing, me and Rohan. The purpose of this batch is simply to give this industry something, because this industry has given us a lot. So it's time for us to pay back the same to the industry. So that's why we are doing it at such a price that all of you can, absolutely everyone can afford it. So that is the reason for it. For lab purposes, I will help you out to set up your own lab. Okay. And if that's not viable for you, you can like go and you can reach out to and you can like ping us. We will provide you remote lab as well. But remote lab has additional charges. If you want that, we can provide you that as well. Absolutely not an issue. Okay. And let me, for those who have joined for the first time, okay, those who have joined for the first time. So this is our URL ngcloudx.in. Okay, let me tell you about us. So we Ngcloudx are a training organization. We focus on providing training at such a cost that it's affordable to everyone. Okay, and we also provide placement assistance in case you require that as well. Okay, Ravi, could you share me the OTP?
Yes, sir. 1 minute, sir.
So with you can turn off your camera.
Sir, shall I tell here or
No, no,
in a
ping me one to one. Ping me one to
that's
one.
okay, sir. One second.
Okay, you can simply guys go to ngcloudx.in. You can log in by your contact number.
Yes, sir. I sent you.
It will ask for an OTP. Enter the OTP, and then you will log in over here. So this is Ravi's purchased courses from us. But if you want, you can like go to the store. Okay, you can go for any of the courses that are listed in Ngcloudx and you can buy them. Okay, if you are looking for this CCNA CCNP bundle, it's right here. Okay, this is a link for that. Let me paste the link directly itself in the chat section for you guys. Okay, so you can directly go to this link and you can directly purchase this course. Okay, and apart from that, we have few more courses with us. This is our hot course where we are providing everything in 10,000. Okay, everything means these many things. Okay, Fortinet, Checkpoint, Palo, Cisco, F5, Wireshark, Linux, WAF, both WAFs, Cloudflare and FortiWeb, two WAFs. So everything under 10,000 and that to basic from advanced. I'm not talking about 10,000 per 10,000 for a single course. I'm talking about 10,000 all of these. Okay, and those who are already enrolled in this, they're very well aware of that. Fortinet and Checkpoint is already done. Palo Alto is going on right now. After then, we'll start with FTD in December. LTM, GTM will go, and then next year onwards, these remaining four topics will go. So that is also one hot, course for us. That is also, and for this course, you can avail EMI option as well. We have EMI option as well. You can also avail EMI for 10,000. Okay, and for you guys who are only enrolled for CCNA CCNP, they can simply go on the CCNA CCNP bundle and they can purchase it. Okay, you will get lifetime access of recordings. You will get lifetime access of recording guys in this portal itself. Okay, so no matter whether you attend session here or not, but you can go to your home, you can open the portal, you can log into the portal and you can watch all these things in your own pace. Okay, guys, please be on time. Okay, one more thing guys before winding off. Apart from that, we have, guys, please be on time. That is the one thing with us. So we have Zscaler courses as well, CrowdStrike. If you want to buy individual courses out of them, that also option we have. Like if you want to buy Fortinet or if you want to buy Checkpoint individually, that also option we have. Fortinet individually costs us 3,000, Checkpoint is 4,000. So like that also you can do. Okay, and we are available in all languages. For example, this is my FortiGate recordings itself. This is my batch only, guys. So recorded videos are there. If you want to buy, you can go ahead and you can buy that. Okay, I think it's only 3,000 rupees. Further, you can check at your end. I believe it's 3,000 rupees only. Okay, and if you want to buy Zscaler, you can buy Zscaler as well. Okay, all the recordings that you will get from us will have a lifetime access. Okay, they will have a lifetime access. Any point of time you can log in and you can watch them. Okay, so absolutely no problems in that. So why I'm going with this course? Again, just to give something to the industry, to what we have got from it. Yeah, guys, go ahead if you want to ask anything.
Okay, Sumit, actually, I have already attended the 40 net paid classes.
Mm-hmm.
Just I wanted to confirm right now, like a course is going on Palo Alto, which is taken by Rohan. So,
Mm-hmm.
which is, that is the different one, or it's already included on 9,000 and 9,999?
That 9999, that 40 gate you attended was part of that 9999 bundle only. And if you want to buy entire bundle, you can like ping Rohan after the session. He will add you in the 9999 section. You can pay the deficit amount and you can get access to all the courses.
Okay, I got it.
Yeah.
Thank you.
Yeah. Checkpoint is completed after 40 gate. We went ahead with checkpoint. Right now Palo Alto Rohan is taking. FTD also Rohan will take. LTM and GTM I'll take. And then we'll Wireshark also I'll take probably. Linux either me or Rohan will take. Cloudflare 40 web both, one will be taken by Rohan, one will be taken by me, or both Rohan will take. So that will sort out, no worries. But that's how we are planning right now. Okay. And your bundle again, 999. You can come, you can buy, and you can avail these classes. Okay. Anyone else want to ask anything?
And what is the syllabus of like current CCNA and NRC, CCNP and RC
Is my
content?
screen visible?
Yes, yes, yeah. Thank you.
This what we are going to cover in the next 3 months time. Okay, fundamentals, addresses, subnetting. It is going to be a marathon subnetting sessions, guys. Okay, then cabling, broadcast domains, collision domains, TCP, OSI. I'll discuss each and everything of layer 4, guys. Okay, whatever features we have, windowing, selective acknowledgement, everything. Okay, of the TAC level. Okay, all the headers we will discuss on TAC level, packet flow, then network designs. Okay, that the 3-tier architectures we have. Then we will come with switch operations, CAM table, MAC address table, all those things. VTP, STP will start from the scratch and we'll cover each and everything of STP, guys. Okay, whether it's STP, its variants, loop avoidance mechanism, STP conversions, STP protection, root guard, BPDU guard, BPDU filter, UDLD, everything, port fast, everything I'll cover. Okay. Multi-layer switching, layer 3 switch also I'll cover. Ceph, inter VLAN routing, DHCP packet flow will be there. Port security also we'll cover. NTP, SNMP, iOS backups. Okay. Ether channel, static routing, EIGRP, OSPF, BGP, HA, high availability, HSRP, VRRP, GLBP, and last but not the least, we'll cover SD-WAN and wireless fundamentals only. Okay. In OSPF, I'm going to cover 8 LSAs, 127 and LSA 9. So this is the table of contents we have that we are going to cover in the next 3 months or so. Okay. This is only the serial number. This is not the day wise content. This is what we will be covering. Okay. It may take more days, it may take less days. That depends completely on you guys. If you will have like more and more engagement, probably I don't have any problems of going even beyond 3 months, guys. I'm absolutely okay with going beyond 3 months, guys, because I want again, as I told you, so 999, what it is giving me. To be honest, we are not getting
Sumit
anything
sir,
out of it. Yeah,
Sumit sir, sorry to interrupt you. Just
yeah,
asking
yeah,
one
yeah.
question that we are going to cover OSPF and BGP in a very complete detailed manner, or we are just going to touch the
Complete,
few of the topics.
complete detail,
Okay,
man.
that in
Complete detail. Never seen before.
okay, 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 I get it.
never seen before. I'll also cover very basic of MPLS as well, but that will be very basic because as you guys all know that MPLS is getting obsolete these days. Okay, but let me tell you one thing: MPLS will never go away. MPLS will remain in the market because as per the guidelines of DOT, Department of Telecommunication, voice traffic has to be on MPLS. So till the time the guideline is there, so all of your call centers, all these calls that you receives, they will be on MPLS only. Okay. If you're talking about normal voice calls, they will be on MPLS. I'm not talking about internet based voice calls. Okay. Like you are calling from WhatsApp to WhatsApp. Okay. But you cannot call WhatsApp on your number or from your number to the WhatsApp. That is not allowed as per the guidelines of Department of Telecommunication in India. So MPLS will always be there. Even I can completely agree on it that its utilization will reduce to 10% or 15%. Definitely yes. But if you talk me, if you like ask me, it will completely go away. No, guys, it won't. Okay. So we will touch MPLS as well to some extent. Uh, Only till that extent to which it is required. Okay. And I am open to add more topics in this. For example, in the session itself, I could see that I didn't added multicasting in it. Okay, so probably I'll add IGMP as well. I'll adjust it somewhere above and below. Okay, IGMP. For those who are not aware about multicasting, don't worry, we'll discuss multicasting, and probably I'll see a room for QoS as well. So we are covering a lot of topics. Let's see how it goes. But I can assure you, it's the most worth 999. It is going to be most worth 999 for you. Okay, probably I'm giving you everything that we have in basic fundamentals. Anyone want to ask anything else? Anyone? Any doubts?
So,
As
Saurabh sir, if we are covering these topics, so that
hmm,
means after completion of these topics, we'll be able to give this CCI written exam, right?
CCI written exam is obsolete, buddy. It's not there anymore.
Okay. Okay.
It's straight away CCI
So,
lab.
okay. So, with respect to the, if we talk about the traditional exams, so it means we are ready after completion of this course till CCI
Yes,
written, right?
NA, yeah, it will be of CCI written level. Yes.
Okay.
CCI written is not there anymore. I think you're not aware about the latest certification pattern of Cisco. We don't have CCI written anymore. If you want to go for CCI lab, so you can give CCNP. You need to give CCNP now. If you want to give CCI Enterprise Lab, you need to give CCNP and Core. And if you want to give CCI Security, you need to go for CCNP Score.
Okay. Okay.
Okay. Hmm. Okay, guys. I guess we are good to go. If you guys still have any doubts, you can go ahead and you can ask me. So our session plan is going to be 2 hours, as I told you, where we will be studying for 1 hour continuously, 12 p.m. to 1 p.m. Then we'll get a break of 20 to 30 minutes. After that, 1 more hour of study, and then you're good to go for the day. Okay, so that's how our session plan is going to be. And I would request you to have maximum engagements as I know there are many freshers in this batch as well. So guys, the more you will interact, the better it will be for you. Okay. So try to have more and more interaction, guys. I hope we are good to start for the day now.
Yes.
Okay, cool. Just give me a moment, guys. Okay, cool, guys. Okay, so let's start from the very basic. Okay, what exactly is a network? Anyone? Anyone? Specifically freshers, guys.
Connect the two things, which is called network.
Absolutely. But what? Connection of only two things,
Connecting multiple computers.
two or
More.
more things. Connection of two or more things. Guys, please be on mute. Things or that's okay. Things or devices, whatever you call. For what purpose? Guys, if you want to like learn anything, you need to, I'll tell you, you need to know about three things: what, how, okay, and purpose. So let's talk about network. So what exactly is a network? Connection of two or more things or devices. Okay, done. What is done? Part two. How? Second, we have how. That we will study in next course of action. But what is the purpose of it? Purpose is so that so that uh, the
So I'm not able to hear you.
am I audible now?
So you. Oh yes,
Um,
no, no worries.
okay,
Yes,
okay,
come.
Yes, yes.
okay. Sorry, guys. Sorry, guys. So I'm saying what is a network? You need to, if you are studying anything, it's not confined to network only. You need to know the answer of three things, like what exactly we are talking about, how to achieve that, and what is the purpose of that. If you know about these three things of anything, you are done. If you can answer these three things, you are done. So same thing I'll do in, I'm doing it for network. Like what exactly is a network? What connection of two or more devices? How you achieve a network, how you establish networking, that we will study in our next course of action for the next upcoming days. And what is the purpose of that? So that they can communicate, share resources and data. That's it. This is a network. And what is a networking? And what is a networking? Networking is simply the design and construction, the design and construction of a network so that they can communicate share data and resources. But in a secured environment, that also we need to assure, right? What is a secure environment? We'll study. Is known as networking. Okay, so this is network and networking. Any doubts? Any doubts? Okay, okay. Let's go ahead. Let's talk about networking devices we have. Networking devices. So what are the devices we have, anyone? Let's start from LAN. What do we have at LAN level? We have switch, we have hub, we have bridges. Okay, then on WAN level, what do we have? We have routers, we have firewalls, okay, and we have layer 3 switches. So these are the devices we have. To understand them in a better way, in every batch of mine, I like to tell a story, guys, so that they can relate. People can relate.
Sir, in LAN,
Okay.
can we include access point and WLC also, or it's
Yes, you
in
can. Yes,
another?
you can. Yes, you can. I'm talking about the major devices. You can include WLC again in WAN. You can include WSAs. So like that, yes, you can include.
Okay,
Now,
sir. Okay.
to understand, I'm just talking about the major devices. So networking devices, AP as well, you can include access pointers. So I would like to tell a story so that people can understand and relate to it in a much better way. Okay. Those who have like taken my basic foundation batch, they must be aware of this. So let's suppose we have a building. Let's suppose this is my building. Okay, it has someone is in the lobby. No, no one is in the lobby. Okay, let's suppose it has 4 to 5 stories. One, two, three, 4, 5, 6. 1, 2, 3. CEO is sitting at the top floor. CEO is sitting at the top floor. Okay, then we have ground floor. Let's say your watchman is there. Okay. Then you have your first floor. Let's say on your first floor, I have some 400 employees. On your second floor, we have, let's say, 500 employees. Third floor, you can take, let's say, again 400. Fourth, you can take, let's say, we have again 300 odd employees. Okay, so how many are there? 9, 3, 12, and for 1500 employees are there, excluding CEO and watchman. Now, let's suppose you don't have networking yet. Okay, we don't have anything related to networking. So I have a CEO. I am a CEO. Let's suppose I want to share a document. I want to share a document or I want to share some data to all of my employees. What is the option I have? I don't have networking yet. I don't have a networking yet. So without networking, what is the option I have? Take print, take 1500 prints Okay, and then go to everyone individually. This is the option one I have without networking. Okay, that he will take 1500 printouts. He'll go to each and every individual and distribute it to them through him or by watchman or anyone. Okay, but you can say 1500 prints. Lot of resources are consumed and being wasted. Lot of resources. So the CEO realized that it is not a cost effective solution. So he discussed with his R&D team. He contacted his R&D team. He said that we need to find a solution that is less cost effective for us. That is cost effective. Okay, that is viable for me so that I don't have to take out 1500 prints every time. So what that R&D team did, they researched and they built a device. What was the purpose of that device? Okay, that device was attached to the system of every single individual. Okay, so that device was Hub. What CEO did with Hub, he has to send data or whatever confidential data he has on one of the interfaces of the Hub, and Hub will forward it from all of its interfaces. So this was the first outcome of the R&D team. Hub receive something on one interfaces and then received thing will be forwarded across all the interfaces. So like that, CEO had a very cost effective solution if he has to send the traffic to all the users he has over the building. Very good. CEO was very happy. Next. Next solution, next thing he wanted from his team. CEO has requirement that he needs to share something. CEO needs to share something with, let's say, 100 users on each floor. So CEO needs to like share this time with only 100 users. CEO doesn't want to share with all of them. Okay, earlier what was happening, he was sending and all of the users are receiving, all of the employees were receiving his traffic. But now CEO has something that needs to be shared only with limited number of employees. So he has two options again to take these many prints and distribute it to those specific employees or to send the traffic via Hub. But Hub will send it to all the other employees as well. So that will be sort of a COC. That will be like a COC breach, that he's sharing a document that is not supposed to be shared with rest of the employees. So again, the CEO went to his R&D team. He said to his R&D team, hey guys, I am okay with your previous technology, with your previous device Hub, but we need to make some modifications in the design. This time, I don't want my device to simply broadcast the traffic. I want my device to share with only specific number of users only. R&D team got one more task. They researched for a few days and then they came up with new device. Then they came up with new device. That device was switch. That device was switch. Switch was an intelligent device. Okay, Hub is not an intelligent device. What Hub was doing, receiving something and then forwarding blindly on all the interfaces. But the switch has modified technology as compared to hub. With switch, the CEO was able to share data with only 100 users on each floor. 100, 100, 100. That means what switch did? Switch forwarded traffic, switch forwarded traffic inside building to specific users only. Okay, that's what switch did. So these were the two major devices we had. Now, CEO, that CEO was very, he had very innovative mind. He wasn't confined to only these two cost effective solutions. Then the CEO, who was sitting at the top floor of his building, he has his office in Noida, let's say. He wants to share the traffic. Okay, now he wants to send a traffic to its other location. Okay, other location, other employees. Let's say this location is in, let's say Gurugram. Okay, it has, let's say, some 1000 employees. Okay, 500, 500 each. So he wants to share something with specific employees of other, other building. How can he achieve that? Switch and hub were able to communicate inside the building. But what about anything which is kept in other location? So again, the CEO went to his R&D team. He gave them another task. He's told them that I want to send something to my other branch. Give me one more solution. So what they came up with? They came up with router. So that two different locations can communicate. CEO was very happy till this point. Okay, his things were going very smooth, very, very smooth. But one day, what happened? One day, someone from the neighboring part of India called China, they just entered into his environment. They entered into his environment. What they did, they hacked his system. All his confidential data, which was going out over the internet and going through the router, it was not secured anymore. He, he wasn't able to send it. So what he did, he again went to his R&D team. He said that, hey guys, we are in trouble as we are exposed, as we are completely exposed. So what we need to do, we need to came up with something that could not only send my traffic across from one end to another end, but I can do the same in a secured manner. So his R&D team again did some R&D and they came up with firewall. So with firewall, the CEO this time was able to exchange the traffic not only from one location to another location, but it was in the secured manner with the help of firewall. So these are the four major devices we have in our environment. So how was the story, guys?
So lovely story. I love this.
Infosec. very to
Never
understand.
ever we can forget it.
I know you will not forget this. Okay. So these are the four major devices we have. Okay. Switch started from hub. From hub, it went to switch. From switch, we came up with router. With router, we came up with firewall. So that was the reason. Every device has a reason. Okay. Okay, so let's talk about some random, though I will discuss each and every device again in a technical manner. This was just to give you overview of it. Okay. Few more fundamental things that you need to know before going ahead. Nick. Nick. Anyone aware of this term?
Yes, sir.
Interface card.
Yes. Network interface card. Nick. So what is the purpose of Nick? Do we have Nick? Do we have Nick in our systems?
Yes, yes, yes. Without
Yes,
that,
Yes.
we
without
do
this,
have.
you cannot access the internet.
Yes, with Nick you can access internet, but how? This component, first thing, is installed on end devices as well as network devices. As well as network devices. Okay, when I'm saying about end devices, guys, I'm talking about PCs. I'm talking about servers. Okay, PC and servers majorly, as well as network devices. Now, what happens with NIC? NIC is a chip on which we have a physical address embedded into. Okay. And what is this physical address? This physical address is known as MAC address, media access control. We'll talk more about MAC address, don't worry. Okay, so every networking device, okay, who is doing networking has a NIC. Okay, has a NIC associated to it, has a NIC hard coded into it, and on that NIC you have a physical address associated. Whenever you access, okay, whenever you access internet with the help of an IP address. And physical address is your name. The IP address that you get from your DHCP server or via any other static means is assigned to your NIC, is assigned to your physical address. So that is why we say that without NIC you cannot communicate over the internet, because without NIC you will not get IP address, guys. Your DHCP server assigns IP address with regards to your MAC address. Now, what is a MAC address? What is a physical address? What is logical IP? These we will talk about in next course of our lectures. For the time being, you just guys needs to be aware that NIC is a chip, okay, that is embedded into our system, and there is a address embedded over that NIC chip, and on that hardware address that is embedded over that NIC chip, we have an IP address assignment, and through IP address you actually access the internet. If you don't have NIC installed inside your device, you will not get the access of internet, you will not get the IP address. Without IP address, no internet allocation is possible. Am I clear?
Yes, sir.
Yes, sir.
Yes. Yes.
Okay. Okay. Hub. Hub is a layer 1 device, though I have talked about it, but let's talk about it in more technicalities. Hub is a layer 1 device. Okay. What is this layer 1, layer 2? I'll talk more about layer 1 and layer 2, or multiple times I'm going to use this thing. Okay, so before going ahead, I'll give you a brief. We have OSI and TCP IP reference model for communication. Okay, and they are layered models. Okay, they have layers. Seven, like OSI has 7 layers. So when I'm saying layer 1, layer 2, layer 3, so they are layer 1, 2, 3 of the OSI and TCP IP models that we will discuss more about in our upcoming sessions. So Hub is a layer 1 device. Hub operates in half duplex mode. What is half duplex?
One-way communication, sir.
How? Yes.
Let's talk about the communications.
Like a walkie-talkie.
Like walkie-talkie. Let's talk about it. So we have two things. First is types of communication. Second, we have modes of communication. So these are modes of communication. We have modes of communication. The very first mode of communication is simplex. So what is simplex? In simplex, one device can receive, one device can receive, and another device, and another device can forward or transmit. Can anyone give me a very good example of simplex? It should be very good. Otherwise, I'll give you.
TV, like TV.
Absolutely. TV can only forward the traffic. TV receives input from our remote, and then according to the input, it provides us the output. Okay. Your keyboard, it is providing the input only, not the output. Mouse, input only. Your radios, output only. Okay. So
Mobile
at a
phones, sir.
time, no, mobile phones can do, mobile phones are full duplex, buddy. They can receive
Monitor.
and transmit both at the same time. Yes, monitor. They can only, I'm talking about devices who can do only one thing at a time. Okay. Mobile phones can send and transmit both at the same time. When you are doing the call, okay, you can speak as well as you can receive, right? Both can be done at the same time. So mobile is not simplex, it is full duplex. We'll talk about it. Don't worry. Half
Mouse, sir.
duplex. Mouse already done. Okay. Guys, wherever you feel like you're not understanding, let me know. We'll repeat again. Okay. Because this is very basic things. These needs to be cleared. Okay. In this mode of communication, both devices in simplex, one device was receiving and one was sending. In this, but in half duplex, in this mode of communication, both devices can receive and transmit, but not at the same time. But not at the same time. At one point of time, he'll either be able to send or he'll either be able to receive. Okay. For example, your walkie-talkies. I don't know how many of you have used walkie-talkies or not, but when I used to work in airport, I have used walkie-talkies a lot when I was part of ATC, air traffic controller. So I have used walkie-talkies, guys. In walkie-talkies, there is a frequency set. Okay. Once you press the walkie-talkie button, you can either speak or you can listen. Okay, you can do both but not at the same time. Okay, for example, I am trying to communicate with Ravi over the walkie talkie, so I'll speak first, Ravi will listen. Once Ravi will listen to me, then he will press the button again and he will say something and I'll receive. So that's how walkie talkie works. I don't know how many of you have used it or not, but walkie talkies are still more of a used in government-based organization, government-based things only. Walkie-talkies are either obsolete now. Then last we have full duplex. Okay, in full duplex, in full duplex, both devices can receive and transmit the traffic at the same time. Example, what is the example? Your mobile phones, has someone told me. Okay, routers, switches, everything, etc. Okay, so these are the modes of communication we have. I hope there shouldn't be any doubts in this, in modes of communication. Then after modes, we have types of communication. After modes, we have types of communication. First is unicast. So what is unicast? Anyone?
One to one.
Yes, one-to-one communication. What do you mean by one-to-one communication, guys? Like a simple client and server model.
Yes.
Simple client and server model. There is one client and one server. They are communicating. I am pinging google.com. I am one user and Google is another user. So we both are communicating. I am his client, he's my server. So simple client and server communication. That is unicast communication, guys. Okay. Second, we have multicast. What is multicast? Anyone?
One to many.
Okay. What do you mean by one to many then?
Like
With example.
Okay, suppose I have I have a WhatsApp and there is a many people in my in WhatsApp group, and that I am sharing any message to this message is reaching to everyone.
Hmm.
That called multicast.
That is more of a broadcast as well. I'll tell you. No worries. I'll tell you with a better example.
Sir, this
There
meeting
is a one
only.
example of FM.
FM, no, FM is
Let's say
broadcast.
it is.
So team
So
meeting
let's
like
say if
one
it
like
is
we
a
are doing right now.
I'll give you a much better example that will clear your doubts. Okay, guys, do you? I think now all of us are using DTH connections, right? I think most of us are using DTH connections, direct to home, for our cable. Earlier we used to have cables. Do you remember that? Now we don't have cables anymore. Now we have DTH connection set-top box. In DTH connection itself is a multicast. First thing, it itself is a multicast because all of us are receiving the lease lines of the DTH connection, but we are using it for a specific vendor only. Okay, no problems. Further, let's suppose we all of us are using same DTH vendor, but inside your DTH connection, let's say it is Airtel. Let's say Airtel's DTH connection is there, or let's say you are using Geo Plus. Okay, I don't know, it's Geo Fiber Plus. Okay, you guys must have observed if you are using Airtel, Geo, or whatever DTH connection you are using in your home, there are some paid channels, right? There are some paid channels. They are not available for you to view. I don't know how many of you have observed it or not. For them, they ask for a specific subscription. You pay for that amount, and then you suddenly start getting the telecast of those specific channels. How does it works at the back end? This is multicasting, guys. Multicasting is those paid channels, even though you are part of the DTH connection group, you are taking the DTH connection, but for those specific paid channels, only those people are getting those who are paying for them, who are paying for them. By paying for those paid channels, what happens is you get added to the multicasting group. You get added to the multicasting group. When I'll talk about IGMP protocol in more details, you will get to know what is this multicasting group. Okay, so you get added to the multicasting group. Once you get added to the multicasting group, only then you will receive that channel. Otherwise, you will not receive the channel. So this is multicasting, guys. One to many. Even though all of you are getting the channel who has applied for that DTH connection or who is getting the DTH connection, but only specific persons are getting output out of it. Why? Because those specific persons are part of that channel's multicasting group. The moment you pay, they add you in the group and you start receiving it. Is it clear now?
Yes.
Okay. Third thing is broadcasting. One to all. As simple as that. One to all in a network. Broadcasting happens always in a network. Broadcasting happens always in a network. Always remember this. Broadcasting happens always in a network. When we'll discuss more about routing, you will get You will get this. There is nothing called as one to all in real time. Okay. If I'm saying I am initiating something and it will go to all the users in the planet, no, that's not possible. Okay. It's practically impossible to achieve. Okay, but broadcasting is one to all, but in a network. For example, right now our classroom is a network. Okay, we are in a classroom, guys, right now, where I am your trainer. I am delivering something and it is going to all of you. When you deliver a message in a WhatsApp to all the contacts, it is like broadcasting to all of your contacts. They are in your network. Same thing happens over here as well. Broadcasting happens in a network only and it is one to all communication. Okay, like I am communicating with you guys right now to all of you at once. Okay, perfect example is your classroom. Okay, classroom lecture. Okay, it's almost one, guys. Let's take a small break. Okay, let me stop my screen share. Let me save the recording. Okay, guys, started. Yes. Okay. So we were discussing about hub. So we were discussing about hub. Okay, hub is a layer 1 device of the OSI network. It operates in half duplex mode. Okay, hub can only broadcast the traffic. Okay, hub can only broadcast the traffic. Okay, always remember one thing: hubs are not intelligent device, guys. Hubs are not intelligent devices. When I'm saying intelligent devices, why? Because what hub does, hub receives the traffic and it blindly forwards it to the remaining interfaces. So that's why we say that hubs are not intelligent devices. Okay, because they do not have memory to learn the addresses. Guys, what was the basic technical difference between a hub and a switch? Hub doesn't has any memory. They don't have any memory, but switch has a memory, and switch uses that memory to learn where a specific MAC address is located. Okay, how to modify or how to play with that memory and its entries, that we'll discuss in switching. But switch can store the entries that this is a MAC address, it is on this interface. This is a MAC address, this is on this specific interface. But the same thing is not there with hub. In hub, send the traffic on one end and it will broadcast it from the remaining of its interfaces. As simple as that. Okay, this is one thing. Next point with hubs is hubs not hubs are not used nowadays because they were very slow. This is the drawback of the hub. Okay, they were very slow due to collision and hard duplex. What is this collision? That we'll talk about in next upcoming sessions. collision domain and broadcast domain, CSMA, CD, all those things. Okay. I hope it is clear to you guys now what exactly hub is and how it forwards the packet. Okay. Hub can only, always remember that hub can only broadcast the traffic. Okay. Apart from that, hub can't do anything. Next is switches. Next is switches. Okay. Now hub is a layer 1 device, switch is a layer 2 device. I think people are in the waiting lobby. Okay. Switch is a layer 2 device. Okay. Switches are used to connect. Switches are multiple devices in a network. Okay. Like we did in case of our CEO, that multiple devices, multiple employees in a network using their devices, they were connected to the CEO. Okay. Switches operate in full duplex mode. Switches operate in, guys, full duplex mode. Switches can unicast, broadcast, and multicast the traffic. Can switches multicast the traffic in real time? As per the theory, switches can, but in practical, if you talk about that, can switches multicast? No, they can't. They consider multicast as broadcast only. So whatever multicast packets they receive, they broadcast it only. Okay. Broadcasting and in routers, they don't broadcast, they do multicast. We'll talk more about this. I'll show it to you in practical as well. Switches are intelligent devices. Switches are intelligent
So Sumit sir,
devices.
it means that L2 switches are not able to do multicast, but L3 switches
Mhm.
are able to do the multicasting, is it?
L3 can. L3 can. Yes. They do multicasting, but they do it as a broadcast only. Okay. If they'll receive multicast traffic, they will broadcast it. That's what they do.
L2
Okay.
switches.
L2 switches. Switches are intelligent devices. Okay, because they have a memory. Because they have a memory. Okay. Switches are in one broadcast domain. I'm just writing broadcast domain. Okay. What exactly it is, broadcast domain and collision domain, we'll talk about them maybe tomorrow or day after. Switches are in one broadcast domain. Switches are in one broadcast domain and have per port collision domain. So this is your switch. Okay. After switch, you have your router.
Sumit sir, one question. So when the layer 2 switches, right, they receive the multicast traffic. right? They must be receiving on some IP addresses. Okay, so once they receive
Absolutely.
that traffic, so that traffic can be converted into a broadcast IP address, which is all F. Is it?
No, 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 no. I'm talking
Okay.
about simple destination IP multicast. When there is a multicast IP as a destination IP, switches broadcast them. Or unless and if it's a first time communication, after first time communication, definitely there will be a MAC address entry created in the MAC address table of a switch, and after that it will do the unicast. So that's why I said now I will show it to you practical. It will give you more clarity what I'm trying to say.
Okay.
First time it will happen. Second time it won't. Second time it will take it as a unicast only. Okay. So these are layer 3 devices. Switches are layer 2, hubs are layer 1, routers are layer 3 devices. Okay. Again, same thing. We can say routers. Theoretically, you can say routers can unicast, router can multicast and broadcast the traffic. But in practical terms, the router can do only these two things. What are those? Unicast and multicast. Router doesn't do broadcasting. You can broadcast within a network in a router. Broadcasting is done only within the network in router. What do you mean by this statement? Again, I have to show you the practical of DHCP, then only you will get to know. Okay, so this thing of yours will be cleared in DHCP, and that the switching thing which I just told, that will be cleared in IGMP. Okay, the more we will progress further, the more clarity of the topics you will start getting them. Okay, routers operate in full duplex mode. Okay, just like your switches, they can receive and transmit the traffic at the same time. Okay, routers are used to connect multiple networks. Routers are used to connect multiple different networks. Okay. What more we can say about routers? Yes, routers take the packet forwarding decision based on logical addresses. What are your logical addresses? IP addresses. Okay, a router process the traffic based on the IP addresses, whether he needs to forward the traffic or not. Okay, then you have, apart from router, you have other important devices as well, like your access pointers, APs. Okay, you can like do some R&D about these as well, access pointers, though they'll not be included in our course. Okay, but these devices are used to connect multiple devices wirelessly like a switch. Okay, just like a switch but in wireless manner. And then we have firewall. Firewalls are used to provide security to your network. Okay. If I talk about firewall, it will be a altogether different course itself. Okay. So we'll not talk more about this device over here. For that, we have different other courses as well. Okay. Because firewall itself is a discussion in itself. Okay. Okay, I hope you got the clarity till this point. Now let's talk about addresses. How many types of addresses we have? We have two types of addresses. Okay. First is your physical address. Okay. Second is your logical address. Okay. Physical address is known as MAC. What is MAC? Media access control. And what is your logical address? IP address. Okay. It is of two types, IPv4 and IPv6. For the time being, we'll talk about IPv4. We have a separate session at the end for IPv6, guys. Okay. Now, if you like want to understand, you can understand like this. I am going to a university. Okay. Let's say you're going to a university, or let's say I'm going to an examination. I'm going to an examination. To enter into an examination, what you need a unique number, your roll number, to enter into the examination. Without that roll number, you cannot enter into the examination. Am I correct? So you need something to access the examination center, and that is your logical address, your IP address. And that unique roll number is allocated to someone, a person. Who is the person? That person has a name. Let's say that person is Sumit. Sumit Singh has roll number XYZ1234. So Sumit Singh is my name, which will not change. Okay, it can't be changed. So this is my MAC address. And to enter into this examination, I will be allocated a unique number, that is XYZ1234. What is that? That is my IP address. A roll number can be changed depending upon the circumstances. So roll number becomes your IP address, and Sumit Singh, it will definitely not change. I can be allocated a different roll number, but Sumit Singh will remain there. So this is my MAC address, or you can say this is your physical address. Okay. Now let's talk more about your MAC address. Okay. So it is also known as, or your MAC address. Okay. It is also known as hardware address. Okay. Other acronym you can also like define for it, because it is dedicated to an hardware. It works at layer 2. it is of 48 bits. It is in hexadecimal format. How many of you are aware about hexadecimal format? Is there anyone in the session who is not aware about hexadecimal format? Please unmute yourself and just say that I'm not aware. What is hexadecimal format? If not, I can explain it to you guys. I'm absolutely fine with it.
Yes, Sumit, if you could just explain that.
Okay. Okay, fair enough, guys. So we have different systems of counting. Like you have binary, you have decimal that we use. Then you have hexadecimal. These are the three major systems of counting that we are using. Okay, binary has only two values, 0 and 1. That's it, 0 and 1. Hexadecimal number system is something what we use. Okay, it has digits ranging from 0 to 9, and then you write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then how do you write 10? 1, 0, 11, 12, so go on and on and on. Hexadecimal is like 0 to 9. Okay, 0 to 9 and then A to F. Okay, so 0 to 9, your A is your number 10, B is your 11, C is your 12, D is your number 13, E is your number 14, and F is your number 15. Then F onwards, you will have 16. So how 16 is written in hexadecimal? 1, 0. 17 will be written as 1, 1, just like this. So it will go from 1, 2, 1, 3 up till 1F. 1F will be my number 30. And then the counting will start from 2, 0. That will be my 31 in decimal. Okay, 21. That will be my 32 in decimal, and so on and on and on and on and on. So that's how counting happens in hexadecimal format. So when I'm saying that my MAC address is of 48 bits hexadecimal format, so that means it has 48 bits, and the numbers in those 48 bits will be represented in the form of hexadecimal, which is 0 to 9 A to F, like this. I'll give you an example as well. One more thing, every character is of 4 bits each. So example of hexadecimal is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, AB. So this is a type of a hexadecimal format MAC address. Okay, you can write it anyways. Okay, this is the Cisco's format of writing. This is Cisco's format of writing. Okay, Windows format is like this. Format can be anything. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 dot 7, 8 dot 9, 0 dot AB. So Windows write it like this. Okay. Linux also uses the same pattern. Okay. So you can write it anyways. Okay. And each character is of 4 bits. Okay. So how many total characters we have? 1, 2, 3, 4. 5, 6, 7, 8, 9, 10, 11, 12. So total 12 characters we have, and each character is of 4 bits. So 12 times 4, it comes out to be 48 bits. Okay. How many bytes are there in one bit, or how many bits are there in one byte? One byte is how many bits? Anyone?
8.
8
bit.
bits. One byte is 8 bits. So I have total 48 bits. So how many bytes? 6 bytes. So this is the value of MAC address. 6 bytes MAC address. Is it okay? Okay, guys. This is about basic about MAC address. We'll talk more about it, but tomorrow, guys, let's wind up our session for the day now itself. Okay, I'll discuss more about MAC address, IP address, subnetting tomorrow. Okay, so tomorrow is going to be very important session for you. So I hope we have maximum participation by tomorrow. And more importantly, for tomorrow only is not audible, let me know. Okay, I will wear my headphones. Right now, I'm not using my headphones.
Yeah, okay,
It's
sir.
in hexadecimal format. I hope hexadecimal format is clear to everyone. 0 to 9 and A to F. Okay. Example 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, A. Okay. Every character is of 4 bits each. Okay. If there are 4 characters, 4 bits of characters, total 12 we have. So overall size is 48 bits, which is also equivalent to 6 bytes, as 1 byte is equals to 8 bits. Till this point, we ended our discussion yesterday. Okay. Okay. So now let's talk about some more detail of MAC address. See, MAC address, which organization assigns MAC address? Okay. IEEE. IEEE. Okay. The job of the IEEE is to make sure that MAC addresses are utilized by different vendors in a proper manner. So to achieve that, it keeps a record of organization which makes NIC card. Okay, which makes NIC. And first 24 bits of your MAC address. First 24. When I'm saying first 24, that means I'm talking about this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, A. I think someone is in the lobby. Okay. So that means this part. This part. Okay. So IEEE keeps the first 24 bits are assigned by IEEE to the vendor. Okay, in any MAC address, the first 24 bits are vendor specific. So not vendor specific, assigned to vendor by IEEE. Okay, they are like identification of the vendor. Okay, these first half 24 bits, they are assigned by IEEE to the vendor who is building your device. So that is why they are also called OUI. Now, what is OUI? OUI stands for organizational unique identifier. Okay. If you want to understand this more, okay, you can take this example. Okay. In a university, okay, I went to my college in 2011, let's suppose. Okay, though I not reveal the real year, but let's take I went into my college in 2011. Okay, I did my graduation, let's say, in electronics and communication engineering. Okay, so my class roll number was like this 2011 ECA, then let's say 1081. Let's say it was like this. Okay, where 1081 is my roll number, and this first half was same for all of my classmates. Okay, like the person who is sitting prior to me or after me were like this 82, 83, so on and on and on. And then again 1001, let's take, he was the first candidate of our class who has to do the vivas first, who has to give the vivas first. So he was like the real hero as usual in degree college. So that's how the things are. So the first few bits, like first few digits, what they are class identifiers. They are same for all the class, right? So same thing IEEE does for a vendor as well. Like for example, it is assigning, let's say 01111 to Dell. Okay, you can check it the real values online. I'm just taking the hypothetical values. Let's say 0, 2, 3, 5, 6 it assigned to Cisco. So all the devices will have first 24 bits of that vendor as like this only. Okay, if you check their MAC addresses of their NIC cards, so you will find first 24 bits as same. So what exactly differs is last 24 bits. So that is up to the vendor to play with the last 24 bits. Okay, manufacture devices and assign the numbers according to last 24 bits, but first 24 bits will be same for a particular vendor that is given to him by IEEE. Am I clear? Am I clear, guys? So they are known as OUI fields, organizational unique identifier. Okay, now let's break our MAC address. Let's say this is my MAC address. Okay, let's talk about this first character of MAC address. Now, guys, tell me, as I told you that every character in a MAC address is of how many bits? It's of 4 bits each. So if this 0 is 4 bits, how am I supposed to convert hexadecimal to decimal? How many of anyone is there who is not aware about the conversion in the class? that how to convert hexadecimal to decimal, decimal to hexadecimal, or vice versa? Anyone not aware of it? Guys, if not, please let me know. I'll explain. Otherwise, I'll go ahead.
I'm not aware about that.
You're not aware? Okay. Okay. Let's talk brief about the conversions. Okay. I'll not talk much, but at least let me give you a small overview. Okay. Conversions. Anyhow, for IP addresses, we require conversions as well. So you need to be very pro in conversion. So let's talk about the decimal to, first let's talk about decimal to binary conversions. Then we'll talk about hexadecimal to binary, which are required for you. These are the two that are mainly required by you guys. Okay. Okay. So guys, to convert decimal to binary, you need to be aware about the power of twos first. 2 to the power 0 is 1. 2 to the power 1 is 2. 2 to the power 3 is 4. 2 to the power 3, 8. 2 to the power 2 is, wait, I missed 2 to the power 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 32. Not 32, 16. 2 to the power 5 is 32. 2 to the power 6 is 64. 2 to the power 10 is 128. 2 to the power 8 is 256. 2 to the power 9 is 512. 2 to the power 10 is 1024. 2 to the power 11 is 2048. 2 to the power 12 is 4096. 2 to the power 13 is 8192. I don't think you require more than this. Okay. So you need to be aware about these values. Okay. Now, if I'm saying convert, if I'm saying convert 100 base 10 means decimal system, the normal system in which we are doing our counting. Okay, base 10. So I want to convert 100 base 10 into, that is decimal to binary. Okay, for this you need to lay power of 2 from right to left. Okay, right to left. So that means 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. I guess it's more than sufficient. What exactly it is? It is 128, 64, 32, 16, 8, 4, 2, 1. Now I want to make 100. How can I make 100? If my this bit 2 to the power 7, that means my leftmost bit, if I set it 1, so it will be more than 128. Let me take this as 0. Let me take this as 1. 64 plus 32, 96 plus 4. So if I add 64, 32 and 4, what the value comes out to be, my value will be 100. So rest of the bits can be 0. So if I convert 100 decimal to binary, it will look like this. Base 2. Is it clear, guys? You just need to look for the bits which will add 100. The rest of the bits can be 0. Let me show you with another example. 235 base 10. 235 base 10. Convert this into binary. Anyone? Anyone want to try? Convert 235 into binary. Again, do it like the same methodology. 6, 2 to the power 5, 2 to the power 4, 3, 2, 1, 0. 128, 64, 32, 16, 8, 4, 2, 1. Now 235, definitely 128 will come. I need 128 to become 235 because it's more than 128. Okay, let's add 64 as well. 128 and 64, what will be? 192. 32, yes, I still need 32. So 64, 32, what will be, it will tell here 224. Now, what more I need? 224. I have reached over here 224. See, 128 plus 64 will be 192. If I add further 32 into this, that will be 224. Now, after 224, if I add 16, it will become 240. So I cannot add 16. So 16 will be 0. So in 224, if I'll add 8, it will become 232. So that means yes, I can add 8. I need to reach 235. If I add 4 into this, it will be 236. So 4 also is not an option. Okay, so 4 is also 0. So 232, if I add 2 in it, it will be 234. So this is 1 plus 1 more of the last, that will become 235. So this is the binary conversion 111011011. Is it clear? Is it clear, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Let me show you one more last. 192. Okay. 2 to the power 7, 2 to the power 6, 2 to the power 5, 4, 3, 2, 1, 0. Okay. 128, 64, 32, 16, 8, 4, 2, 1. I need 192. So I definitely require 128. So 128 is done. If I add another 64 to it, it will become 192. Over here, I'm reaching 192. So rest all bits 0. So value is, that's it. Done. So this is your decimal to binary conversion. Now let's talk about Excel decimal to decimal conversion first. Not decimal, binary first, let's say. Decimal we'll take after this. Guys, before going ahead, could you convert 255 decimal into binary? Anyone?
That would be all one.
That will be all one. If I make every value 1, that will be 255. That means all bits are occupied. So hexadecimal to binary. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A is your 10. B is your 11. C is your 12. D is your 13. E is your 14. And F is your 15. Right? One hexadecimal character is equals to 4 bits. Okay, it is also known as one nibble. If I'm telling you 8D, okay, base 16 means whenever you will see base 16, you can straight away tell that base 16 stands for hexadecimal. Okay, 8D. So hexadecimal conversion is one of the easiest conversion, guys. Why? Because in hexadecimal to binary conversion, you simply need to, convert bit by byte by byte, every character by character. For example, I have 8D. I don't need to do anything. I simply need to convert every single character into their individual binary numbers. For example, you have 8. If I convert 8 into binary, let's say 2 to the power. So for hexadecimal, you require only 4 values. Only these 4. That's it. So this is 8, 4, 2, 1. So 8 is 1, 0, 0, 0. So 8 is 1, 0, 0, 0. Now you need to convert D separately. D is your 13. So for 13, I need 8 plus 4, 12, 0, 1, 13. 1, 1, 0, 1. For example, you have B9, base 16. What is B? B is your 11. Okay. How can you write B? 8, 1, 0, 1, 1. And what is 9? 1, 0, 0, 1. Is it clear? Is it clear, guys? What about all values? Okay. Let's go to our next conversion.
सर एक डाउट था
बताओ.
सर ये जो हमने पावर लिया है 2 to 3 2 रेस्ट 3 अगर ये हमें 8 था ये जो फर्स्ट एग्जांपल आपने लिया था 8D बेस 16 अगर 8 से ज्यादा कुछ होगा तो हम वो पावर को आगे आगे जो वैल्यू है 2 की लाइक 2 रेस्ट टू 4 2 रेस्ट टू 6 ऐसा लेंगे आगे या फिर यहाँ इतने ही तक लेंगे 2 रेस्ट टू 3 तक
आप you can take that in decimal to binary conversion, but in hexadecimal to binary, it's not required. Because in hexadecimal to binary, you need to convert every single individual character. And an individual character is not more than 4 bits. Okay, you can take anything. Let's suppose, let me take a big number. Okay, 1, 1, 6, 7, D4. Okay, if I have to convert this into binary, so I have to do it character by character. So first I need to convert this 1. 1 is 0, 0, 0, 1. Next one, again 0, 0, 0, 1. Now number 6. Okay, 8, 4. So 6 is 0, 1, 1, 0. 7. So it will be 0, 1, 1, 1. D is your number 13.
1 0 1
1, 1, 0, 1. 8 and 4, 12 plus 1, 13. Okay, then your 4. 4 is like your 0, 1, 0, 0.
Got it, sir.
Is it clear?
Yes, sir. Thank you.
Okay.
मीन सर 2 to power 3 तक ही कंसिडर होता है सर.
In hexadecimal, it will be considered till 2 to the power 3.
Okay.
Okay. So where were we? We were discussing MAC addresses. Let's talk about this first character. Okay. Convert this hexadecimal into binary. I'm asking you to convert only one character, that to 0. Anyone? Guys, 0 is 0, 0, 0, 0.
0, 0, 0.
If I'll take, it is 0, 0, 0, 0 in binary. As simple as that. Okay. Now, if I convert this entire into binary, so the first 4 bits definitely will be for our very first character, right? So this is known as leftmost bit. This is known as second leftmost bit. If the value of leftmost bit, okay, this, okay, if the value of leftmost bit is 0 and if the value of the leftmost bit is 1, then what does it means? It has a specification, guys. If it is 0, that means it is assigned to an individual device. That means that MAC address is associated with individual device. If it is 1, then that means this MAC address is assigned to a group. That means your multicast group or your broadcast traffic. For your broadcast traffic as well, the leftmost bit will be 1. Okay. If your second leftmost bit if this value is 0 and if its value is 1, then what does it means? If it means 0, then that means this device is this MAC address is assigned by IEEE. This MAC address is assigned by IEEE, and if it means 1, then that means this MAC address is assigned by local authorized government entities. Example, DRDO. Is it okay? Is it understandable? Okay, so these are the things that you need to know about your MAC addresses. So I hope MAC addresses are pretty much clear to you guys. In case you can go through the recording once again, and in case you have any doubts, you can let me know. Okay. Now let's talk about logical addresses. Now let's talk about logical addresses. What is a logical address? We'll talk about IPv4 for the time being. IPv6 we'll talk later. Okay, I'm talking about IPv4 address for the time being. So what exactly is IPv4? See, MAC address is something which is encoded in your NIC card. You cannot change your MAC address of a NIC card. You can replace like your NIC card by some very hard means, but you cannot change the MAC address of a NIC. Okay. But what is a logical address? Logical address is something which is not confined to a user or which is not confined to a machine. It depends on the, environment to environment. A different IP address can be assigned to you. It is not fixed. But how will you understand this? You will understand this by going or by doing more and more practicals, guys. Okay. Before we have 32-bit dotted decimal values. What was the size of MAC address? What was the size of MAC address, guys?
48 bits.
48 bits. So IPv4 is 32 bits. IPv4 is 32 bits and it is in the dotted decimal format. For example, 10 dot 10 dot 10 dot 10. Okay, every dot here and there is known as octet. Okay, this is called as first octet. Okay, this is called as second octet. This is called as third octet. And this is called as fourth octet. So every single field is known as octet before and after the dot. And every octet have a value range from 0 to 255. Okay, 0 to 255. Now you can relate it over here as well. I'm saying every octet can have a maximum value of 255. We discussed above as well in conversions. I somewhere wrote 255. Yeah, here. If you convert 255 into decimal, 255 decimal into binary, it is all ones, right? So guys, if I need to represent 255, how many minimum bits I need? I need a minimum of 8 bits. Okay, so that means every character before and after a dot, which is known as octet in an IPv4 address, is of 8 bits. So likewise, we have 4 octets of 8 bits each. So that is why the size of an IPv4 header is 32 bits. Okay. Now, after this, we have classes of IPv4. If you are a fresher, very important as far as your interviews are there. Class, range, number of network bits, number of host bits, and then the usage. If it is a class B, sorry, if it is class A, okay, I'm talking about the range of the first octet. I'm talking about range of the first octet. If your first octet lies between any values from 0 to 127, it is of class A. If your first octet value lies between 128 to 191, it is known as class B IPv4 address. Okay. If your first octet value lies between 192 to 223, it is class C IPv4 address. Similarly, class D is your 224 to 239. And last but not the least, class E, that is your 240 to 255. Okay. Number of network bits 8, 24, 16, 16, 24, 8. No concept of network and host bits. These are unicast range. This is also unicast range. Unicast range, unicast. This is also unicast range. This IP range 224 to 239. 224 to 239. This is known as multicast IPv4 range. Okay, and 240 to 255 is reserved for R&D purpose. Okay, this is reserved for R&D purpose. Now, when I'm saying, I hope this is clear. This should be clear. This should be clear. What do you mean by network and host bits? What do you mean by network and host bits? Network and host bits are also known as on and off bits. To understand them, we need to understand the concept of subnet mask first. Okay, so let's finish our discussion on IPv4 first. Then I will introduce you to the subnet mask or CIDR values. Okay, so just wait for 15-20 minutes, or maybe after the break, I will discuss on network and host bits. Okay. So just wait for 15-20 minutes. I'll clear your network and host bits as well. First, let me finish IPv4. You need to be aware about the few reserved IPv4 addresses. Reserved IPv4 address range. First, 0.0.0.0. It is reserved for unknown IP. For freshers, they haven't seen it, I know, but those who are experienced candidates, guys, if you would have taken Wireshark capture, or even if you have run a basic simulation of ARP in Packet Tracer, you must have seen this IP 0.0.0.0. This is generally used when you don't have any IP to assign. In ARP, you can see, in hello messages of routing protocols, you can see. Okay, so guys who are freshers, guys, 0.0.0.0 IP is assigned, is not used in production traffic. Okay, this is not used in production traffic, that is any live traffic. It is not used in any production traffic, but 0.0.0 is used for your control plane traffic. Now, who will tell me what is control plane and what is data plane? and what is data plane traffic? Who will tell me this? Control plane and data plane, very basic fundamental question.
Sir, routing protocols, hello messages are called control plane, right?
Yes, they are called, but why they are called control plane? There must be a reason.
To manage the device config and the control own traffic, and data plane for device traffic passes through that.
Control plane manage route table and all the details data. Data
But
plane
you are saying they manage route and all, but what about BPDUs? What about DHCP messages? What about your IPsec messages? What about your SSL handshake messages? What about them? Guys, control plane traffic is a traffic which is generated by the device for the device. By the device for the device. Or in some books to the device traffic. Sometimes it is written like this. When I'm saying device, what device I'm talking about? I'm talking about devices which are involved in your network establishment, like your router, switch, firewall, whatever traffic they are exchanging between them for the purpose of network establishment is control plane traffic. What is data plane traffic? Traffic generated by end devices to access a service. Data plane traffic is something which passes from the network established by control plane traffic. Is this clear, guys? So this 0.0.0 is used by control plane, okay, when there is a network establishment. Okay, more clarity. Definitely, you are saying it is used in routing because routing traffic itself is a control plane traffic. Your hello messages, your the moment they are initiated, like in OSPF, hello message. In OSPF, what are the states of OSPF? Anybody remembers?
Yes, sir. Downstate, you need two-way extract exchange.
That's it. So in init state, what happens? Hello message is exchanged. The moment hello message is exchanged first, its neighbor ID is neighbor router ID field is empty. It is not available because it hasn't discovered its neighbor yet. Okay, for the fresher guys who are doing it for the first time, if they don't understand it, it's absolutely fine because I will show you practically as well. I'm discussing it with those who have already worked in the domain. So in control plane traffic, in the hello message, what it does in init state, a hello message is generated. Just observe the capture sometimes. I will show you the captures in class as well. In that capture, you won't see, okay, you won't see anything in the router neighbor ID because neighbor is not discovered yet. But I have to generate my first hello message. So in that case, the neighbor ID is kept like 0.0.0.0. Okay, so that's how it is. Apart from that, we have Another reserved IP, second reserved IP you have is 127.0.0.0 to 127.255.255.255. This entire range is reserved for loopback testing. What is loopback testing? Anyone? Guys, if you have worked on servers or end applications or anyone with a development background, guys, you must have done this. https://127.0.0.0.1 in a browser. What is the purpose of this? Why are we doing it? Sometimes you will see you are going on a call with your customer care for your fibers or for your internet or for your modem complaint. So they ask you to ping 27.0.0.0.1 apart from 8.8.8.8.8.8.8 is stupidity. But why do they ask you to ping? If he's a genuine person, he will ask you to ping 127.0.0.1. Why? Why? What is this loopback testing? What is it used for?
To check our records whether it is working or not.
Self-testing.
Self-testing, but for which purpose?
For device check.
No.
Or they get back to your response or not.
Because your own stacks are working or not, like this.
Testing of TCP IP protocol working in your device or not.
Okay.
Interview question. Okay. Remember this next time. Third.
Sir, sometimes we are pinging ping localhost. So is it same? Like
yes. Why localhost is ping to check the TCP IP protocols are working fine or not in your device. If something is wrong with the ping of 127.0.0.0.1, then that means your Wi-Fi driver is down, is gone. Then you need to change your drivers. PIPA. Somebody asked about a PIPA yesterday as well. What exactly is a PIPA? Automatic, private, IP allocation. This is a PIPA. Automatic, private IP allocation. What is the range of a PIPA? 169.254.0.0 to 169.254.255.255. This is known as a PIPA range. Why a PIPA IPs are assigned? Why? There are two ways of IP assignment to a device. Okay, first is static, second is dynamic IP allocation. What is the difference between the two? Dynamic IP allocation is automatic IP allocation. Okay, how it happens, we'll talk in DHCP, but you must have observed that whenever you turn on your data in your mobile or you turn on your Wi-Fi, the moment you do that, you get connected to internet and you get an IP automatically. Static IP is going into your network settings, and assigning manually. And assigning manually. For example, in okay, if you want to like assign yourself a manual IP, you can do ncpa.cpl. So I'm right now connected to Dexter. Let me see the properties. In the properties, you have this option of Internet Protocol version 4. Double click on it. Right now, what methodology is selected? Obtain an IP address automatically. So the moment I'll turn on my Wi-Fi, I will get an IP address automatically. But if you want to get a manual assignment, you can choose the second option. Okay, you need to provide the IP address, subnet mask, gateways. Guys, please be on mute. Yeah, thank you. So you need to assign IP addresses automatically. Okay, but make sure that you are assigning from the same range as given to you by the Wi-Fi. Otherwise, you will not be able to access internet. Okay. So this is a self IP assignment one way. Second is your private IP range. Next, you have your private IP range. Sorry, guys. We have three private IP ranges. For class A, the private IP range is 10.0.0.02, 10.255.255.255. For class B, the private IP range is 172.16.0.02, 172.31.255.255. For class C, the private IP range is 192.168.0.02, 192.168.255.255. So this is a private IP range. If you will check the IP address allocated to you, it will be one of the addresses in these three ranges only. Okay, let me show you how to check your IP address assigned to your device. Again, open command prompt. Use the option IP config/all. Okay, if I do IP config/all, these all are my network adapters. Okay, let me see the physical network adapter, not the VMware one. Okay, this is my LAN adapter. So what is the IP address allocated to my device? 192.168.29.185. This is the IP address allocated to my device. So in a LAN network, in any of the LAN areas, you will see only these three ranges only. Okay. For internet, to access the internet actually, you need public IPs. What are public IPs? Remaining all IPs are public IPs. Remaining all IPs are public IPs, which are used to access internet. Guys, do you think that the IP address allocated to me 192.168.29.185, it is this IP which is providing me internet? No, that's not the case. So how internet is actually accessed, that we need to discuss more and more in networking. That is what we are here to study. Okay, so that you will learn gradually, that how it is used to access the internet. Okay, so I was talking about a PIPA range 169.254.0.02.254.255.255. So in case I have chosen the option of dynamic IP allocation, okay. In case dynamic IP allocation is chosen in your scenario and you are not getting any IP from DHCP server. So guys, those who are new to the domain, DHCP server is the server which allocates IP addresses to us. Okay, so if I have turned on my Wi-Fi and I'm trying to reach out to DHCP server to get an IP address and I'm not getting any response from him, so I will allocate this range automatically to my device, one of the IPs from this range. Until the time you are allocated to a PIPA range, you cannot access internet. Again, as I told you, only public IPs are used to access the internet. It's not like that we cannot access internet from other IPs, but there is a standard in the industry that is used. Okay, to abide by those standards, the network is built in such a way that internet can be accessed only by public IP. This is also an interview question. Once an interviewer asked me why we cannot access internet from private IPs. We can access internet from the private IPs, but we choose not to. We are abiding the standards of industries, and as per the industry standards, public IPs are used to access the internet to save the IP addresses with a concept called as network address translation that we'll discuss little later. So this is about IPv4 addresses, guys. It's almost one. Let's take a 20 minutes break. Okay, let's reconnect at 120 exactly. And then we will talk about subnet mask, network bits, host bits, CIDR values, and then we'll start our subnetting. Okay, let me stop my recording. Discussed IP address. Okay. Subnet mask. Okay, what is subnet mask exactly? Anyone? We all have discussed, like I know most of you must be aware about subnet mask, but what exactly it is? How do you differentiate subnet mask from IPv4 address? Because like IPv4 address, it is also 32-bit dotted decimal number. It is also 32-bit dotted decimal number. How do you differentiate this from IPv4 address? You differentiate like this. This 32-bit number specifies how many network bits, okay, or you can say constant. In some books, this is also referred to as on bits, okay, and how many host bits, variable or off bits in an IP, in a subnet, in a subnet. For example, these are the default subnet mask of every class. Okay, A, B, C. Class A has default subnet mask 255.0.0.0. Class B has default subnet mask 255.255.0.0. Class C has default subnet mask 255.255.0. 255.255.255.0. These are the default subnet mask of every class. What do you mean by 255? 255 means all 8 bits are set to 1. Right? So how many bits are set to 1 in class A? 8. So that means 8 are on bits. Or you can say 8 are constant bits. They will not change in a subnet. Okay. Similarly for B, we have 16 bits as on and 16 as off. 16 bits on and off each. Over here, 24 on, 8 off. That means only 8 bits, last of 8 bits will be variable in a subnet mask. First 24 bits will remain same in all the host IPs that are associated with a subnet mask. For example, if I'll take IP address always has a subnet mask associated with it. Okay, and IP is incomplete without a subnet mask. We always write an IP like this 10.0.0.0.1 with subnet mask 255.0.0.0.0. So what does it exactly means? It means that 255, that means first octate's 8 bits. That means this 10, this 10, this 10 in a subnet or in a network will remain same. What exactly will differ? These octet values. That means 10.0.0.2, 0.3, 1.0, 10.0.3.250. So like that. So first octet will be there. So how many constant and how many variable bits are there in an IP address? They are defined with the help of subnet mask. What is the value of my subnet mask? A, B, C has default subnet mask of 255. And B has 255, 255.0.0, and C has 255, 255, 255.0. After subnet mask, we have one more concept, CIDR. What is CIDR? CIDR is classless inter-domain routing. What is it used for? CIDR. CIDR are simply the slash notations of subnet mask. Okay. Simply say network bit values. How many network or on bits are there in a subnet mask? For example, if I say class A has subnet mask value of 255.0.0.0, right? So what will be its slash notation? Slash notation will be /8 because over here 8 bits are on bits. In class B, we have 8 bits of first octet, then 8 bits of second octet, 8 plus 8, 16 bits. Similarly, in class C, same value is /24. So what is the better way to write your subnet mask? The better way to write is through a class notation, slash notation, like this, /8. Okay. Now, these are all we are talking about default values, 8, 16, and 24. What about anything in between them? What I'm trying to say, /8 is 255.0.0.0. But why only 8 bits? Why I can take only 8 bits? Why not 9? Why not 10? All are possible. Okay. What, according to you, should be the subnet mask value of /9? /8 is 255.0.0.0. So what should be /9? Anyone? Any guesses?
225.128.0.0.
Now the question is how? Question is how? /8 5678 dot 0.0.0. /9 is 8 bits of first octet, 9th bit of second octet, so these 8 is 255. Again, if you remember that thing, 2 to the power 7, 2 to the power 6, 2 to the power 5, 4, 3, 2, 1. You are saying this is 2 to the power 7, 2 to the power 6, 5, 4, 3, 2, 1, 0. So 2 to the power 7, that is set to 1. So what is 2 to the power 7? It is 128. So what is my value? 255.128.0.0. Is it clear to everyone how this 128 came? Yes or no?
Yes, sir.
Yes.
So then tell me what should be /10? 255, first 8 bits, done. Then after that,
192.0.0.
absolutely.
192
How? 128, that will be
plus
1,
64.
1. 128 plus 64. Similarly, /11, 255 dot 224
224.
/12, 255 dot 240.0.0. /13 will be 248. /14, /15, /16, /17. Now what should be /17? 255 for first 8, 255 second 8, 8 plus 8, 16.
128.0.
Absolutely, 17th bit. I hope everyone is clear with this. If anyone is stuck, please let me know. I'll explain again how these numbers are coming.
Okay, I'll take silence as no. Slash 18 will be your 255.255.192.0. Slash 19 will be your 255.255.224.0. Slash 20 will be your 255.255.240.0. Slash 21 will be your 255, 255, 248.0. Slash 22, 252.0. Slash 23 is 255.255.254.0. And slash 24 is 255.255.255.0. Slash 25, 255.255.255.128 slash 26, 255.192 slash 27, 255.255.224. I'm writing each and every subnet mask values because I want you guys also to write in your notebooks or on a piece of paper. .240 slash 29 is 255.255.255.248 slash 30 is your 255.255.252 slash 31 is your 255.255.254 and slash 32 is your 255.255.255.255. Okay, so that is how your CIDR notations work. Guys, freshers, we learn subnetting, but experienced candidates, if you are part of my any previous batch, you must be aware about one thing that I can solve any subnetting within 5 seconds. It takes me 4, 5, or 6 to 7 seconds if it is little complicated, but not more than that. Entire visualization, like entire subnet mask, all the valid possible hosts, they all come into my mind instantly the moment I see a subnet. Why it happens? Because I have practiced it so much. You can't even like realize how much questions of subnetting I have solved. It's close to 5,000, guys. I can guarantee you it's close to 5,000 questions. How to achieve that feat? How to do that? First step in achieving that is you should be aware about every single slash notations. You don't have to calculate the slash notations. Like someone asked me what is slash 28 and I'm doing it in my mind and I'm uselessly wasting 20-25 seconds in calculating that. No, you should instantly answer that 2 slash 28 is 255, 255, 255, 240. Instantly you should answer. So just do one thing, take a piece of paper of your notebook, write all the slash notations. Okay, if you can learn them, well and good, because you know the concept, how they got into that. After doing that, just paste that piece of paper anywhere in your premises where you say, I'll tell you, when I was in class 11th or class 12th, I wrote, I think in class 11th in maths we have that thing, what do you call that, trigonometry. So what I did, I wrote all the trigonometric formulas on a paper, and I paste that paper on my toothbrush cabinet, so that every morning whenever I have to wake up, I'll go in front of that cabinet, I'll take out my toothbrush, and while brushing my teeth, those formulas are in front of me. I'm going through those formulas every single day. So what happened? After 10-15 days, those formulas were in my head. I still remember sine A plus sine B, sine A, sine B plus cos A, cos B. I still remember those formulas. Why? Because I did that. So that's how you can achieve it. You just have to work something out of the box. But if you want to solve subnetting very quickly, you need to plan it like I told you. This is the first step in order to solve subnetting very quickly. Now, what exactly is the subnetting? I'm talking a lot about subnetting. Even you don't need to write it on a piece of paper. Okay. What you guys can do, you guys can simply take the screenshot of my screen, take a couple of screenshots and write it. Definitely better approach is to write it in your own notebook, but you can also take the screenshot from the lecture. That also you can do. Now let's talk about subnetting. Let's do one thing. Subnetting is a new topic altogether. Let's do subnetting next Saturday. Okay. Next Saturday is dedicated to subnetting only. So I'll take a marathon class next Saturday. Okay. That class will be of 3 hours. And in those 3 hours, we'll cover subnetting only. So that will be like a subnetting workshop as well. If anyone wants to attend the subnetting workshop, I'll talk to Rohan that if he can do that. So let's do that as well. Okay. 3 hour subnetting. I'll make you pro after 3 hours. After that, you need to practice on it yourself. Is it okay with everyone?
Yes.
Yes,
Yes,
sir.
sir.
Okay. By next Saturday, I want all of you guys to remember all the slash notations. Okay. If I'm asking slash notations to you guys, you should answer.
Okay. So we discussed all slash notations in our last class. Okay. We discussed why slash notation is required. Okay. To define how many variable and how many constant bits will be there in our IP address. So last class we discussed slash notation. Okay. We discussed requirement of subnet mask. Okay, requirement of subnet mask to define on and off bits or constant or variable bits. Then we discussed all the slash notations from /8 to /32 and their subnet mask respectively. So now we will discuss subnetting. First of all, what exactly is subnetting? Subnetting is a methodology. Subnetting is a methodology in which a big network is divided into smaller networks. Small networks or subnets, whatever you say. Basically, we have subnetting classified into three broad categories, three main categories. Then we have inferred categories after that. Okay, the three categories are class C subnetting, class B, and class A subnetting. We'll start our discussion with class C subnetting. So guys, if you have joined from your laptops, phones, it doesn't matter. But this point onwards, everyone, please take out your notebooks and have a pen with you, because we will practice as well. We'll practice a lot. Okay. So let's start our discussion by class C subnetting. Again, I request all of you to bring out your notebooks, pen, paper, whatever. Okay. Let's suppose we have class C subnet like this 192.168.100.0/25. Let's suppose we have a subnet like this. So to do subnetting, you need to follow the following steps. Step number one will be to calculate the subnet mask that is given to you. Guys, we will study the long method first. After that, I'll tell you the shortcuts. Okay. Subnet mask for /25 will be 255.255.255 dot. What should be the value of the fourth octet? 128.
128.
Step number one is done. Step number two to calculate subnetting is to calculate the block size value. Block size. Now, what exactly is block size? It is a reference size only. It doesn't exist in any way, but it is a reference size which tells that from where the next network will start. So guys, always remember one thing: if you want to do subnetting quickly, block size is very important. These two things, subnet mask calculation and your block size calculation, it should be done in your head instantly the moment you see your subnet. Okay, and to calculate block size, again the formula is 256 minus subnet mask octet value which has last one. Okay, that will be 256 minus subnet mask octet value which has last one. What I'm trying to say is, if I'll convert my subnet mask into binary, how will it looks like? It will look like this, right? Then that's how it will look like. Yes or no? In the last class we discussed the conversions as well, that how to convert certain numbers into one another, how to convert decimal into binary, binary into decimal, hexadecimal into binary. I hope all of you remember that. So if I convert this subnet mask into binary, it will look like this. Now you can see that I have last one. In which octet I have last one? Last one is in my fourth octet. Last one is in the fourth octet. So that's means I will take the value of the fourth octet. So 256 minus 128, that will come out to be 128 itself. Okay. Now I have step number 3. I hope the first two steps are clear to all of you. Now,
Yes, sir.
step number 3. Step number 3 states, or step number 3 will help you to find number of networks or subnet that will come out of your parent subnet. Number of network or subnets. The formula is 2 to the power n. 2 to the power n, where what is n? N is number of host bits changed into network bits. What do you mean by this? If you remember, in the last class, we discussed the concept of on and off bits, constant and variable bits. So host and network bits are the technical, nomenclature for them. When I'm talking about on bits, they are known as network bits, or your constant bits, you can say. They don't change. Variable of, they are known as host bits. So in terms of network terminologies, they are known as network and host bits. Now tell me one thing, what was the default slash notation of class C? What was the default slash
24.
notation of class C? Exactly.
Slash 20.
Slash 24. So default slash notation we have slash 24. That means in a class C network, by default, we are supposed to have 24 network bits. Whatever is your slash notation is your on bits or network bits, and remaining 8 should be your network host bits, right? But in my scenario, what I'm given, in our scenario, we are given slash 25. So that means how many host bits are converted into network bits. In my case, it was supposed to be 24, but how many I have right now? 25. What is the difference between the two? 1. I hope you are clear how this 1 comes out. I was supposed to have 24 network bits, but right now how many network bits are given to me? 25. What is the difference between them? 1.
1.
That this one is your n. This one is your n. So how many total subnets will be there? How many subnets we can create out of your parent subnet? So that will be 2 to the power 1. That means 2 subnets we can create. Now let's talk about step 4. Number of valid host per subnet. That means these subnets or networks that we will have, how many valid hosts will be included in between them. So that is achieved with the help of a formula 2 to the power h minus 2, where h is number of host bits. So how many network bits I have? 25. So how many host bits I'm supposed to have? If out of 32 bits, I have 25 as network bits, then how many host bits I'm going to have? Out of 32, 25 are network. Then how many host bits?
7.
7. 2 to the power 7 minus 2. So that is 126. So total 126 valid host or IPs will be inside these two networks. Now, how to calculate these two networks? To calculate these two networks, first you write the network as it is 192.168.100.0. 100.0, that will be your first subnet. Now in step number 3, we see 2 to the power 1 2, so we are supposed to have two subnets. We can create two subnets out of it. So this is the first subnet. So what should be my second subnet? In order to find second subnet, you don't need to do anything. Okay, you just simply go for your block size. What is a block size? My block size is 128. Now I took block size from which octet? I took my block size value from fourth octet. Yes or no? I took my block size value from the fourth octet. So what I'm going to do in the subnet itself, I will add the block size into the octet from where I took it out in the first place. That is the fourth octet. So my second subnet will be 192.168.100.128. What did I told you? The moment I discuss block size, that it tells you where your other subnet is going to start. Okay, you simply need to add the block size value in the octets to calculate the recurring subnets. So this 128 is going to be my second subnet. The first subnets are also known as network IDs of their respective subnets. So this is network ID of first subnet, and this is network ID of second subnet. This is network ID. What will be the first valid host? If I start subnetting, so the first valid host is going to be 100.1. Second valid host will be 168.100.2. So this counting will go till 126. How many hosts we are supposed to have in the step 4? 126. So it will go till 126. Okay, so this is my last valid host, and this 100.1 is my first valid host. This is network ID. And 192.168.100.127. Then what about this? Because my second subnet is starting from 100.128. In between them, they have one IP. So what about this? This is known as broadcast IP of first subnet. What do you mean by this? Guys, just give me a moment. Someone is at my door. Just a moment. Okay, so this will be the broadcast IP of first subnet. Now, what do you mean by broadcast IP of first subnet? That means if something is forwarded on this IP, then it will be broadcasted on all the valid hosts from 1 to 126. Same thing will go for my second subnet. Okay, 128 will be my network ID. 192.168.100.129 will be my first valid host. Now, if you think logically as well, that why can't I have more network IDs? Why can't I have more network IDs? Third network, fourth network, why? My block size is 128, right? If I add a 128 again to my fourth octet, because I took out the block size from my fourth octet. If I add another 128 to my fourth octet, so 128 times 128 will turn out to be 256. And again, as I told you at the starting of the session, that 256 is not a valid value of an octet. So that is also a reason we are going to have only two subnets, if you think about this logically. So 129 is going to be my first valid host. 192.168.100.130 will be my second valid host. It will go till 126 IP. So 126 IP will finish at 100.254. That will be my last valid host. And if I talk about 192.168.100.255, that will be my broadcast IP of the subnet. Okay, so if I summarize, if someone is having any doubts, he can say right now. And if I summarize the subnetting steps for you guys, because now I will ask you to solve the questions. Step number 1, calculate the subnet mask. Step number 2, calculate the block size, which is nothing but 256 minus subnet mask octet, which has last one. Step number 3 is your number of subnets or networks, which is your 2 to the power n. Then you have number of valid hosts per subnet, which is 2 to the power h minus 2. These are your steps. So we have solved one question of class C. Now I want you guys to solve one more question of class C on your own. Let's take 200.200.0/26. What is the time right now? It's 12:20. I'm giving you exactly 10 minutes because initially it will take some time. Okay, by 12:30, I need the answers. Okay, answers of these 4 steps plus the calculation part. Okay, so guys, take out your pen and papers and start solving. Steps
Yeah,
are
okay, sir.
right in front of you. In case you feel any doubt, I'm right here to help you out. But guys, if possible, all of you please solve.
Hello, is someone speaking or like we are doing some stuff because I just joined right now?
We are supposed to solve the subnetting. I just,
Okay.
yeah. Anyways, I'm about to discuss in next couple of minutes.
Fine, sure. Thank you.
Okay, guys, I hope you have solved the question. Let me tell you how to solve in case you have any doubts. So subnet mask /26 255 255 dot 255 dot 192. Step 1. Step 2, block size 256 minus 192, which will be
64.
64. Then number of subnets will be 2 to the power n. What will be my n in this case? 2. 2 to the power 2, which is 4.
4.
Number of valid hosts per subnets 2 to the power h minus 2. What should be the value of h? 6. That means 62. So that means I'm going to have 4 subnets and each subnets are going to have 62 valid hosts. So what will be those 4 subnets? Let's discuss. First subnet will be 200.200.
Dot 100.
What was the subnet? 100. First subnet will be 200.200.100.0. What will be my second subnet? 200.200.100. What was my block size? 64. So simply add 64 in the fourth octet. 64. 200.200. Third subnet will be 100.128. Fourth subnet will be your 200.200.100.192. If I'll add another 64 in 192, it will be 256, and 256 is Martian subnet. It's not a valid value of an octet. So these are the 4 network IDs you are going to have, and all network IDs will have first valid host like this 100.1, and this will have first valid host as 100.65. This will have first valid host as 200.200.100.129. This one 200.200.100.193. So it will go till 62. So 200.200.100.62, that will be your last valid host, and 63 will be your broadcast IP. This will be your broadcast IP. Similarly, you can do for these 3 subnets. For this
Sumit sir,
last
one question.
yes, yes.
How did you find out that value of h as in 6?
Okay. Total, how many bits we have?
32.
Sir, whole
32.
bits are 6.
Host bits are 6. How? Network bits are your slash notation. Okay, whatever slash value is given to you, your subnet mask slash 24, 25, 26, that is your network bits. Okay, let's suppose in our case, network bits were 26. Okay, so out of 32, 26 are network bits. So how many I'm left with? I'm left with 6. So 6 are my host bits.
Okay.
Is it clear?
Okay.
Yes.
And if it's a class B address, then again we have to subtract from 32, right?
We'll talk about class B, but yes, the concept is same. You have to subtract from 32 because total are 32 bits. And what are those 32 bits? They are combination of network and host bit. So if one value is something, to find out the other value, you simply have to subnet the value you have from 32. That's it. Is it okay?
What about total IP, Sumit?
What about
Total IP contain.
total IPs? You need to add 62 plus 62 plus 62 plus 62.
26.
246. 246 will be your total valid host that you can take out of them.
Sir,
Of
248.
4 subnet. 248.
248.
Yes, 248. Yes. Okay. Let's do one more question. Right now we are discussing class C only. Okay. I will come out to class B after this and then class A. But I will make you pro today. Just keep practicing with me. 190, not 190, 190 is class B. 196.68 dot tell me something, let's say 17 dot 0 slash 24. Try to solve this now. This is slash 24. The tricky part is finding the value of n. What do you think should be the value of n, guys?
1.
1. How?
Sir, subnet map means I have guessed. I don't know it's right or wrong. But 24 minus 24 means it's 0 and 2 raised to 0 is 1.
You're right. You are correct, buddy. You are correct. So step 1 is your subnet mask. Step 1 is your subnet mask, which is 255.255.255.0.
Dot zero.
Okay. Then you have block size 256. So in our case, our fourth octet is complete 0. My fourth octet is complete 0 and I have to take the octet value which has last 1. So in this case, my fourth octet has no 1. So I'll take the value of third octet, which is 255. In this scenario specifically, block size is of no reference. That is why. So number of subnets or networks 2 to the power n. So n is supposed to be 24. What is given to me is 24. So 24 minus 24, 0. No change. Anything raised to power 0 is 1. That means we are going to have only one subnet. And how many IPs will be inside that subnet? What will be my value of h? 8. in this case? 2 to the power 8 minus 2, 254. So it will look like this. 196.68.17.0. This will be my network ID. 196.68.17.1. This will be my first valid host. 196.68.17.254. This will be my last valid host. 196.68.17.255. This will be my broadcast IP. So do you get this question? Yes or no? Is this clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. One very important subnet in class,
Hello, sir.
class. Yes.
Sir, will you explain how to find the number of broadcast IPs for some
Number of
for some broadcast IPs?
how to find broadcast IP. After last valid host
Between
of
these
any
person.
after that is what I'm telling. After last valid host of any subnet, the next IP is your broadcast IP. If you see any octet is supposed to have, why this 2 minus 2 we are taking? Why we are not taking 2 to the power h? This minus 2, if you think about it conceptually, this 2 we are taking 1 of network ID. That means this one, and 1 of broadcast IP. That is this one. So to find network ID and broadcast IP, network ID you will find by conventional means, but broadcast IP is simply the next IP of your last valid host of any subnet. Is it okay?
Okay. For suppose it is slash 31.
/31 will not have a valid host, buddy. /31 won't have a valid host. /31, that is why is not used in production environment. You will never see /31. You will see either /30 or 32. Okay. Am I good to go ahead? If I take C, I'll take /31. What will be the subnet mask? 255.255.255.254, right? Block size will be 2. Number of subnets will be, how many subnets I'm going to have in this case? 2 to the power for class C. I'm talking about class C. For class C, how many subnets I'm going to have? 2 to the power 7. That is 128 subnets, and valid host per subnet will be 2 to the power 1 minus 2. That will be 0. That will be 0. So that is why in /31 we don't take it as a production environment network, because /31 has no usable IPs. It has only broadcast IP and network ID. Network ID, broadcast IP. Network ID, broadcast IP. You can't use it in a production environment because it has no usable IPs. What is the core concept of subnetting? Core concept of subnetting is I'm going to Airtel. Okay, I'm telling Airtel, hey Airtel, I have 250 users. Please give me a subnet so that I can assign IPs to my all the networks internally. Airtel will give me a seeing 250 subnet, 250 users. He will give me a /24 network so that I can assign IPs to my 250 users accordingly, or maybe more, depending upon the requirement. But in /31, you have 0 subnet, sorry, 0 valid host, 0 usable IPs. So you don't use /31 in your production environment. Is this clear now?
Yes, Sumit.
Can who has that doubt /31? I hope it's clear to you, man.
Yes.
Am okay. 223.79.69.0/30. Very important. Please resolve the subnetting for this. Take 5 minutes. Let's take exactly at 12:50. Then I will tell you the use or why we take /30. Okay. Take 5 minutes. 12:48. Okay, guys. So how many of you solved it? I hope the total count is 100%. Okay, subnet mask. .255.255.255./30. What is the subnet mask for /30?
252.
252. Block size 256 minus
Minus
252.
equal to
That is 4. Number of subnets
64.
2 to the power 6. That is 64 subnets. Then you have number of valid hosts per subnet
2.
2.
2 to the power h minus 2. That is 2 to the power 2 minus 2. That is 2. 64 subnets with a gap of 4 each. So they will be like this: 223.79.69.0, 223.79.69.4, then .8, .12, .16, .20, .24, .28, .32. It will go on till .252. So this will be your 64th subnet. This will be your 64th subnet, and every subnet is going to have 2 valid hosts. So let's say this is first valid host 69.1, 69.2 will be the second valid host. Okay, and 223.79.69.3, this will be my broadcast IP. First valid host, and this is your second valid host, or you can also call it as last valid host in case of /30 subnet. So that means /30 subnets have only they have only two usable hosts. Why are they used? Where exactly we use /30? Can anyone tell me in production? This is a question specifically for those who are working in the networking environment. Could you guys tell me why we use
For WAN
/30?
connectivity or point-to-point connectivity?
Point-to-point connectivities. For freshers, guys, you need to wait till routing to get this answer. Okay. I hope /30 is also clear to you guys. Let me give you one homework question. Or let's not take homework question. Okay, it's for class C. Now let's start our discussion via class B subnetting. So what is class B's? What is a class B IP range whose first octet value lies from? Okay, so for example, let's talk about this. One of the basic subnets. Concept is absolutely same. Okay, if you are clear with class C subnetting, class B is nothing for you. Step 1. Subnet mask calculation. What is the subnet mask for /17? 255.255.128.0. What is the block size? Now who will tell me block size? 256 minus what?
128.
Which octet? Guys,
Third octet, sir.
please be sure in this case. Now we will manipulate third octet. Class C, we were manipulating fourth octet. Class B, we will manipulate third octet. So that will be 128. Not 4, 3. Number of subnets or networks. What is it? 2 to the power n. What will be the value of n in this case? Think conceptually.
1.
1. Why 1?
Because 16 minus, I mean 17 minus 16.
17 minus 16. We are supposed to have 16 network bits. But how many network bits I have? 17. So 17 minus 16, 1. 2 to the power 1, that is 2. I hope this is clear to everyone. How I came to the conclusion that n is 1. Number of valid hosts per subnet. Now what will be the value of h in this case?
15. 2 to the power 15 minus 2.
Absolutely. Even I don't know the value, how much it will be. 2 to the power 15 you can calculate. We don't need it. We don't need to calculate. We just simply need to apply the logic. What is our subnet? Our subnet is 16.0.0. Okay. So I am going to have two subnets, right? First subnet will be 16.0.0. This will be my first network ID. Now, what is going to be my second network ID? Who will tell me now? Block size was 128. Second network ID. First network ID, absolutely fine.
That would be
172.16.0.0.
128.255.
No, 128.0.
0. Yes, sir.
We will not touch any other octet in network ID. We will touch only that octet in network ID from where we have taken the block size. We took the block size from the third octet. So we will apply the block size in the third octet only to find out the next recurring network IDs. Am I clear? You will not touch this 0. I'll tell you why. Because now if you talk about the valid host, it will be 172.16.0.1. This will be my first valid host, right? Any doubts till this point?
No, sir.
172.16.0.2 will be my second valid host. It will go till 172.16.0.255. Will it? Question is, will it? If I start counting from 1 to 255, it will come out to be roughly 254 IPs. Guys, all of you please be on mute. All of you please be on mute. Thank you. If I start counting from 1 to 255, my count will be 254 only. But what are the number of valid hosts I'm going to have in my subnet? 2 to the power 15 minus 2, which is huge. Which is huge. That is close to 65,000, guys. This is huge, right? So once this will full, once my fourth octet will fill up from 1 to 255, then I'll start manipulating my third octet. Now counting will start from 1.0. It will go like this: 1.1, 1.2, 1.3, then it will go till 172.16.1.255. Again, after fourth octet is finished, we again add one in the third octet, 2.0, 2.1. So this counting will keep going on. It will go till which value? It will keep on going till 127, because my next subnet is starting from 172.16.128.0. So all the IPs till 127.255 will be covered in first subnet. So 127.254 is going to be my last valid host of first subnet, and 172.16.127.255 is going to be my broadcast IP of first subnet. Is this clear to you guys? Yes, no, maybe.
For
Yes,
me,
sir.
it's okay, sir.
Okay,
Sir, one small question.
just give me a moment. Okay, let me finish second subnet as well. Then I'll take your questions. 172.16.128.1 is going to be my first valid host. It will go on and on and on till 172.16.255.254. In between like this 128.255, then it will start from 129, then 130, then 131. So this will be my last valid host, and 172.16.255.255 is going to be my broadcast IP of second subnet. Let me pause the recording now because it's almost 1. So we'll take a break of few minutes. Okay. 0.20. Let's take this one first. First is your subnet mask. What will be the subnet mask? 255.
56 minus 240.
Just 255.240.240.0. Block size will be
16.
16. 256 minus 240, 16. Number of subnets,
That's 16.
2 to the power 4. They are also 16. Number of valid hosts
2 to power 12 minus 2.
per subnet, 2 to the power 12 minus 2. 2 to the power 10 is 1024. 2048, 4096, 4094. Right?
Yes, sir. Yes, sir.
So we are going to have 16 subnets. Oh my god, 16 subnets. Too many of them. Let's try to write all of them. 150.150.0.0. This will be my first subnet, okay? Yes. Second subnet will be, there will be too many 16. 150.150.16.0, 150.150.32.0, then 48.0. These will be your network IDs up till 16 network IDs. What will be the last network ID? 240.0. It is simply table of 16. I don't know how good you were in mathematics in your school days, but these are all tables only, guys. See, I'm running six multiples of 16. 16, 16, 16, 16, 16, 48, 64, 80, 96, 112, 128, 144, 160, 176, 192. After that, 2121, 192 and 16, 208, 224, 240. I was
Correct,
good
sir.
in maths. I was good in maths in my at my time. So that's why calculations are little easy for me. Okay. So 240.0, this will be my 16th subnet. If I'll go beyond 240, next 16, that will be 256.0, which is not a valid value of an octet. So first valid host for this will be 150.150.0.1. If you want to know that what is the limit of a subnet, there is one more trick. 16 minus 1, next subnet minus 1. If I'll go next subnet minus 1, that is 150.150.15.255, right? The IP prior to 16.0 will be 15.255, which is the broadcast IP. If I'll go 1 minus to broadcast IP, 150.150.15.254, which is last valid host. First valid host, last valid host. Now tell me what will be the first and last valid host of third subnet, that is 32.0. Who will tell me? First valid host first, tell me. First valid host.
32.1, sir.
Yes.
And the
This will be
last
the
one.
wait, 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 wait,
32.25.
wait, wait, wait. Last valid host will be
254.
no of this subnet. I'm
47 dot
asking about
40, 47 dot 254, sir.
255.
yes, 47.254. This will be my last valid host and broadcast IP will be 150.150.47.255. See, next subnet is 48.0. If I'll go -1 to this subnet, that will be 47.255. See how subnetting is going, how octet values are filled up. First fourth octet is filled, then third octet is filled, then second, then first. So if I have filled all the octet values of fourth octet, that is 12255, then the counting will again start from third octet. Same thing is happening over here. So prior to 48.0, we will be having 47.255. If you are having confusion in this, see what is the decimal system of counting? Decimal system of counting is this: 1, 2, 3, 4, 5, 6, 7, 8, 9. Prior to them is 0. It goes like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So once one's place is occupied, then we fill up tens place. How? Like this. And that will start from first value only: 1 0 1 1 1 2 up till 1 9. Then we'll change this to 2 2 0 2 1 2 9. Same thing is happening over here. First I'm filling the octet value of fourth octet 1 2 2 5 5. Once they are filled, then I'm moving to third octet. Third octet will go from 1 to 255 with all these conjuncture values. Then it will keep on increasing from 1 to 2, 2 to 3, 3 to 4, like so on and on and on. I hope you are getting this intermix relation that I'm trying to convey to you.
Yes, sir.
Is there any doubt left now in class B subnetting? That how to find first valid host, how to find last valid host, how to find broadcast IP. Any doubts in this? I know calculations are clear to you, but value should also be clear like calculations.
Yes, sir. Clear, sir.
Okay, cool. Next is your /16. (169.54.0.0/16). Did I write 54 or 254? I don't know, whatever it is. Anyways, it's the same. 169.54.0.0. Again, subnet mask 255.255.0.0. Okay, block size. What will be my block size now? 1. 256 minus 256 minus 255. Why? Because my last one is in second octet now. Number of subnets 2 to the power n. What should be the value of n? 0.
1, sir. Yeah.
Number of guys, please be on mute. Someone is having disturbance at his backend. So that is 2 to the power 16 minus 2. I don't know what is this value. You can calculate. You can calculate the value. Okay, 169.54.0.0. That will be the only subnet we are going to have. And it will have all the values till 255.254. That will be the last valid host. And 169.54.255.255 is going to be your broadcast IP. Okay, 169.54.0.1 is your first valid host. It will go all the way to the bottom. Class B subnetting, any doubts?
No, sir.
Okay, fine guys. I'll give you a few questions that you need to do as a part of your homework. Okay.
Okay, sir.
Let me write it for you guys. one more you take. These are the 4 homeworks for you for class B. Class A I already, sorry, class C I already gave you. Now let's talk about class C. That will be your final question for the day. I won't take much more time of yours because I know what you guys want to see at 2 p.m.
Yes, sir.
Okay. So class, if you understood the previous 2 classes, you should not have any problems in understanding class A because concept is absolutely same. Subnet mask 255.224.0.0. Then you have your block size 256 minus which octet will take this time? Second octet 224, which is 32. Then you have number of subnets 2 to the power n. What should be the value of n here? Anyone?
3.
3.
sir.
So how many networks we are going to have?
8.
8
6.
networks. Number of hosts per subnet 2 to the power h minus 2. What will be the value of h? 21. Class A has maximum hosts. Class A has maximum hosts. So what will be our 8 subnets? My 8 subnets will be 101.0.0.0. That will be my first subnet. Second subnet will be this. Third subnet will be fourth, not 68, 96. Okay. Next will be your 128. 128 plus 32, 160. 160 plus 32, 192. 1, 2, 3, 4, 5, 6, 7. One more will be there. 224.0.0. If I'll add one more, it will be 256. And we have our 8 subnets over here. Okay. First valid host. Okay. Last valid host of every subnet. And broadcast IP of every subnet. Now start telling me. First valid host for this, very simple.
Yes, sir.
Host.
Dot 1. We just have to add dot 1 at the end. Right?
Yes,
Now
sir.
tell me last valid host.
101 dot
101.31.254.254.
31.254 dot. No, not 254.
255, sir. 255.254.
255.254.
Yeah.
And broadcast IP will be 31.255.255. Okay, for this 101 dot, this is 32, so it will be 47. So this will be 47.255.254. Okay, for this it will be 95.255.254. For this it will be 127.255.254. For this it will be 159.255.254. Okay.
Sumit,
For
second one
the
will be 101.63.
So second one will be 31.
oh, I missed
47.
one. Yes, I missed one in between. No.
No, 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 47 instead of 47.
Yes, 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 yes.
101.37. 31.
Okay, yes, 63. Yeah, I took 16. Yes, you're right.
Yes, sir.
I took 16. It will be 63. 64, 95, 127, rest all is fine. 101 dot 191.255.254, 101 dot 223.255.254, 101 dot 255.255.254. Okay, now you can change the last octets to 255 to get their broadcast IPs.
Broadcast.
Sometimes, guys, it was just a typo. I think I miscalculated. I hope it's clear. Class A. Similarly, like /24 /16, you can do it for /8 as well. It is going to have only one subnet. So what we discussed till now was how default subnetting happens. Okay. That is when we have a class and the same class subnet range. Tomorrow we will discuss variable subnet with variable subnet mask, like class A IP, class C subnet mask, like 10.10.10.10.0/24. How will you solve this? That we'll discuss tomorrow. And after that, we'll discuss VLSM, supernetting. Then in the last section of the tomorrow's class, we'll discuss about the shortcut tricks. Okay.
Yeah, okay, sir.
Okay, guys. This is VLSM, variable length subnet mask. Okay. Tomorrow we'll discuss FLSM, fixed length subnet mask. Rest our discussion I'll continue tomorrow, guys. I hope you had some productive learning for the day. Yeah, yes, good morning. Okay, I think we're good to start. Okay, guys, see, till now we talked that we have till now I told you that class A that class A, class B and class C, they have the subnet range from they have the default subnet of /8 /16 and /24, right? But the range and anything from /8 to /15 is class A, and anything from /16 to /23 is class B range, and 24 to 32 is class C range. This is for by default. This is for the default subnetting subnets, but it doesn't hold true in the real time. In real time, the range is everything till 30. That means, what does it implies? It implies that any subnet, any subnet can be associated with any subnet mask. That is what it implies. That means I can write it anyway. I can write this. This is class A subnet, but I'm using class C subnet mask. I can write it like this: 170.200.0.0/26. That means subnet is class B and subnet mask belongs to class C range. Okay, but in practicality, anything can hold true. Okay, you can define the starting subnet or the starting slash notation of a class, but where does it actually ends? You cannot define. It can go anywhere till /30. Now, why I'm taking /30, I'm not taking /31 and /32, because /31, as I told you in yesterday's class, I believe that /31 doesn't have any usable IP host. It has only network ID and broadcast IP, and /32 has only one IP. That is that specific IP itself. Now, how will you solve subnetting of such questions? Let's take this example itself. 170.200.0.0/26. How will you solve this? Don't deviate from the concept. The concept remains the same. Step 1, subnet mask. /26 is 255.255.255.192. Okay, guys, please be on mute. Step number 2, block size. What will be the block size? 256 minus 192. That will be 64. Step number 3, number of subnets or networks. Two to the power n. What will be the value of n over here? Anyone? Any guesses?
That would be 2.
Mm-hmm. What is the default slash notation of class B?
10, sir.
16.
16
16.
slots.
And what we have? 26. So whomsoever answered 10 was absolutely correct. What is the difference between the two? 10. This is your n. Guys, please be on mute. So 2 to the power 10. What is 2 to the power 10? I think it is 1024. So you will have 1024 networks. These many networks, yes. Step 4. Number of valid hosts per subnet. That is 2 to the power h minus 2. What will be h over here? In this case, h will be 6. Why? /26, 26 network bits, remaining are host bits. As simple as that. So 2 to the power 6 minus 2, that will come out to be 62. All the calculations are done. Now let's talk about the real stuff. 170.200.0.0 will be my first network ID. What should be my second network ID? I took block size from which octet this time? I took block size from which octet this time? The block size is taken out from the fourth octet. So keep adding 64 in the fourth octet to get the next subnet. Same concept. This will be my second network ID. Okay. This will be my third network ID. Okay. 170.200.0.192 will be my fourth network ID. What about after this? What about after this? If I'll add another 64 in 192, it will come out to be 256, right? 256 is not a valid value of the octet. But what I have found that this IP or the provided subnet with the subnet mask can have 1024 networks. How? These are only 1, 2, 3, 4. What about the remaining 1020 networks? What about them? Again, the counting phenomena that we discussed yesterday. Once my fourth octet is filled up, I will now start filling my third octet. 170.200.1.0. Okay, that will be my fifth network ID. 170.200.1.64, that will be my fifth network ID. Not fifth, sixth network ID. 170.200.1.128, seventh. 170.200.1.192. Then after that 170.200.2.0, 170.200.2.64, 170.200.2.128. It will go on till 170.200.255.192. That will be my 1024th network. Is it clear? Is it clear to everyone?
Clear.
Yes, sir.
Yes, sir. Clear, sir.
If you are clear with the basic subnetting, then it should not be of any problem to you. Guys, if you are okay with this question, then try this one. 111.0.0.0/22. Class A and class B. Subnet belongs to class A, subnet mask belongs to class B. How much time you want? Is 5 minutes okay for you? 12:15? You can try it out by yourself.
Okay, sir.
Okay, I think he joined. Maybe by some other name.
Sumit, I joined Ramchandra.
Yeah. Okay, buddy. Let's then continue our discussion. So guys, did you try this question? Okay, step 1, same thing, subnet mask. What is a subnet mask? 255.255. What is /22? 250. Block size. What is the block size? 256 minus 252. That is 4. Which octet? Third octet. We have taken the block size from third octet. So we will manipulate third octet. Okay. Number of networks or subnets. 2 to the power n. Now what should be the n here? Anyone. It is going to be very big.
That would be 2.
2 to the power 14. How? This is a class A subnet. Subnet is class A. Subnet mask class B /8 and /22. What is the difference between the two? 14. 2 to the power n, 2 to the power 14. Okay, number of valid hosts per subnet. 2 to the power h minus 2. What will be h over here? 2 to the power 10 minus 2. 1, 0, 2, 2. Okay, I hope everyone is clear how h is 10 now. So how many subnets we are going to have? 2 to the power 14. Again, huge subnets, huge, literally huge subnets. 111.0.0.0. This will be my first subnet. What should be my second subnet? Anyone? Anyone? What should be my second subnet?
11.11.0.4.0.
Absolutely. 111.0.8.0. 111.0.12.0 up to 111.0.252.0. This will be around your 64 subnets. So after this, how will you take up after this? 111.1.0.0, 111.1.4.0, 111.1.8.0. It will go till 111.1.252.0. Then you will start with 111.2, then 111.3, 111.4. It will go till 111.252.0.0 till last will be 111.252.250, not 252, 255, 255.252.0. This will be your last subnet. That will be your 2 to the power 14th subnet, whatever value this will be. So these are the variable subnet questions that I hope are clear to you guys. Okay. Now let me give you one website name that is excellent for practice. I don't know how many of you are aware about it or not. Subnetting.org. Till now, what we have done, we have discussed subnetting, to very good extent. Okay, I believe we have practiced well enough. If you have done all the questions that I have discussed till now in the class, then your practice is good enough for subnetting. But what we are doing till now, we are doing it on paper and pen, right? What we are doing is on paper and pen. Do you think that in a live interview or in a live production environment, in a production environment, maybe you have this much of time that you can do it on a paper and pen, but in an interview which hardly is of 20 to 30 minutes of an L1 or L2 or maybe sometimes L3, do you really think that interviewer will give you this much of time that you take a paper and you do all the calculations and stuff? No, right? So I want question to be in front of me and solve it in an instant. How to achieve that thing? All of us want that. Yes or no?
Yes.
Yes, sir.
So
Yes, sir.
Yes, sir.
first thing to achieve that, you need to practice a lot. Okay, from subnetting.org. Definitely few tips and tricks are there that will help you out to do it in a faster way that I will just tell you, but you still need to do practice. To achieve subnetting solutions in a much faster way, you need to have command over two things. Okay, first is you need to have command over two things. First is subnet mask calculations. You should know all subnet masks starting from /a to /32. They should be on your tips. Okay. Second, block size calculations. Subnet mask should be in your head, then straight away calculate the block size. For example, let me talk about this question. He is saying, what is the first valid host address on the subnet that has host this belongs to? Can anyone tell me what he is actually asking? What exactly he is asking? Anyone?
First
He's
finding the
asking for the first usable IP address.
First usable IP address of what?
first have to find the subnet
Of the
and then
subnet which belongs to
Yes.
this IP address.
Yes. Of the subnet that belongs to this IP address. So how to calculate that subnet? Thing is how to calculate the subnet. Again, what did I tell you? You need to have command over two things. First thing I told you, subnet mask. What is the subnet slash notation? /28. What is the subnet mask for /28? Everyone please look at my screen very carefully now what I am going to tell you how to approach these questions. What is the slash notation or what is the subnet mask for /28? It is 255.255.255.240. Block size will be 256 minus 240. Which octet? Fourth octet. So my block size is 16. So that means my fourth octet has to be a multiple of 16. If you look at all the questions carefully, what we have done in the past, you must have seen we are adding block size simply in the octets from which we have taken out the block size. So all the octets in which we are adding the block size, definitely they are multiple of block size. Yes or no?
Yes, sir. Correct.
So over here, if my block size is 16 from the fourth octet, so to find the network ID, don't you think my fourth octet should be a multiple of block size itself, that is 16? And what is the nearest multiple of 16 in 30s? It is 32. So what is the network ID? 172.28.54.32. If .32 is the network ID, what is the first valid host? 33.
31.
33.
33.
33.
Yes,
Next.
33, sir.
what I did, is it too much? Was it too much calculation? No. Just two
No, sir.
things: subnet mask, block size, rest all logic.
Yes, sir. Understood, sir.
Let me show you next question. How many subnets and host per subnet? This is simple. This is, we have talked a lot. 2 to the power 5. 2 to the power 5 will be your subnets, that is 32. And how many hosts per subnet will be there? 2 to the power 3 minus 2, 6. This is simple question. What is the broadcast address of the subnet that host is a part of? Again, same sort of a question. Now, to calculate this question again, first thing, subnet mask /23 255.255.254.0, right? So block size will be 2. Which octet? Which octet? Third octet. So my third octet has to be a multiple of 2. Is my third octet multiple of 2? 182? Yes. So what will be my network ID? 172.18.182.0. This host belongs to network ID 182.0. Network ID is clear. What will be the next network ID? 184.0 minus 1. 172.18.183.255 is the broadcast IP. See, is this clear to you guys? Yes or no? How I'm doing the calculations in my head?
Yes, sir.
Anyone is having any doubts over here? How I came to this answer? Please ask me if you have, because this is important. You might not get a chance to discuss these things again, guys. Come on, guys, you can ask me if you have any doubts. No?
Sir, one more
Okay.
time, sir.
Okay. Tell me one thing. What is the block size of this? Don't use pen and paper, buddy. What is the block size of this? 172.18.182.245/23. What will be
So
the subnet mask first?
255.254.0.
254.0. What will be the block size?
Block size is 256 minus 252.
254. 254.
Sorry, 254.
254. That will be 2, right? So block
Right,
size
2
is
block
2.
2.
Which octet?
Third 2
Third
second
octet.
octet. No,
Third octet.
sorry.
255.255.254.0. Block size will be 2 from third octet. So your third octet needs to be multiple of
Multiply
2
2.
to get the network IDs. So 182 is a multiple of 2. I know it is a multiple of 2. So 182.0 is one network ID and next network ID will be 184.0. Right? Yes or no?
Yes.
If one network ID is 182, then other network ID will be 184. And I need to tell the broadcast IP of 182.0. I know 182.0 is my network ID. Next network ID is 184.0. If I go 1 minus to the 184.0, that will be 183.255, which is going to be my broadcast IP. Is this clear now? Yes or no?
Yes.
Still anyone is having any doubts? I'm good to repeat it for the third time. Guys, say something. I can repeat it for the third time, but this time I'll do it on board if you are not understanding via simple calculations. No? Okay. Then tell me this you can tell. Yeah, come on, this is very easy. 1024. Tell me this then. I will not tell you the answer of this. Can you solve this question, guys? You need to tell me the valid host range. That means the first valid IP to last valid IP of the subnet that this host belongs to. Don't use pen and paper. I'm again giving you a tip. Don't use pen and paper. Okay, let me help you to solve this question. Leave your pen and papers. What is slash 23? First tell me. What is slash
255.254
254, sir.
254.0, right? So
right.
what is the
Yes, sir.
block size? What is the block size?
2,
256
sir.
minus 252 minus 2
2. Block size 2. Which octet?
Third
third
octet,
out
sir.
Third octet. That means third octet has to be a multiple of 2
2
to
2,
get the
sir.
network ID. What do you think is the nearest multiple of 2 less than 25?
26.
20
24 less
20,
than.
24.
24.
24
So
24.
So one network ID will be 24.0. Next network ID will be 26.0. So 24 to 26, how many valid IPs are there? 172.31.24.1 till 172.31.25.254. Is this clear or not?
the number of hosts
Yes.
510 510
That doesn't matter.
okay.
You need to tell me that what is the range? What is the question saying? What is the range of those? What is the values of those?
Okay.
Are you clear, guys? Again, I'm asking, is it clear to you how I'm calculating them?
Yes, sir. Clear, sir.
Do I need to repeat it again? Anyone?
It is clear, but we have to the practice and
You have to
practice.
practice. What valid host range is the IP address a part of? You need to, again, this is a host, valid host, and you need to tell the valid host range this IP is a part of. Can you tell me? Slash 30, 252, 4, 152,
252, 150, 154.
Guys, come on, tell me. My calculations are already done. Guys, if you are taking more than 10 seconds for a question to solve subnetting question, then you are taking too much of a time. A good network engineer is a network engineer who has all the calculations in his head. Okay, let me help you out. What is slash 30? Tell me. What
252,
is
sir.
252? Block size?
4.
Which octet?
Fourth octet, sir.
Fourth octet. What is the nearest multiple of 4 in the fourth octet to 153?
148, 152, sir.
152, absolutely. So network ID will be 192.168.23.152. What is the next
Correct,
network
sir.
ID?
Uh, 1,
192.168.23.156.
6, correct, sir.
156. So in between 152 and 156 are the host, valid host. That means one valid host will be 192.168.23.153. That is which you have. Second will be
154.
192.168.23.154.
4.
155 will be the broadcast IP. So 153 and 154 is the answer.
Yes, sir.
How is it? Is this methodology a good one, which I'm telling you?
Yeah, good, sir, but we need some practice, sir.
You need practice, definitely. I will not lie. I'm solving these at such a good pace because I have solved more than 5,000 questions. For one
That's why you
consecutive
are a
year.
teacher.
For one consecutive year, one full 12 months, 15 minutes of my daily schedule was dedicated to subnetting.org. So in those 15 minutes, I used to solve Initially I used to solve 7 to 8 questions, then it comes to 15, then it comes to 100 at one point of time, sometimes more than 100. So I don't know how many I have solved. Even 5,000 is just a rough count, but to be honest, I definitely think it's more than 5,000. But this methodology which I'm telling you is my personal practiced methodology, guys. Nobody will teach you in anywhere. You won't get this on any blog or any channel or any from any institute. This is something which I have studied personally and observed myself, which I am sharing with you guys. Could you tell me this? What subnet does host belongs to? You need to tell me the network ID. This is very simple. This is very simple, guys. One of the most simplest question what we have discussed by today.
So 172.16.0.0 subnet.
Absolutely. Perfect. Very good.
And
What is going to be the second network ID? This will be the first network ID. Second network ID of this
64.0, sir.
64.0. Are you
Yes.
getting the groove now? Do you want to solve more questions? Do
Yes,
you want
sir.
to solve more questions? Okay. This we'll discuss. This question we'll discuss after this. How many subnets and hosts per subnet? No, this is simple question you can solve. 2 to the power n and 2 to the power h minus 2. Tell me this. I don't want you to use pen and paper.
Dot 127.
No.
Sir, 79.
No. Come on, guys. Okay, tell me what is the block size?
Sorry, block size is 8, sir.
8.
Which octet?
Fourth octet.
So fourth octet has to be a multiple of
71 broadcast, sir. Right, sir?
71.
71.
71. Absolutely. It is 71. Any doubts? Anyone? Any doubts? Anyone?
No. No, sir.
See, guys, block size 8. Which octet? Fourth. So fourth octet has to be a multiple of 8. 64 is a multiple of 8. Next multiple of 8 after 64 is 72. Minus 1 is a broadcast IP of previous subnet, which is 71. Try now. This is simple. This is easy. Tell me the network ID of this. He's simply asking network ID of a valid host of an IP address. Tell me the network ID. Very simple.
32.
5.32.
Okay. What is the subnet mask? Okay. Anyhow, let's see. You are right.
Dash 224.
You are right, guys. Last question. Again, same sort of a question. Tell me the network ID of this.
64. 128, sir.
127.
Absolutely. 128. 64, 64, multiple of 64 are 0, 64, 128, then 192. Are you guys feeling comfortable in subnetting now? Better to what it was before?
Yes, sir.
One thing I can assure you guys, this is probably going to be the best 1000 you have ever invested in your life. I hope you have
Yeah,
got the
that's
idea by now.
yes, sir.
Okay, there is one more. See, two things we'll discuss. One, I'll discuss uh, one more type of subnetting. After that, I'll discuss supernetting as well. Supernetting is combining small networks into one bigger network. Subnetting is dividing a bigger into smaller, but supernetting is opposite of subnetting. So we'll discuss a couple of questions of supernetting. You won't get much of in supernetting, but still it is important. In some books, it is referred to as summarization as well. Okay, so but two types of question. Type 1, 192.168.10.0/24. This is a subnet. Let's suppose I'm given. Okay, now you are the network engineer of an organization. You are handling the network of an organization. You are given a task to divide subnets in three departments of your organization. Let's say one department of your organization has 100 users. Okay, let's suppose. Second department of your organization, let's say it has 50 users. Third department of your organization, let's say it has 2 users. You need to, what you need to do, you need to find the network ID and arrange the requirement wait. This is you need to find network ID simply. You need to find the network IDs of these three departments in such a way that all the departments are provided with their specific IDs. Because if you talk about /24, it is going to have only one subnet, right? If you go by conventional method, 2 to the power n, that will be n is going to be 0 over here. Anything raised to 0 is 1. But over here, I have three different departments. I need to provide IPs not only to these three departments, but I need to separate these three departments by having their own individual network, and that networks need to come out of this subnet. How will you do that? So in order to find the network ID, okay, in order to find the network ID, you need to arrange the requirement first in decreasing order. What I'm saying, you need to allocate IP to the department which has highest users first. That implies department with highest users will be provided IP first. That means the department with 100 users, this will be provided first, then 50, and then the department with 2 users. Okay, so let's provide the IP to these 100 users first. How? Let's say this is the finance team of your organization. This is the, let's say, IT and HR team. And these two people are you people, network and admin team, who are handling everything. So you will first give priority to finance, who has the highest users. Okay, so let's say, let's talk about which is 100 users. A formula is 2 to the power h minus 2 has to be greater than or equal to the number of users. So that is 2 to the power h minus 2 has to be greater than equal to 100. So what value of h I should put that this inequality of mine should prove true? What should be the value of h?
2 power of 7, sir.
Absolutely, h should be 7. If my h will be 7, so it will be 2 to the power 7 minus 2. That will be 126, which will be greater than 100. So if my h will be 7, so what will be my n? What will be my n? H is 7. What is n?
1, sir.
No,
1.
no. How to find n? Guys, 25. 25. How many total bits we have? 32. Out of 32, if 7 are host bits, how many network bits are there? 25. As simple as that. Any doubts? Any doubts till this point? So your department 1 is going to have this subnet. 10.0/25. Subnet mask will be, let's do it subnetting now. 255.255.255.192. You don't need to calculate block size for this, but you can calculate for simplification. Block size will be 64, not 64. Wait. 19/25 is 128. So block size will be 128. Okay. Block size will be 128. How will it looks like? It will look like this. 192.168.10.0 will be the network ID of first department. 192.168.10.1 is the first valid host of the department 1. Second valid host. It will go till 10.126. This will be the last valid host since our block size is 128. 192.168.10.127 will be the broadcast IP of the first department. Guys, any doubts
And
in the
Sumit sir,
Hmm?
how you calculate the value of n in this case? N is 25, right?
Yes.
And how you calculated that?
Total bits is 32. That is your network plus host bits, right? If your host bits are 7, that is over here. We find h as 7, right? If your host bits are 7, then what should be your network bits to make the sum as 32? 25. Is it fine now?
Yes. Thank you.
Okay. So even so, just see it carefully. Not only we dedicated IP to 100 users, but we have left 26 more usable IPs, so that in future if a new joinee comes up, he can also be allocated IP address. Okay, is it clear, guys? Shall we go ahead with the second department?
Oh, yes, sir.
Okay. Second department, 50 users, right? And we have allocated IPs till 127 to first department. So we are left with 190 to 168, 10.128 onwards. So what should be my slash notation over here? To find out the slash notation, again, I will use the inequality 2 to the power h minus 2 has to be greater than equal to 50. What should be the value of h in this case now? 2 to the power
6,
of
sir.
6. Absolutely. 2 to the power 6 minus 2 has to be greater than equal to 50. So my h is 6. If h is 6, what should be n? H is 6, what should be n?
26, sir.
26. So slash value will be 26. Again, how to dedicate the IP addresses? Subnet mask 255.255.255.192. What will be my block size? 64. Subnet is going to be this. This is going to be 10.128 is going to be my network ID. Okay. 10.129 first valid host, 10.130 second valid host, 10.131 third valid host. It will go till 192.168.10.190. That will be my last valid host. And this will be my broadcast IP. How? 64. So this will provide IP addresses to not only 50 users, but also 12 additional IPs will be left. So that if a new joinee comes up, he can be allocated the IPs as well. So sorry, this is 191. This will the broadcast IP. 90 and 91. So we have allocated till 191. Now let's talk about our final department. How many users it has? 2 users. 2 users are very simple. So till 191, we have already allocated the IPs. So 10.192 onwards we are left with. So some slash notation will come up over here. 2 to the power h minus 2 has to be greater than equal to 2. What should be the value of h to make this inequality holds true over here?
2, sir.
2, absolutely. If I'll make it as 2, 2 to the power 2 minus 2 greater than equal to 2. So 2 to the power 2 is 4, 4 minus 2, 2, 2 is equals to 2. So on h equals to 2, my inequality will hold true. If h is 2, what should be n?
30.
30. So my network ID will, so my slash notation will be 30. So that means 192.168.10.192 is going to be the network ID. Guys, you can find it out by yourself. 192.168.10.193 first valid host. 192.168.10.194 is your second valid host or your last valid host, and 192.168.10.195 is your broadcast IP of this. So we were having 254 valid hosts in main subnet. And using this terminology, we allocated IPs to 3 different departments effectively and in a better or a sequential manner, that we have allocated 195 IPs and we have still lot of IPs left. Lot of IPs are still free with us. So that is how you can allocate IPs to a organizational hierarchical structural department. It's almost one, guys, and I am done with subnetting, guys. I hope you like subnetting. So let's do one thing. Let's take a break for a few minutes. Do we have any? Okay. Mani, do you want to ask anything? Mani, do you want to ask? Netting quickly. Okay, I won't take much of your time. Okay, after summarization, super netting, whatever you call it as, I'll let you go. Okay. Summarization, some people call it as super netting. Whatever you want to call, you can call, but you should know the concept most importantly. Okay. Summarization is basically multiple this dog. Guys, I hope you're not getting dogs barking sound from my background.
No, sir.
Multiple networks into one big network. Okay, combining multiple small networks into one big network. Okay. Okay. It is majorly used in case of routing. It is a very big application of routing. How, that we'll discuss in routing only for the time being. Basically, routers use concept of summarization to reduce the routing entries in the routing table. How it is done, that we'll definitely discuss in dynamic routing protocols. So for example, I have 4 subnets 192.168.0.0/24. Okay. 192.168.1.0/24. 192.168.2.0/24. 192.168.3.0/24. So let's suppose I have these 4 subnets. Okay. I need to combine them into a one summarized subnet that will cover each and everything that belongs to these subnets for my routing table. How can I do that? Step number 1. Okay. Number of similar bits needs to be written first. Number of similar bits need to be written first. You can say similar bits or you can say similar octets. Okay. Now in my case, how many similar octets I have? I have two similar octets. If you see, I have two similar octets, first and second. Third octet onwards, the things change. So 8 plus 8, 16 bits are my similar, or I can say two octets. Okay, fair enough. So my subnet or my end result will look like 192.168 dot something dot something. Step number 2. In the third variable octet, you need to convert octet into bits from where change is occurring, not from till change is occurring. Change is occurring. For example, when I'm saying now this is for third octet, okay? This is for variable octet. Now my variable octet starts from third octet, right? So let's convert third octet into bits. So for my first subnet, the third octet value is 0, second is 1, third is 2, and fourth subnet third octet value is 3, not 4, 3. Let's convert it into bits. Okay. Okay, so that means if you observe this thing very carefully, so till this bit, everything of mine is similar. Not only 16 bits that I found it in the step number 1, but also 6 bits of the third octet. They are also similar. So 16 plus 6, that will come out to be 22. And what is this 22? This is the slash notation of your subnet. That's it. 192.168. Okay. Till slash 22, what exactly it is? If you see, observe carefully, these bit values are 0. So 0.0 slash 22. So this is your super netted subnet of these 4 subnets. Did you understood it, guys? How I came out to 162.0.0 slash 22? You simply have to see the similar bits. That's it. Combine the similar bits until whichever similar bit, the bits are similar. That is the slash notation, slash and the value. Let me show you with one more example. Maybe that will clear out to you in a much better way. One 192.168.10.32 slash 30. 192.168.10.36/30, 192.168.10.40/30, 192.168.10.44/30. Step number 1, whatever the similar bits you are seeing at the first place, write them down. In my case, the similar bits that I can see from my naked eye last till third octet, 192.168.10. So 192.168.10 dot something slash value, something like this will come. So to calculate the value of this octet and slash notation, I know till 24 bits everything of mine is same. So the minimum value of my slash notation will be 24. What goes beyond 24? Let's write it over here. 32, 36, 40, 44. Convert 32 into bits quickly, guys. Okay, I'll tell you. 0, 0, 1, 0, 0, 0, 0, 0. This is 32. 36 is 0, 0, 1, 0, 0, 1, 0, 0. Okay, 40. 0, 0, 1, 0, 0, 0, 1, 0. Then you have 40. 1 0 0 0. Okay, 44 0 0 1 0, then 1 1 0 0. So if you see, my similar bits last till over here. Beyond that, everything is variable. So that means 24 bits till third octet plus 4 bits that are similar in fourth octet as well. So my slash notation will be slash 28 first thing. And what is the value of fourth octet? So what is the common value that is over here? If you see 0 0 1 0 0 0 1 0 0 0 1 0 0 0 1 0. What is 0 0 1 0? 32. So this is the supernetted subnet 192.168.10.32/28. That is why in previous case it was 0, because the similar bits sum up to 0. If you see, the similar bits were sum up to 0. In the our next case, my similar bits, they sum up to 32. So fourth octet value is 32. Is this clear?
Yes, sir.
So this is your entire subnetting. I hope subnetting, in which we discussed each and every type of questions that you can get and each and every real time scenarios that you can get. So that is it for this week, guys. So we are done with the basic fundamentals that are required.
Okay, let's talk about broadcast domain. Okay, so broadcast domain is how broadcast defines how much a broadcast traffic can travel within the domain of a device. For example, I have a hub. Guys, I hope all of you remember what exactly is a broadcast traffic. I hope nobody is having any doubts on that. And if you have, then let me tell you, broadcast traffic was a traffic which was one to all. So what happens in a hub, guys? Let's suppose your hub has these many interfaces. So if a broadcast traffic comes to a hub, hub will simply send it. Sorry, guys. Hub will simply broadcast it towards all the remaining interfaces. So that's how broadcast works in hub. So that is why we say that hub is in a single broadcast domain. Hub is in single broadcast domain. Because hub, any broadcast traffic will come to hub. Hub will broadcast it to all of its remaining interfaces, all of its remaining egress interfaces. Same thing goes for switch as well. If I have a switch, okay, if I have a switch, if a broadcast traffic will come to a switch, switch will also broadcast it to all of its remaining interfaces. That is why we say that switch is in a single broadcast domain. Okay, but if I talk about router, the same thing doesn't stand true. Why? Guys, remember this thing, because when we will study DHCP, there is a concept called as DHCP relay. To understand DHCP relay, you need to understand the broadcast domain of a router. If a broadcast traffic comes to a router, the router doesn't process the broadcast traffic. It will drop the broadcast traffic. It will not allow the broadcast traffic to, go further. So that is why we say that routers are in per port broadcast domain. Routers are in per port broadcast domain. Okay, remember this thing. Routers are in per port broadcast domain. So if I summarize, hub, one broadcast domain. Switch is in a single broadcast domain. Router per port broadcast domain. Okay, let me give you a question then. If you are clear with the concept, switch, or you can also say bridge. Okay, both, they're both same thing. Bridge was just the less updated version of switch. For the time being, you can say it like this, and bridges are not used these days anymore. Let me give you a small topology. This is a hub, PC. Okay, one more hub, one more PC. Okay, let's suppose these both are hubs are attached to a switch. Okay, then switch is connected to a router. A router has one hub. Okay, with this hub, we have one more hub. One more hub. Okay, PC. Then with this router, Let's say we have one more switch. Switch, another switch. Okay, PC and PC. So tell me number of broadcast domains over here in this topology. Total broadcast domains in topology. It's very simple. How many?
5.
5. Okay. Somebody told me 10. Somebody said 5. Anything else? Okay, I'll tell you.
9, sir.
No, 3.
3, okay.
How? Because these all are in single broadcast domain. They all are in single broadcast domain. The only thing the broadcast domain will differ, no matter what topology you are creating, broadcast domain will differ in your layer 3 device. You have one router and it has 3 interfaces: broadcast domain 1, broadcast domain 2, broadcast domain 3. These all are in single broadcast domain. As I just told you, that hubs and switches are in single broadcast domain. They all are in single broadcast domain, guys. I hope you got it now. Any doubts in broadcast domain? Just remember that router doesn't let the broadcast traffic to cross through it. That is why we say that router has per port broadcast domain. I hope I'm clear with this.
Clear.
Guys, please be on mute. I can sense some disturbance in the background. Then we
That means
have
broadcast domain of router is only counted.
come again.
Sir, means that broadcast domain of only router is counted.
Absolutely, because the rest of the devices are in single broadcast domain. They are in broadcast. See, let's suppose, let me clear out your concept in more detail. Let's take green color. Let's suppose this PC has generated a broadcast traffic. Okay, the broadcast traffic will go to hub. What hub will do? Hub will further send it across. Okay, now this,
yes,
see how much this broadcast traffic is traveling. So what switch will do? Switch will, this is a broadcast traffic. So switch will send it over here and here, right? Switch with the moment switch will receive the broadcast traffic, he will send it to router as well as to other hub. Other hub will send it to PC. But will this router send it any further? No. Right?
No.
Yes, so that is why we say that over here, broadcast one broadcast traffic that was generated from this switch, sorry, from the PC, it traveled across all the devices. It traveled across all the devices in my domain. So that is why we say that switches and hubs are in single broadcast domain and router is in per port broadcast domain. So a broadcast traffic cannot cross this interface of the router. Is it clear now?
Yes, sir. Thanks, sir.
Even if I'll do the same over here, just you can draw the topology, just create a broadcast traffic and keep following the arrows. Okay.
Yes, sir.
So after broadcast domain, we have collision domain. Okay. Okay. Collision domain. An area. Did I cover collision domain and broadcast domain in fundamental batch of mine? I don't think so. I'm not sure. an area in which a collision occurs and because of that collision, the devices are affected. Is known as collision domain. Switches and routers have per port collision domain. Hubs are in single collision domain. Hubs are in single collision domain. Okay, what exactly is a collision? Let me tell you. Hub. Okay. Let's say PC, PC, PC. So whenever hub, first of all, you need to understand one thing, that hubs work in half duplex mode. Hub works in half duplex mode. That means they can either transmit or receive at a time. Can't do both. Okay, so that means on a particular interface of a hub, either a transmit traffic will go, okay, or receive traffic will go. If both of them will go simultaneously, then what will happen? Collision. What will happen? Collision. To avoid this collision, hub uses a mechanism of CSMA CD. Carrier sense multiple access collision detection. So that is why we say that hubs are in single collision domain, because the moment collision will happen in a hub, it will stop the traffic flow. It stops it processing. There is an algorithm. I am not sure about the name of the algorithm. I guess it is a reverse traffic algorithm, something like that. That is part of CSMA CD. You can read about it. It's part of the digital signal communication. There is a subject in BTech, digital signal communication. You can study CSMA CD with regards to that LTM GT. So you can read about that. So there is a, I guess that algorithm is reverse something algorithm. The moment collision happens, because of that algorithm, hub stops the traffic flow for certain milliseconds. So that is why we say entire hub is stopping the traffic flow for all the interfaces. So that is why we say that hubs are in single collision domain. Because one collision is affecting entire hub's traffic flow. If I remember exactly, in CSMA CD, there are three things that happen. First is the collision sense. Collision sense. In collision sense, I believe before sending out the traffic over the, over your hub, before traffic is sent, let's say it has multiple devices. It asks it asks whether anyone else is sending any traffic or not. It uses some internal algorithms. Let's say this is device A, B, C. So A will ask anyone else there? Yes or no? If no, then he will send its traffic across the terminal. Okay, this is collision sense. Then you have multiple access. In multiple access, what happens is in collision sense, he didn't got any reply. Okay, if no reply is received, that means no device is sending his traffic. In multiple access, A, B, C. Okay, something he has to send the traffic. B also has to send the traffic at the same point of time. So that means multiple devices wants to send their traffic over the terminal. So this is multiple access. So what will happen in this case? One of the devices will wait. One of them will wait. There is some reverse traffic algorithm. One of them will wait for certain milliseconds, and then the first one, whomsoever has sent the message first, whomsoever has sent the message first among them will be able to send his traffic. Then we have collision detection. In collision detection, collision detection is some miscommunication happened, and because of that, collision happened. This also sent, he also sent. So collision happened. Now what will happen? Hub will stop the flow. So this is CSMA CD. If you want to read about CSMA CD in further details, I'll tell you the name of the book. I don't remember exactly, but I think it was digital signal processing. I don't remember the name of the writer, to be honest, because it's very long. You can read about it over there. You don't, in practicality, you don't require it more than this. You got the concept that in half duplex, if both the receiving and transmit traffic are sent at one point of time, they will collide, collision will occur, hub will stay for some point, some period of time. Same thing doesn't happen in a switch. If I talk about a switch, PC, PC, PC. Same thing cannot happen in a switch. Why? Because switches operates in full duplex mode. They can transmit, they can receive at the same time. Okay, so no chances of collision. And even in half duplex as well, there will be no collision. I'll tell you why when we will study cabling. Okay. So that is why we also say that the switches are in per port collision domain. And even if by any XYZ reason, by any chance, let's say a collision happened due to some latency or anything, any XYZ crosstalk region, it could be anything. Let's say collision happened. So collision will remain in that specific interface only. It will not cross the switch. It will not go to any other interfaces. So switch will not hold entire traffic flow because of some collision happened in its one of the interfaces. Hub is programmed like that. Switches aren't. Same thing goes for my router as well. Okay, same thing goes for my router as well. If a collision will happen on one of the interfaces of router due to any XYZ reason, router will not the entire traffic flow. Router will not stop the entire traffic flow. It will let the traffic flow across the remaining of its interfaces. That's why we say that switches and routers are in per port collision domain. Okay.
Sir, in broadcast domain, switch was had one broadcast domain.
In switch has one broadcast domain, and in collision it has per port collision domain.
Okay.
Same topology. Okay, same topology. Tell me the collision domains I have.
Seven.
Yes, sir. 7.
Collision domain 1, collision domain 2, collision domain 3. This collision domain is common for router and switch. So in region 1, 3 collision domains. Okay, plus let's come to region 2, hub. This entire is in single collision domain. 1. Okay, let's move here. 1 collision domain, 2 collision domain, 3 collision domain, 3 and 1 collision domain. For this also 1 collision domain. 1, 2, 3, 4, 5 plus 5, 9. These are also switches, now. This collision domain is common between them, but this is the individual collision domain of the switch. Is it clear?
Yes, sir.
Okay. So this is about collision domain and broadcast domain. Okay, let's talk about cables. We'll not discuss much. Okay, we'll talk about only basic things. What is a cable? Transmission media. This is something which could be asked from very freshers. So we'll not discuss much, only 10 minutes, 15 minutes, that's it. Transmission media. What are the types of cables we have? Coaxial cable. And this is the first type of cable that we'll study. What is coaxial cable? Anyone aware of it? Copper wires. Long copper wires. Okay, they carry data in electrical signal format. Okay, basically they were used in bus topology. Second thing we have twisted pair cable. The cable is the updated form of coaxial cable. Okay, the cable has twisted pairs of wire. I hope everyone have seen these cables. Copper wires are very common and twisted pairs are very common. They are twisted, one cable is twisted on the another. Have you seen them? They're very common.
Yes, sir. Straight through cable and crossover cable, right, sir?
Twisted pair, yeah, they are further, they are, updated in that as well. Basically, there are 2 or 4 pair of cables that are twisted on one another. Pair of cables twisted on one another. Okay. Twisted pair cables are of 2 types, STP and UTP. Shielded twisted pair and unshielded twisted pair. And unshielded twisted pair. Okay. Nothing in shielded twisted pairs. The wires are shielded with foils actually. Shielded with foils to avoid EMI, electromagnetic interference. In UTP, wires are not shielded. Okay. Then after coaxial cable, twisted pair cables, you have optical fibers. Optical fiber communication is a topic in itself. Okay. Optical fiber. BTech who are done with their BTechs, they must have studied optical fiber communication, and who are still pursuing their BTechs, guys, you will study optical fiber communication in either semester 6th or 7th, if I'm not wrong. You will study it in great detail, and you will probably read one of the worst books that are ever written, Guard Keyser. I still remember that book name, Guard Keyser. For optical fiber communication, you can search about it right now itself. It's one of the worst books written ever. Gard Keyser is a great, scientist in the domain who teaches in University of Boston. I had a chance to meet him as well once. In this cable, data is transmitted in the form of light. Okay, in the form of light. The wire works on the basis of the principle total internal reflection. TIR, the concept of TIR. Guys, optical fiber, anything optical fiber wire, it has 2 parts basically. Core and cladding. Guys, I hope you're not getting bored till this point. In case you feel like it's getting bored or it's getting too theoretical, let me know.
No, it's a good.
Basically, this is core. Okay, inside a core, you have a cladding. Okay, how traffic communicates? A light will strike the cladding. Okay, and mechanism of total internal reflection will take place. It will hit, it will reflect it further like this. I hope you must be aware about the mechanism of total internal reflection. We must have studied. All of us must have studied this in
Yes, sir.
either class 12th in optical fiber or in optical fiber communication and BTech. Core, cladding. Okay. So core is, core or this, I written it opposite actually. Outer is cladding, internal is core.
Yes.
This is core.
Yeah. I got confused when you wrote that. Yeah.
This is cladding. Okay, so that's how it works in optical fiber. The core is like a glass-like material. It's not a glass, but it's a glass-like material due to which your, reflections happen. Okay, there are two types of optical fibers, single mode fiber and multiple mode fiber. In a single mode, only single wavelength is there, single light wavelength. Single light wavelength can communicate or can travel in a core, but in multiple modes, multiple light wavelengths can travel. Okay. Let's move to next type of. These are all theoretical ones. Okay. What is SFP? Small form factor. SFP. Small form factor. Anyone aware about this? Portable
Module connector.
Yes, portable module used to connect switch with fiber. Okay, guys, we have Ethernet cables. Earlier, we used to have in the very initial part of the like devices when initial devices were there, switches, routers, they only have Ethernet slots. Okay, the wire slots, the cable slots, they were only for Ethernet. But now we have specific slots for optical fibers as well. Those slots are known as SFP slots. In the higher end devices. Okay, over there you can connect your optical fiber. Okay. What is straight through cable? Let's talk about some networking as well. Straight through cable. Straight through cable. Tell me, what is straight through cable? Cables which are used to connect different devices. As simple as that. Cables which are used to connect different devices. like switch and a router. PC and switch, different devices. They are known as straight through cables. Okay. Then we have, after straight through cables, we have crossover cables. Cables which are used to connect same devices. Switch and switch, router and router. Switch and switch, router and router. Etc. Okay, they are known as crossover cables. Always remember that there are some exceptions as well. There are some exceptions like PC and routers are connected with crossover cables. Servers and routers are also connected with crossover cables. Okay. Basically, a router or a switch. Your last type, first let me discuss the last type of your cabling. Last is your rollover cable. Or your console cable. It is also known as console cable, which is used by end devices to connect, which is used by end devices to connect with the layer 2 or layer 3 devices for the configurational access. When we connect to a device directly so that we can see. You guys must be wondering, I'm writing layer 2, layer 3, then what is the difference between rollover and other cables? See, other cables which I am connecting like straight through crossover, they are connected so that PC can send its traffic to the next hop and then next hop can send it to the internet. But rollover cable is the cable or console cable is the cable through which when you are connecting to a device, you are taking the access of the device. You got the difference between the two? Yes or no? Straight through and crossover, they are sending my traffic towards the other hop and then other hop will send it to the internet. It is for the communication purpose. But rollover cable is the cable through which I am accessing the device and then doing some changes in the device. Is it understood? Yes or no?
Yes, sir. Understood,
Yes.
sir.
Okay, cool. .568A and 568B, color coding schemes of your cables that you can study on your own. It's not much. If you write it in a simple Google, you will get it. Neither anyone will ask you in an interview, or nor it is that much of a required from a backend or a front-end network engineer. Now let's study about the memories of the devices. Okay, we have following memories: RAM, ROM, NVRAM, and your flash memory, which is also known as EEPROM, electrically erasable programmable read-only memory. Okay, I hope everyone is aware what is RAM, what is ROM. Okay, if not, then you need to remember RAM is random access memory, which is volatile in nature. Power goes off, RAM is lost. ROM, read-only memory. Read-only memory, it is non-volatile in nature. If power goes off, ROM will not go off. Okay. NVRAM. NVRAM. Non-volatile. Non-volatile random access memory. A type of RAM which is non-volatile in nature. That means power of memory not lost in that case. A normal RAM is a RAM in which power is off, memory is off. In ROM, power is off, memory is not off. That is why we say ROM is non-volatile. Same goes with NVRAM. It is non-volatile RAM. If power is off, then memory, that specific RAM will not be lost. So that type of memory is known as NVRAM. Flash memory is the memory, electrically erasable programmable read-only memory. Content can be in a normal ROM, it is read only. Normal ROM is your read only. It's not write. It's not writable. But flash memory is a memory which is for both purposes, read and write. You can erase as well. You can erase the memory as well. So these are the four types of memories we have. If I talk about their examples with regards to a device, best example of RAM is routing table. Routing table is if my power will go away. If my power will go away, definitely my routing table will be lost. The moment power will be back, my router will re-establishes the routing neighborship with the other hop devices, as well as it will read out the static routes and it will build its own routing table again. So that is why we say that routing table is part of my RAM memory. Your ARP table. Again, ARP is also something which will go away. It needs to be built on its own. Your running configuration. Okay, buffer memory, etc., etc., etc. Now, what is an example of ROM? That is read-only memory. that you can't change. You cannot play with it. Your post process, power on self test. Post is power on self test. What is post? We'll talk about it after this on. What is post? I'll tell you in great detail, maybe after break. Post, bootstrap program. You cannot change that. You cannot change bootstrap program, the program that is run internally on the device through which the device is working. We cannot change that. Then you have mini iOS. Mini iOS is used in case of, I'll show you mini iOS as well when we will do password recovery. That is in case you lose your password of the device. Mini iOS, ROM monitor. So these are the few examples of your RAM in a networking device. Then you have NVRAM. Best example of NVRAM, your startup configuration. I'll tell you the bootstrap process, then only you will understand why I'm putting startup configuration in NVRAM and why running configuration is part of RAM. Startup configuration, it will always remain in the device. My configuration will not go away unless and until it is not erased. Your registry values, your register values. Then you have your EEPROM. It contains the iOS image of the router.
And Sumit sir, these things are same for Nexus OS also, or no?
Yes, absolutely. Now let me okay, let's study about the bootstrap process. How many of you are aware about the bootstrap process, booting process?
I don't know, sir, actually.
Booting process of a router. I can bet you nobody will touch this topic because it is very complicated. That's why you are hearing it for the first time. Okay. Booting. Booting means when a device is turned on. The moment the device is turned on to the moment you get the configuration terminal or your you get into the user or your privilege mode. What are the steps that goes behind? How you get the ultimate thing in front of you the moment you power on your device? What exactly happens? Step number one. Step number one. When the device is powered on. When the device is powered on, post process will happen. Will happen. Okay. What is post? Post stands for power on self test. What will happen in post? In post, the device will check that all the hardware components are working or not. Okay, that means it will check the interface, it will check the all the temperature related things, environmental things. Okay, everything related to your hardware will be checked in post test first. Power on self test. Okay, that every hardware component is working fine or not. Then step number 2. In Bootstrap program, or you can say the Bootstrap program will run. Now the Bootstrap will start. The Bootstrap program will run, and it will try to load iOS image. It will try to load iOS image in RAM. We need an operating system to work, right? What is the name of the operating system in Cisco? iOS. Like Windows have OS, Windows 10, Windows something, something, something. Kali Linux has its version. Every device has its OS version. Cisco's OS versions are known as iOS. Okay, iOS stands for interoperating system. Okay, iOS versions. So these are known as iOS images that are loaded and through which Cisco takes its operating system. So my hardware is done. Once hardware is done, what I need an operating system to work, right? So hardware check done, then my device will start looking for the iOS image. Okay, it will go through the RAM. It will check whether I have the iOS image in my RAM or not. Configuration okay, configuration register values are used. Configuration register values are used to load the iOS. Are used to load the iOS configuration. Configurations are used to load the iOS. Okay, whose default value is. If you give your CCNA, CCNP exam, written exam, CCNP and core, this question could come in your certification. What is the default value of the configuration register in which your iOS image is loaded? So obviously in my memory, there are certain registry values. OK, you cannot go anywhere and you can take it out. OK, by default, the value on which your iOS image is stored is 0x2102. This is the location on which your iOS image is stored. So first it will check whether it's there or not. OK, and this location is in your flash. OK, so I need a iOS image in my RAM, and first it will be checked in the configuration register value 0x2102, which is where, which is first it will be checked in iOS image will be checked iOS image will be checked from flash first. Okay, from the flash. It will check the flash memory. If it is kept in the flash memory, it's fine. Otherwise, it will go to the next step. If iOS is found, then it will be loaded in RAM. Second, if iOS not found in flash, then if iOS is not found in flash, then TFTP configured server will be checked. For iOS. What is TFTP? TFTP is an external server on which you keep your important things. So it will check whether my iOS is kept externally in any TFTP server. Okay. So iOS will be checked. So TFTP will be checked for iOS. Okay. If found, it's okay. If not found, then it will go to step number 3. If iOS not found in TFTP, if iOS is not found in TFTP, then device will load mini iOS. From ROM. Okay. From here, we can load iOS image into Flash. What I'm trying to say over here, if I'm not getting my iOS in Flash, if I'm not getting my iOS in TFTP, then mini iOS will be loaded in your device. In mini iOS, you will not be able to perform 100% of the original features that are provided to you in iOS. You will be provided only with certain features, and one of them features is loading iOS image by yourself. So what you can do, the moment mini iOS is loaded, you can take the access of your device. You can load iOS image through yourself in your Flash. And once it will be loaded in the Flash, you can reboot the device and it will take out the loaded iOS image by himself. Do you got my point? What I'm trying to say? Yes or no?
Yes, sir.
Clear.
Okay. A mini iOS will be loaded, and in that mini iOS, you will have certain features, and using those certain features, you can load your iOS by yourself. Once you have loaded the iOS, then reboot. Then in the next reboot, it will see that you have loaded an iOS in the Flash. So over in the first step itself, it will find the iOS and then it will boot accordingly. Okay. Last feature, last part of the booting process is now I'm done with two things. I'm done with my hardware testing. I've got my operating system. Now what is next? Configuration. Configuration. Once the iOS image is loaded into the RAM, the router for your device, any device, the router will check the router will check NVRAM for startup configuration. It will see whether you have saved any configuration or not, whether there is an existing configuration for this device or not. Okay, and again, this is done with register value of 0x2102. Okay. If
2102.
learn it, cram it. It's literally, if you are giving if you're giving certification on your own, definitely a question will come. If startup configuration file, don't expect anyone to ask you this in real time. Nobody will, because nobody is aware of it. I can bet my life on this. In no interview whatsoever will ask booting process of a device. Neither any interviewer nor anyone else will teach you this, because this is completely useless. But to have a good understanding of a device, you need to know about this. If startup configuration file is found, the startup configuration file is found, it will be loaded. If not found, then step B will happen. Then the router will start from setup mode. The mode that you get when you turn on a brand new router, setup mode, that you have to configure everything for yourself. So this is your bootstrap process or booting strap process of your router or your any Cisco device. Okay, three things happen: power on self-test, iOS loading, then after iOS, you have your configuration loading. Let's take a break of few minutes. Okay, it's 13:05 right now. I'll meet you
Sumit,
at
okay, I'm good.
13:30. Just a moment. Yeah. One more thing prior to you guys taking screenshot, let me draw the flow chart for you as well. Okay. So that you can relate. Post. Okay. After post, you have after post configuration. This is find iOS. Okay. Yes, if it's found, then it will go to next step. If not, then it will check first flash. Okay, if it's not found in flash, then it will go to TFTP. TFTP server, then it will go to ROM. Okay. And if it is found, then load iOS. Once iOS is loaded, then go to NVRAM. In NVRAM, what we are doing, we are finding the configuration file. Okay. In NVRAM, if configuration is not found, then it will go to setup mode. If it is found, yes, then it will load the startup configuration. Okay, so now you can take the screenshot if you want. Tomorrow will be your practical session only, guys. So I think tomorrow I'll do it on packet trace set initially. Okay, then we'll gradually move to EVNs because I need TFTP servers and all initially to show you the password recovery, iOS and all those. If I'll use EVNG, then I need to share a lot of things with you. I need to share even the server images as well. Okay. I hope it's clear to you.
Sir, at what time the class would end?
Today? Okay, you guys need to travel, right?
Yes, sir.
Let me end in few minutes, okay? Another 25 minutes I'll end, okay?
Sure, sir. Okay, sir, no problem.
Okay. So let's talk about OSI model now. We'll discuss both OSI as well as TCP/IP, okay? Full form of OSI: Open System Interconnection. Okay. It was developed by whom? It was developed by ISO. What is ISO? International Standard Organization. Then it was developed by ISO. It is a reference model. Why exactly OSI model was developed? These are okay. I know these are the theoretical points, but what was the need of OSI? Anyone? Why OSI was developed basically? OSI was developed so that different vendors can communicate among themselves. OSI gave a reference, okay? It gave a reference lines. It gives a reference layers that if we will follow this reference layered model, then any vendor can communicate with any vendor. Dell can communicate with Lenovo. Cisco can communicate with Palo Alto. Palo can communicate with FortiGate. Huawei can communicate with Aruba. Anyone can communicate with anyone. That was the basis behind giving this reference model. And this reference model was like the backbone of the communication. It is a reference model. It is a layered approach. It is a layered approach. It is a layered approach. OSI was developed so that different vendor devices can communicate with one another. Okay, the 7 layers OSI, as I wrote that it's a layered approach. So what is the layered approach? That layered approach has 7 layers. There are 7 layers in OSI model. Those 7 layers are, let's talk about, yeah, let's, first layer is the physical layer. Okay, second layer is your data link layer. Third layer is your network layer. Fourth layer is your transport layer. Next is your session layer. Next is your presentation. Last but not the least, you have your application layer. So these are your 7 layers of OSI model. Okay. In TCP/IP, they come down to 4 that we'll discuss in TCP/IP. Okay. So let's start talking about each of them one by one. Okay. I'm starting with the bottom one first, application. Okay. Okay. So what exactly is application layer? Anyone? What exactly application layer does? Anyone? No?
The interaction between user and the computer.
Yes. Communicating software. This layer acts as an interface. This layer acts as an interface in between this layer acts as an interface in between, not user, between application and communicating software. What exactly I'm trying to say over here? I have a Chrome. What is Chrome? Chrome is my communicating software. Okay. Through Chrome, I will communicate with certain web pages, right? Or with certain servers. Through those servers, I'll get their web access. So that is how Chrome is. So with Chrome, my web browser, I am taking accesses of certain web pages. But how? I need to use some protocol. I need to use some protocols so that I can access those web servers or those web pages through my software. And what are those protocols? Those protocols are HTTP and HTTPS colon google.com, right? HTTPS clickinfo.com. So what is this HTTP and HTTPS? They are application layer protocol that are helping out my communicating software, which is Google Chrome and Clickinfo's web server or Clickinfo's web page, right? Yes or no? See, I have a software and then we have a server. Okay. Yes, we do have them. We have all the communication media, but how will they communicate over the media? We need to initiate a connection. We need to use some protocols. We need to define some rules that this will go and that will come, right? So who is providing that? HTTP and HTTPS are providing that. Similarly, for any services of application layer, we have a dedicated protocols that help out the communicating software and the end server to communicate. See, now that server, now you can, I don't know how many of you are aware about it or not, but your destination server could have multiple services enabled. In a small organization, I'm using same server for DNS. I'm using same server for Active Directory. I'm using same server for web services. A DNS data is there. A DNS entries are there. I'm using the server for DNS data. I'm using same server for my user Active Directories, which has the user database. I'm using the same server for web services as well. So which service needs to be taken out? Who will decide that? What I need. See, I am trying to access that server, but what I need out of that server, I need web services out of that server, right? So who will provide me? Who will lay out that this is how you need to request this server so that it will give you web services. This is how you need to access this server so that it will give you DNS services. All these things are decided with the help of application layers protocols. Am I clear with it? Various various services like web services, various services like web services, file services, remote services, okay, time services, management services, mail services. How do I need to access a particular server so that it will give me the following services? I need to use application layer protocol. Now tell me, specifically experienced candidates. Sorry, guys. What are the protocols for web services? Tell me the protocols for web services which are used by application layer. Right? HTTP and HTTPS. For file services.
FTP.
FTP. TFTP. SFTP. Right? Remote services. Remote services. Telnet and
Telnet, SSH.
SSH. Okay. Time. Who will tell me? Time services.
NTP server. NTP.
NTP. Network time protocol. Management.
SNMP, sir.
SNMP. Okay. Mail.
SMTP.
SMTP. And many more. Many more. Okay, we have multiple protocols, but who will decide that how you will access a web server? Through what services you will access a destination web server? That is decided by the application layer and its protocols. Okay. Now we have presentation layer. After application, we have presentation layer. What exactly presentation layer does? Application is done. In TCP IP, we don't have presentation layer. Or we can say your presentation layers things are managed by your application layer only. But what exactly presentation layer does?
Represent format.
At this layer, data is presented in an standard format. Example, ASCII. What is ASCII? American Standard Code for Information Interchange. ASCII. So whatever communication that is happening using the normal language like HTTPS colon google.com, something ClickBuzz, ClickInfo, Insta, something, whatever it is, they are all in ASCII format. Does machine understand ASCII format? No. So in presentation layer, data is converted into a standard format. So ASCII will be converted into ASCII will be converted into EBCDIC. What is EBCDIC format?
EB.
Extended binary.
Binary. Coded decimal interchange code. So ASCII will be converted into binary in short. Okay. Encryption, decryption, compression, and decompression of user data also happens at this layer. Okay. So these are your two layers. Just one more layer, guys. Session layer. The rest we will discuss tomorrow. Okay. Guys, did you practice subnetting in the last 1 week?
Yes, sir.
Why, guys? Do you want to forget that? You need to make it a habit. 5-10 minutes daily. That's it. Anywhere while you are traveling, while you are in a metro, while you are what I don't want to say it on recording, but after recording, I'll tell. You can do it in that period as well. So just 5-10 minutes in your phone, open your phone, open subnetting.org and do it. That's it. How long it will take? Take out your phone, open subnetting.org, watch 10 reels less, watch 10 less reels, and spend that 10 odd minutes in subnetting.org. It will help you out in your job, in your anything, whatever you will do. Okay. Session layer, this layer creates, this layer creates, maintains, maintains and terminates okay. This is done with the help of session ID. This is done with the help of a session ID. And lastly, this layer separates different application data from one another. See, quick info, right? Let's open two different tabs. One is schedule and one is Teams. Okay, one is Teams data and one is schedule data. If I'll refresh this Teams, okay, if I'll refresh this Teams and if I'll refresh this Teams data, do you get anything else apart from that? Is it like I'm refreshing schedule and I'm getting the output of Teams? No, it doesn't happen. Why? Because both sessions are allocated their individual session IDs that are helped to identify the different sessions. Otherwise, if you see, both communications are using same source IP, same destination IP, same source MAC, same destination MAC, then how are we identifying which is different from one another with the help of a session ID, which is provided in the session layer of OSI model. I hope it's clear to you guys. That is it for the day. Okay. I'll see you tomorrow at 12 only. So tomorrow I'll take just a moment, guys. Okay, so anyone aware about transport layer? Anyone wants to say anything? What is the use of transport layer? Transport layer is used to provide end-to-end. Transport layer is used to provide end-to-end data transport services. When I'm trying to say data transport services, that means transport layer is responsible for the data to go from one point to another point. How it will go, that will be held responsible by your layer 3 and layer 2, but overall your transport layer is the one which sends the data accordingly with the help of layer 3 and layer 2 from one end to another end. Okay, and transport layer is also responsible for transport layer segments. Anyone aware about segmentation? No. Segments and reassembles. Transport layer segments and reassembles data into data stream. Whenever you receive a traffic from one end to another end, you don't receive the traffic as a whole, right? You receive segments of it. All those segments are reassembled in your transport layer. That is the one use of transport layer. And what are the two major protocols we have in transport layer?
TCP UDP.
Absolutely. Two protocols of transport layer are TCP and UDP. Both protocols are responsible to send the traffic from one end to another end. The only difference between the two is TCP creates a connection and then it sends, and UDP sends it straight away. Right? Let's discuss the differences between the two. Okay, tell me the differences between TCP and UDP. One of the most basic questions of the domain.
In TCP, so three-way handshake will happen. In UDP, no handshake.
So what do you call the three-way handshake?
Connected, oriented, and connectionless.
Yes, it is connection. It is connection oriented protocol. What about UDP? It is connection less protocol. When I'm saying connection oriented, that means I'm talking about three-way handshake, which we will discuss after the differences. What TCP does, TCP forms a connection and then it sends the traffic. Second point, we can arrange the receiving traffic in a sequence. That means if you receive any out of order packet in TCP, you can rearrange them. But in UDP, we cannot arrange the traffic according to sequence numbers. Okay. Third point, data retransmission can be done. Data retransmission can be done. You can retransmit the data. But in UDP, you cannot retransmit the data. Data retransmission can't be done. It is a reliable protocol. What do you mean by reliable? Anyone?
Yeah, it will provide the acknowledgements for each data packet.
Reliability is like a surety. Anything I have sent, it will be received by the destination. And how it is achieved? It is achieved with the help of the mechanism of, as you said, acknowledgement. UDP is not a reliable protocol. Okay. Next point. What else? Tell me, guys, what else we can have?
So flow control, TCP.
Flow control can be achieved in TCP, and flow control can't be achieved in TCP, right? Next point. What else?
TCP is slower than UDP.
Yes, TCP is slower than UDP. Why TCP is slower than UDP?
Because of acknowledgement
Because of
messages.
reliability.
Yes, because of reliability. TCP is slow protocol. UDP is fast protocol. What else? There can be many things.
Header size, sir.
Header size. Yeah. Header size of TCP is
20 bytes.
What is the header size of UDP?
8 byte.
Header size is 8 bytes. Okay. After header size, what else?
No error checking in UDP.
Reliability, same thing.
Okay.
Sir, congestion control like in TCP, sir, like
Congestion control, ECR, explicit congestion, no, not ECR, ECN.
Notification.
Explicit control notification and congestion window reduce mechanism is in TCP. No congestion control in UDP. What else? Windowing. Windowing is used in TCP, right?
Yes, sir,
Windowing is not used in TCP. Then after windowing, four-way handshake. What is the use of four-way handshake in TCP?
Connection closing, sir.
Reliable or graceful connection close? No, graceful connection close in UDP. Okay, what else? 10 points are there. What about rest? Header size. I guess 10 is more than sufficient. If you answer 10 points in an interview, at number 5 or 6, he himself will tell you that's it. But again, no answer is complete without examples. So, protocols that use TCP at layer 4 are, which application layer protocol uses TCP at layer 4?
BGP, sir.
Tell me. BGP. Okay. Yes, you are right. BGP does use. What else?
Telnet, SSH, HTTP.
Telnet, SSH, etc. Right?
Yes, sir.
Then protocols that use UDP at layer 4. Which protocols uses UDP at layer 4? Come on, tell me. DNS,
DHCP, NTP,
DHCP, NTP, etc.
SNMP,
Does
sir.
DNS uses only UDP?
Both,
No,
sir.
it also uses
Sometimes
Hmm?
it produces
Does
both the
DNS
DNS,
uses? Yes, DNS
UDP, and
uses
TCP.
both UDP and TCP. DNS uses both TCP and UDP. When it uses, I'll tell you in the DNS traffic flow. Then we have segmentation is done in TCP. Segmentation is not done in UDP. So this is your difference. I think this 12-point difference is more than sufficient for you guys. Anytime someone asks you about the differences, you can straight away let them know. Let's talk about the differences one by one. Okay, first we talked about connection orientation. What do you mean by connection orientation? It implies that every time before initiation of traffic, a connection will be formed with the client and server, in which both of them will advertise their communication parameters. What do you mean by communication parameters? Like what is my sequence number? What is the acknowledgement number? What is the window size? What will be my MSS, MTU, all those things, whether I'm using selective acknowledgement, all the header part. Tell me one thing, specifically those who are already, working in the domain, is window size negotiated or is window size advertised?
Advertised.
I have taken hundreds of interviews in which people say that window size is negotiated because we have read somewhere in the book. In which book we are not aware, we don't remember. They say that window size, least window size is taken. This is a misconception, guys. If you read RFC, you will get to know window size is not like this. Client has a different window size and server has a different window size. Both of them advertises their window size. What is window size? We'll talk about that as well. This is a client. This is a server. This client wants to have a communication with the server. Let's say the server is the Google itself. http://google.com. Let's say this is a Google server itself. Client wants to have a communication or client wants to access Google server. What will happen? First, I'm using HTTP. I'm not using HTTPS. Anyhow, even if you will use HTTPS, then also three-way handshake will come first. Okay. I hope networking people are very well aware of the fact that what happens first, three-way handshake or SSL handshake? If I'm using HTTP, absolutely. Or this is also an interview question, guys. Sometimes I don't believe the people with 10 years of experience, 12 years of experience, they just say anything. So they say SSL handshake takes place because it is layer 7 thing. I don't know why people are like three-way handshake. The connection between them is formed using three-way handshake. In three-way handshake, the client and the server will send their communication parameters to one another. Since client is the first one to initiate a connection, because definitely you will be the one who is going to type https://google.com. So you will send the first packet towards the server. So the very first packet that you will send towards the server. Okay, I'm not saying very first packet you will send. Why? Because the very first packet, if I'm typing https://google.com, what will be the first? Yes, DNS will be the first packet. So the first packet that you will send towards the server will be your SYN packet or SYN segment. What do you mean by SYN? Three-way handshake is very simple. SYN plus ACK. Finished. That's it. But is it like this? Seriously? Do you think it's like this? We all know it isn't. SYN is what? My synchronization. And ACK stands for my acknowledgement number. What exactly they said? What exactly SYN is sending? What exactly SYN plus ACK is? In SYN, client will send his sequence number. It can be any random sequence number, anything. Okay, what is the purpose of sending that sequence number? Purpose of sending that sequence number is from this sequence, I will send my data. any traffic that is sent in TCP with the help of TCP has a sequence number associated with it. Okay, based on the sequence number only, rearrangement, retransmission, acknowledgement, all these things are done. What exactly is acknowledgement? If I am sending a send packet, what exactly I am receiving in acknowledgement? Nothing. +1. Acknowledgement is always sequence number +1. Always. That means the destination is trying to tell you that I have received this much of data. Now I'm expecting next bit. I'll show you with the Wireshark. Let me see whether I can show it to you with the Wireshark. Just give me a moment. Okay, so I have captured a stream. Let me see. Okay, this is a UDP stream. This seems to be a TCP stream. Yeah. Let's close it. Send message, synac, ACK. Can you see this on my screen, everyone?
Yes,
See,
sir.
let me open the first. The moment he sends the send packet, what exactly he sent? Flags, all these things. I don't want you to focus over here right now. Okay, focus over here. Source port, destination port, sequence number 330-338-770-5058. This is the sequence number, right? Next sequence number, nothing, forget about it. Can you see this sequence number 58? That means this 29.185, I'll tell you 29.185 is my machine, and I believe this is the Google's IP. My machine to Google IP, send packet, sequence number, this 58. Let's see what synac I'm getting from the Google. In reply to the Google is sending his own sequence number that he will use for his data transmission. 320443 something. What was mine? 330. What I'm getting from him? 320 something. Just see the acknowledgement number that he sent me. 33877050559. If I'll check mine, what was mine? I sent to him 58. What I got? 59. What do you mean by this? This means till 58. That Google server is trying to tell me that I have received everything till 58. Now I am expecting you to send me 58 onwards starting from 59. Have you got my point? Yes or no? Same.
Yes, sir.
Same thing. Sequence number 76. The acknowledgement which I will send to him is 77. That's how sequence number and acknowledgement number works. In the next few traffic, definitely it will be differed. Why? Because of the size of the data length. Okay, the next data length will be the next acknowledgement number that you will send here onwards will be your sequence number plus data length. In synac app, you don't have that thing. Why? Because we are not sending any data. We are only sending our communication parameters. That what sequence number I'll use for my communication, what will be my acknowledgement number, what will be my window size. Okay, this is the window size that I'm sending. What will be my other option feeds that I am opting out? Or everything we'll discuss. So what exactly three-way handshake does? Three-way handshake simply tells the other other peer, that this will be my communication parameters that I will use. Everything related to TCP header that I am going to use and what Google will use, both of them will be exchanged in the SYNAC message itself. Whether it's sequence number, whether it's acknowledgement number, whether it's anything, window size, whether I'm using selective window, selective acknowledgement or not. What is selective acknowledgement? Anyone? What is window scaling factor? Anyone aware about these two terms? No worries, no problems. After this batch, you will be aware about these terms. Okay, I hope three-way handshake is clear to you guys. Even in this example itself, you can see one more thing. TCP, 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 then TLS, client hello. Can you see this? First three-way handshake, then SSL handshake. Okay, so let's move to our second point. Guys,
Sumit
I
sir,
discuss more
I have
about
seen
sequence. Yeah, go ahead.
actually after client TLS we saw I mean we can see again this this TCP retransmissions. So can you just
This is
reassemble
client
it
hello.
and then
Yeah,
again
they are random packets. You can ignore them. They are random packets. There are certain irrelevant and random packets as well in the communication. This is client hello, that client send, and this is the server hello. These are random packets in between. This is the
so
server hello, client
mhm.
hello, server hello, and then the client exchange in which the key will be sent from the my end to the server, and ultimately after this this message will send the PMSK pre-master secret key. After PMSK, both the client and server will generate a master secret key, and using master secret key they will do the communication encryption. These are
Sir,
random
is there
packets
is
in between.
sir, is there is a means between the TCP three-way handshake and SSL handshake between HTTP request and response will be there? Is there is something like that
After
or
SSL handshake, after SSL handshake, that will be the HTTP stream. That will be first three-way, then SSL, then HTTP.
thank you.
Okay.
Or sir, what is SSL handshake?
Okay. SSL handshake. You need to wait for SSL handshake actually. I can tell you over here, but it will be, a bouncer for the over for you. So better not to touch that topic because it will be too advanced for you. No.
Okay, sir.
Okay, I'm happy to tell, but I know for the experienced candidates, it will be an plus plus for them as SSL handshake is not part of this course. But still, if you want me to tell you, I'm happy to tell you, but you need to wait for certain days for that because SSL handshake is comes in the advanced VPN.
Okay, sir.
Okay, so just wait for it. It will be too early for you guys. Am I right?
Yes, sir. Okay.
Experienced candidates?
Yes.
Yes, Sumit.
Data sequencing and receiving end. Guys, I will leave you early today. I might leave you by 1 today itself. We may not have second half because my wife is telling we have to do that Durga Puja. Whatever that ritual is, I completely forgot. That also is there. I wasn't aware today is
That is
that.
important, Sumit.
No problem.
Yeah, come again, guys.
I told that is more important. You need to keep the home minister happy always.
Yes, absolutely. If home ministry is not happy, you don't get food. Okay, let's suppose we have a stream like this. hello hour, simple stream, let's say. Though obviously these are the sequence number I'm taking. Definitely sequence number are not like this. Okay, as we have seen in our Wireshark capture itself, you can see there are proper sequence numbers, but it's not always 1 2 3 4. I'll be taking these small sequence numbers just so that you guys can understand. Okay. Okay. Data sequencing. Sometimes, see, before sending out the traffic, as we all know, segmentation and fragmentation is done. That means traffic is divided into small chunks, then it is forwarded. There is a huge possibility that over the internet, when you are sending the data, before reaching out to destination end, let's say hello is sent differently. All of them are sent differently. Okay, so let's suppose when they are sent differently, let's say how or r or something, whatever, it got some latency in the network, some terrain, something would have happened. Because of that, some would have reached earlier and some would have reached late, like this. So TCP provides a very good mechanism of sequencing. So the moment they will be reached on the destination end, what the receiver will do? Receiver will check the sequence number. Receiver will check sequence number and he will put them in the right order, like this. So what you need to understand, you need to understand the concept of sequencing. With sequencing, we can achieve multiple things. Concept is only one, sequencing. With sequencing, we achieved first thing, connection orientation. Second thing we achieved, data sequencing. Just give me a moment, guys. This call is important.
Vocês já tá campando live location Souza? Até tu quer que outro que são
I start getting calls that I need to go. Connection orientation, data sequencing. This is achieved. And same thing goes with data retransmission. Just imagine same thing happened. Okay. 1 2 3 4 1 4 3 2. Something got missed. Let's say R didn't reached. Let's say R didn't reach. So you got it like this. Hello. So 1 2 4. So I knew that sequence number 3 is missing. Sequence 3 missing. So in such case, what will happen? I'll get the message acknowledgement 3. Acknowledgement 3 means I need. What do you mean by acknowledgement 3, guys? I just told you. You will get the acknowledgement for the packet that you want to be accept, that you want to receive first. So the moment sender will get acknowledgement 3, what does that mean? That means that receiver has received till sequence number 2. Send him sequence number 3 onwards. So this will send him not only R but also U. Okay, both will be sent, and ultimately he'll get those R and U. And like this, your data retransmission can also be achieved with the help of sequence number. Don't ask me that why we sent U again. I'll tell you in few minutes, maybe today or maybe next week, because that can be avoided with the help of SAC, selective acknowledgement. Okay, generally what happens, guys, this is sort of a disadvantage of TCP, that if you have, okay, let me explain it. If it's come, let me clear it here itself. Okay, let's say we have 10 packets, 1 2 3 4 5 6 7 8 9 10. Okay, sender, and let's say this is my receiver. Okay, let's say packet number 1 is sent.
Sumit sir, can you just repeat what were this, because I got a call in between. So
What exactly, buddy? Data retransmission, right? I'm explaining retransmission through this example only. Okay. Okay, so sequence, let's say sequence number 1 will go, you will get acknowledgement 1, right? Similarly, 2, 3, 4, 5. Okay, let's say 6 got lost. 6 got lost. Okay, 7 will go, 8 will go in first go, I'm saying 9 and 10. Okay, let's say all of them will go. So on receiver, what do we have? 1, 2, 3, 4, 5. We don't have 6 yet. 7, 8, 9, 10. So everything is there. So what receiver will do? Receiver will send like this. Receiver will send acknowledgement 6, that I received till 5, please send me 6 onwards. So what your sender will do? Sender will send 6. Definitely he will send 6. But after the 6, he will again resend the remaining stream. Because acknowledgement means I have received till that point. So entire stream will be sent again. So it's like wasting the bandwidth. So to avoid this, what do we have? We have a concept called as SAC, selective acknowledgement. In selective acknowledgement, this option you have in the TCP options field of TCP header. This option is available in TCP options field of TCP header. Okay, this option is available in the options field of TCP header. This is not available straight away in the TCP header. Okay, if this option is enabled and acknowledgement 6 is sent, so it will be like SAC 6. So only in reply to this, you will get only 6. You will get only packet number 6 stream. That's it. You won't get anything else. So selective acknowledgement somehow saved our bandwidth. I hope you are clear with the concept of acknowledgement and selective acknowledgement, because the difference is very important.
One more time, can you just repeat that again, please?
Okay.
I lost the connection in between.
Problems 1, 2, 3, 4. Sender, receiver. Okay. For how the traffic flow will go, one will go right, two will go, three will go, then you will send four, right? Let's suppose in between them, three is lost somewhere in the internet. It's lost. It didn't reach the destination. It didn't reach the receiver. So then what will happen? The receiver will get something like this: 1, 2, and 4, right? He will not get 3. So what receiver will do? The receiver will send a message. Receiver will send acknowledgement 3. What does this mean? This means that receiver has received packets or traffic till sequence number 2. Okay. So that means he has received sequence number 2. He is expecting sequence number 3 to come now. So the moment sender will receive acknowledgement 3, what he'll do? He will, sorry guys, he will send the sequence number 3, as well as he will resend the sequence number 4, because he received the message that receiver has received till sequence number 2. He hasn't got that receiver has received sequence number, only sequence number 3 is missing. So that is how acknowledgement works. Acknowledgement means whatever acknowledgement I am getting, the sender will feel like till this acknowledgement only my receiver has received. Anything beyond this acknowledgement number I have to send again. So again, this was like wasting my bandwidth, right? My bandwidth is getting wasted because even though my receiver has received sequence number 4, but again I have to send it to him. So to avoid this thing, he came up with the solution of SAC, which is nothing but selective acknowledgement. This selective acknowledgement is there only in the TCP options field. It is not directly enabled in the TCP header. If selective acknowledgement is enabled, then in that case, rather than sending this acknowledgement message on receiving sequence number 4, the receiver will send selective acknowledgement. Let me take any other color. Okay. So in this case,
Sumit sir, this should be enabled for both client and server, or it anyone?
that depends on the availability, whether both of them can avail it or not. It depends on the hardware to hardware, or it depends on the compatibility. It is not like vendor specific. Both of them can enable, and if both of them doesn't, if both of them can't enable.
So is
This
it
is
like
not.
one can one on one side it will be enabled, on another side it will not be? Is
Yes,
it also?
yes, that's also it can. Okay,
Okay.
so
So we
select.
can change. Is it like we can make any change in this kind of
Yes,
options
you
field
can.
settings?
Yes, you can. Yes, you can. You can manually change them. I'll tell you the trick. It's not by default, but yes, you can
Mhm.
change. Okay,
Okay.
so
Thanks.
selective acknowledgement 3. So that means in this case, only packet 3 will be sent. Only sequence number 3 will be sent. Not 4 won't be sent again. So this is your fundamental of selective acknowledgement. Okay. Guys, let's take a break. Okay, let's take a break of 30 minutes if it's all okay with you guys. Let me finish that puja and all. Okay. So guys, today we'll hold our discussion on some theoretical things that we were doing till last week. Okay. So today I changed the behavior and we will discuss some practical things today. Okay. We will discuss some CLI. We will discuss some other things. I will teach you like introduction to the CLI first, where I will talk about the modes and the various things that we have, or the basic commands actually that we have with Cisco devices. After then, we'll talk about Telnet and SSH. And after Telnet and SSH, we'll talk about iOS backup. iOS backup and retrieval. So these are the major three things that we will cover. After this, if our time will permit, then I'll continue my discussion that was left till last week. I think till last week we discussed data sequencing and retransmission. So there onwards, I will start my discussion. Okay. Okay. So let's discuss modes of Cisco devices first. First mode is user mode. The moment you will log into any Cisco router or a switch, the first mode that you get by this symbol is known as user mode. What is the use case of this user mode? Basic troubleshooting. Basic troubleshooting. Okay, like ping, telnet, enable, exit, basic commands only. Okay, so these are the type of basic commands that you can execute in the user mode. After user mode, you have privilege mode. Now, what is the use of privilege mode? It is used for major troubleshooting. Major troubleshooting. All show commands that you execute, they belong to privilege mode. All the show commands that you execute, show IP interface brief, show VLAN brief, all those show related commands, or even the user mode commands as well. So privilege mode is like a combination of privilege mode plus user mode commands that we execute. So both of them you can execute in the privilege mode. Show, ping, telnet, all the major troubleshooting things, all the debugs, whatever things that are related to major troubleshooting, you can do in your privilege mode. After privilege mode, next is global configuration. Now, what exactly global configuration mode? This mode is used for new configurations. New changes. Whatever new executions are there, that are done in global configuration mode. Okay, generally it is, if you are into this, like you have only this symbol in your CLI, that means you are in user mode. In user mode, once you enter enable, then you go to hash or pound symbol, and this is known as privilege mode. From privilege mode, the moment you use the command configure terminal, you enter into global configuration mode, and it is like this: config and then pound symbol. So these are the three modes we have in major modes in all the Cisco devices. You can have few more modes according to your requirement. For example, line terminal, which is used for your virtualization, or your virtual terminal, which is used for your telnet, SSH, all those types of configurations. Okay, then after that you have your interface terminal, or interface mode, in which you do your interface related configuration. So all these things you can do in your Cisco device, any Cisco device. Okay, this is my packet tracer. Let's take some routers. Let's take only 2 routers and 2 PCs. Okay, guys, this is Cisco Packet Tracer. This is a stimulating software. Okay, stimulating software is a software which is generally plug and play type of a software. It doesn't use the real-time resources of your device. In networking, we are majorly use in network security or any virtualization or any type of virtualization. We use two types of software: stimulation and emulation. Stimulation is the one which is plug and play, and emulation is the one which uses real time resources of your device. For example, EVNG. If you have gone through with EVNG, you must have seen that EVNG requires real-time resources, that you need to allocate few GBs of RAM to certain devices, few MBs or GBs like that. But in a stimulating software, you don't need to do that. Stimulating software has a basic setup, and everything in a stimulating software is plug and play. Okay. Okay. So for example, if I'm opening this router and I'm going into the CLI, would you like to enter the initial configuration dialog box? No. The moment I'm doing that, can you see this router and this? Guys, just give me a moment. Okay. Okay, so you can see this greater than symbol. That means you are in user mode. If I'll press question mark, you can see these are the only commands I have in user mode. Only the basic commands: ping, resume, show, SSH, telnet, terminal, trace route, disable, enable, disconnect, exit logger. So you can see you can't do much in user mode. Cisco is one of the most friendliest devices when it comes to command line configuration. You know the command, very good. You don't know the command, use the utility question mark. The moment you will press question mark, it will list out all the related commands that you have for that mode. If I am not using any filter prior to the question mark and I'm like using only question mark and then enter, then it will give me all the commands of that mode. But if I use some filter, for example, I'm using en and then I'll use question mark. So it will give me only that command which is after en available in that mode. And even you don't need to press question mark as well. You can press tab, it will automatically take. So this should be a generic habit of everyone who is working in CLI or any type of a code. If you are in development, you are doing coding, whatever it is, you should make it a habit of using tab key as much as you can rather than typing the full command. Okay, let's press enter, enable. Can you see this? Now we are into pound or hash, whatever you can call this. Now this is known as privilege mode. If I'll press question mark over here, you can see there are many commands. Many commands are there, probably more than what we have in user mode. You can see that if I'll keep pressing the enter. So I have more commands. Then these commands further have sub commands. For example, there is a command show. Now show what? If I'll use show and then I press question mark. So these are the sub commands that I can use using the keyword show. Show IP, IPv6, show license, show flash, show file, and further these have sub commands. For example, I'm saying show IP. Show IP what? Question mark. So you don't need to learn all the commands. You need to learn the logic first. Commands you will learn gradually. The more you will work in the environment, the more grasp you will get over the CLI commands. Okay. Now I'll do configure terminal. I will enter into global configuration mode. Any changes with regards to the current configuration, you can do it over here. Okay, before going ahead, I want to ask you guys, what is the difference between running configuration and startup configuration? Last time we discussed the boot process of a device. If you have gone through that video, you should be able to answer this question. What is the difference between running configuration and startup configuration?
Running configuration cell will be stored in RAM.
Yes, it is RAM.
And startup configuration NVRAM cell.
Startup is NVRAM.
Yes.
Yes, go ahead. Okay, power off.
Configuration erased.
Power off, gone. Power off, not gone. As simple as that. Why? Because in the booting process, with the current registry values, any device looks for NVRAM. In NVRAM, it tries to headphone use. In NVRAM, it tries to locate for your startup configuration, and startup configuration is the configuration which gets loaded once your device is turned on. Okay, for example, let's talk about this command, hostname R1. Hostname command will change the name of your CLI or whatever the device you have like booted up. It will simply change the host name of it. Now I haven't saved it. Saved means I haven't copied. Right now, whatever is in front of me, this is the running configuration. So if I will do reload, no, he's asking me to save the configuration. No, confirm. See, my current configuration that I configured is gone. Why? Because that was in the RAM. That was not part of the NVRAM. So if you want your configuration to be part of NVRAM, you need to use this command copy run to start. Okay, enter. That's it. Your command, your output is saved. See, I tried hostname in the privilege mode, but I wasn't able to execute the command. Why? Because I'm doing a change, because I'm executing new thing. I'm providing a new configuration to my device, which is not possible for the privilege mode. So I have to do it in the global configuration mode. Okay, now again, copy is a privilege mode command. You need to be very careful of which command belongs to which mode, guys. Copy running configuration to startup configuration. I'm using shortcut, but the entire command is copy running configuration to startup configuration. That's it. Now, if I'll do reload, this time my configuration didn't got erased. Why? Because I saved it in the NVRAM. And the moment reload happened in the boot process, it checked for any saved startup configuration in the NVRAM and it got my saved configuration in the NVRAM and ultimately it booted up the startup configuration. Is it clear to everyone?
Yes, sir.
Okay. First command for you guys, hostname, as I told you. Let's talk about few commands. First is hostname. To change the name of your CLI device, of your CLI host. Guys, if you are making notes, okay, try to do this. Whichever command belongs to global configuration mode, use config pound in front of that. If you are writing any privilege mode command, use pound before that. This way, it will be better for you to remember that which command belongs to which mode. Okay, host name, anything you can say, Alpha, Bravo, Charlie. First command for you guys, okay? Banner, banner command. What is banner? Sometimes you must have seen you are logging into a device and it gives you some pop-up before entering into the device that this is a registered or a trademark device. Beware of the security concerns or the compliances like that. So that is known as banner. So you can also set the banner in your device. The command again for the banner is in the global configuration mode itself, banner MOTD. MOTD means message of the day. Guys, every single command has a logic, okay? If you are using that logic, it will be easier for you to remember that thing. Okay, so let me show you the banner command. In Cisco, there is one more thing. You don't need to type the entire command. Like configure terminal, I don't have to type the entire command again and again. Even if I'll type the partial command, Cisco is an intelligent device. It will infer the exact command and it will execute the correct one. So even if I'll type conft, it will also take configure terminal. See, now I will not type the entire banner. I will use BA, then I will use tab. Question mark. What do I have? MOTD, set message of the day banner. Okay, what message should we set? This is a proprietary device of CloudX Solutions Private Limited. Enter. Okay, copy, run to start, or again. You don't need to type the entire command again and again. Copy running to start of config. Cisco is an intelligent device. Even if you will write copy run to start, it will take. Okay, let's reload. See, now the moment I think T got missed out. Okay, so you can see proprietary device of CloudX solutions. Okay, so that's how the banner came up. So this is your banner. Next command is setting up the password. Set password on privilege mode. See, even if you have got the access of user mode, you can't check many things. You can't even I'll say you can't check anything if you are in the privilege, if you are in the user mode. You need to go from user mode to privilege mode, and then you need to use show commands to check what is the current running configuration on my device, right? So that's why it is always advised to set up a password before going ahead. The command to set the password is you need to again go into the global configuration mode. Command is enable password. Okay, then you can set any password. Let's say I'm setting Cisco 123. Okay, let me show you. Enable password Cisco 123. Exit. Exit. Next time, the moment I'll press enable, it will ask for a password. Cisco 123. The moment you will enter Cisco 123, you can enter into the privilege. So that way you can set the password as well. Now, same thing you can do. You can set the password on the line console as well, but that we will discuss later when we'll talk about the line console. Okay. What is the command to check the current configuration on my device? Currently running configuration. Command to check the running configuration. The command itself is show running config. Show running config. And this command belongs to privilege mode. Why? Because we have show. We are not configuring a new thing this time. We are checking something. So we will not go to the global configuration mode. So we will simply do it in the yes. Show running config. It will give me the entire configuration of my device. Okay. Whatever is a default configuration available and what we have configured as well. So the moment I'm using show running config, can you see this enable password Cisco 123? This is what we did configured, right? Yes, just imagine a scenario. You are sitting on your desk. Okay, you are working on this device. Somehow your manager called you, or you have to take a call and you have to go out, and you forgot to lock your laptop and you are logged into your device. What your colleague will do, your colleague will come to your desk, he will grab the opportunity, he will use the command show run, and he will see the passwords that you have configured. The moment he will see the passwords you have configured, he will copy them, and the next time he'll take the access on the device on his own through your passwords, through your account. Not good sign for you, right? So whatever passwords we have, so whatever passwords you will configure or you are configuring, make sure they should be in the encrypted format. They are not like this in the plain text. So to achieve that, enable secret. Either you can use this option, Cisco 1234. If I'll do that, show, see, enable secret. You can see this. It's in the encrypted or unreadable format. You cannot see what password is configured, right? So this way is the one thing. And second thing is service password
Sir, what is
encryption.
FI, sir? After enable secret, there is a FI, sir, right?
Level. That we'll talk about later, but this is the level of encryption.
Okay, okay, sir, okay.
Okay. Service password encryption. If I'll press enter, exit, show run, you can see that even this is also in the encrypted format. This is also unreadable. Your guys, I think some equals. Just give me a minute. I hope no echo is there this time. Okay. So this way you can achieve the encryption of the password. Show running config is done. Okay. Yeah, let's come to interface now. So to achieve any sort of networking, we need to do one thing. We need to assign IP address to the specific interfaces. Now I'm into router 0 right now. I'm into router 0. So I need to assign the IP addresses to the router. So how can I assign the IP address? Before going ahead, one more command, show IP interface brief. This command will list out all the physical interfaces of your router, that whichever are active, all the physical interfaces, and on those interfaces, you can check what is the IP address configured, what is the status, whether they are up or they are down. So all those things you can check over here. So you can see that my router has three interfaces: fast Ethernet 0x0, 0x1, and VLAN 1, where 0x0 and 0x1 are the physical interfaces that are available on my this device. Router 0, fast Ethernet 0x1, and fast Ethernet 0x0, the two interfaces. You can configure them like this. Interface fast Ethernet 0x0. Let's come to this interface first. Okay, this is towards my no shutdown. IP address 10.10.10.1 subnet mask exit. So these are the steps to configure any interface. That means if I write it down for you guys, Go to global configuration mode. Write down the interface. Let's say fast Ethernet 0 by 0. You can write the full like fast Ethernet 0 by 0, F0 by 0. Again, as I told you, you don't need to write the entire command in Cisco. Cisco knows it. It will come into interface terminal configuration mode. Config if no shutdown. First step 1. Step number 2 is giving the IP address. IP address, address, and then it's subnet mask. Like I gave 10.10.10.1. Like I gave 10.10.10.1/24 to F0 by 0. On fast Ethernet 0 by 1, I am going to give subnet of 20. Now, if I use the command show IP interface brief, now check the output. If I go little up, I have to show you the output of this command show IP interface brief. You can see IP address unassigned, unassigned, administratively down, protocol down. Now come over here. Ethernet 0 by 0, IP address 0 by 1, IP address status up, protocol up. In the second line, status up, protocol down. Can anyone tell me the reason why protocol is still down for fast Ethernet 0 by 1? Status is your status, administrative status of the physical cable, whether you have make it shut or no shut. If you have done, if you have used the command shutdown, this will be down. If you have used the command no shutdown, the status of the interface will be up. But what about protocol? Up in first case and down in second case. If you look at the topology carefully, fast Ethernet 0 by 0 is towards your PC0, right? Fast Ethernet 0 by 0 is towards your PC0 and fast Ethernet 0 by 1 is towards your router 1. This interface is showing red or its protocol is showing down because what is protocol in this case? In this, the protocol is line keep alive. Keep alive sends the message that whether my next hop is up or not. It's a very important interview question. If I'll talk more about it, keep alive. It is used to check whether next hop is available or not. Okay, it is sent after every 30 seconds. Every 30 seconds, your device will send a keep alive message to the next hop. In case of router 0, on its interface F0 by 0, it is attached with the PC. It is sending keep alive message to the PC and PC is always on. The moment power cable is turned on in a PC, PC is always on. So PC is replying him to the keep alive message that yes, I am on. But on the other hand, if I talk about F0 by 1 of router 0, it is sending keep alive message to router 1, but router 1's F0 by 0 interface is still in the shutdown state because I haven't no shut the interface. So till the time the interface is in the no shut state, is in the shutdown state, it won't send reply for the keep alive message. So that is why my protocol is showing down over here because line protocol is down, and reason being that is my router is not receiving keep alive reply to the keep alive message he is sending to the next hop. So to make it up, what I have to do, I have to go to the next router. Interface if 0 by 0, no shutdown. Okay, now this interface is no shutdown. Let's come back to our router, R0. Let's use the command once again. Now you can see my line protocol is also up. I hope this is clear to everyone. This is a very common case that if you are working in a data center, you get these sort of cases very easily. There are three reasons for that, guys. If line protocol is showing you down, first reason is you're not getting the keep alive message from your next hop. And if your next hop is also in the no shut stage and your device is also in the no shut stage, and still their protocol is showing down for both of them, then that implies your cable is faulty. Your cable is faulty. You need to replace your cable that is connecting your two devices. I hope I'm clear to you guys. Interface F 0 by 1, no shutdown. Show So I did no shut for this as well. So now my topology is completely up. Now, what is the command to save the configuration? Copy, run to start, that I have already told you. Guys, I hope you're not getting bored.
No, sir.
No, sir. No, sir.
Okay, cool. Okay, let's talk about some show commands then. Show IP interface brief we have already discussed. Okay. Show running configuration also we have discussed to check the running configuration of your device. Now, what if I want to see specifically the running configuration of a single interface? Show IP interface fast Ethernet 0 by 1, not IP. Show run interface. Show run. I think it is show IP only. Show IP interface past Ethernet 0 by 0 or 0 by 1, whichever you want to see. Okay. The moment you will use the show IP interface brief, it will give you all the output related to that interface, the detailed output, that what is the IP address configured for it, whether the interface is it is set as up. If it is no shut down, that means it is in the shutdown. Line protocol is up, connected, IP address, subnet mask, MTU of the interface, okay, security level, ICMP, whichever protocols are by default allowed on that interface. So all the detailed list will be provided to you, okay. Show interface fast Ethernet 0 by 0. If I'll use this, this will give me the layer 2 level of information of the device. Layer 2 level of information. That means MAC address and all. I want to see the MAC address of my interface. Show interface fast Ethernet 0 by 0. See, this is the MAC address. 00D09731. What is the bandwidth? What is the delay of the interface? Okay. What is the duplex mode of my interface? See, I told you at the time of introduction videos that by default routers and switches are in the full duplex. So you can verify the same over here as well. What is the throughput of the interface? Okay. What is the media type of this interface? RJ45 connector. ARP timeouts, okay, 4 hours. By default, ARP is there for 4 hours. We'll talk more about the ARP in the further upcoming sessions as well, most probably tomorrow only. Okay, then you have number of input packets, okay, number of input errors or number of output packets that this interface is sending, errors in the outputs. So there is a very common question that that get asked in the interviews, that why I'm facing the latency. An interviewer asks it very easily to a candidate that you are in a data center or you are in an environment. Please tell us the reason that we would be facing latency. So in that case, the command show interface fast Ethernet, the number of that interface becomes very, very powerful and very, very useful, because you can tell the latency related things by checking the number of input packets. Suppose that I'm receiving 10,000 input packets, but my outputs are only like 500, 700. Then what does that mean? That means 9,500 odd packets are still in my queue. They are yet to be processed. That means there is a delay or there is a CPU overload on my router. So that way you can tackle the latency on your device as well. Okay. You need to lower down the load, you need to lower down the processes, you need to confine your configuration. A good network engineer is an engineer, or any engineer who provides the maximum output in the minimum resources. It's not like you have resources and you will utilize all of them in a single go. No. You have to optimize your resources so that you can get the best output out of them. So if I'm getting 10,000 input packets, then my output should also be close to 9,800, 9,900. I should have the minimum of the least, I should have the least output packets. I should have the least packets in my buffer queue. So you have to do the configurations in that way. Okay, if you want to, we have already discussed that, show IP. Yeah. So if I want to use any privilege mode command in the global configuration mode, show IP interface brief, I cannot do that by default. But is there any other workaround we have? Yes, we have. We need to use do keyword before that. Do show IP interface brief. If I'll do that, I can use all the privilege mode commands in the global configuration. The key over here is the do keyword. You can use any privilege mode command in the global configuration mode. You need to make sure of the do keyword. Okay.
Sir, what is this input or CRC error here in the show interface?
Which just a moment. कौन सा वाला CRC बोल रहे हो? Are you talking about CRC? Cyclic redundancy check. We'll talk about that in Ethernet header. CRC is cyclic redundancy check. Errors related to CRC checks. That means your layer 2 issues are there. That means issues related to MAC addresses are there. Because of that, your packet is getting dropped. Cyclic redundancy check.
Okay, thank you.
We'll talk about cyclic redundancy check. Sequence, that means your checksum is also an issue. Now, what is checksum? We'll talk about it in the headers. Okay. By default.
Hello.
Yeah, go ahead.
Sumit, there is ARPA mentioned, that protocol. What is that?
ARPA. I'll talk about it.
Okay.
I'll talk about in the packet flow. Just remind me at the time of packet flow, when we'll discuss the packet flow in single subnet, I'll talk about the ARPA and ARP. ARPA and ARP are one and the same thing. I'll talk about the differences over there. Okay.
Yes.
By default, you cannot use privilege mode commands in global configuration mode. you need to use do keyword prior to using that. Okay. Okay, always make sure of this. Now let's talk about reload. Also, we have discussed. Okay, let's talk about some more things. Let me take one router and let me take one server. Okay, let me host name, let's say R1. Okay, interface fast Ethernet 0x0, no shutdown, IP address 192.168.10.1. I'm not talking about the working of FTP or TFTP yet. Okay. What we are going to do, we will just be storing our configurations on the TFTP server. But yes, prior to doing that, you guys should needs to be aware about the FTP or its related terminologies. FTP, TFTP, SFTP. What is FTP? File transfer protocol. What is TFTP? Trivial file transfer protocol. And what is SFTP? Secure file transfer protocol. What is their uses? Their use is to transfer files. FTP has two modes, active and passive, which I'll definitely talk about in upcoming sessions as well. That how active and passive are used, and when the firewall comes into picture, how the behavior pattern gets changed. Okay, so we are using TFTP right now for file transfer. Okay, so I have taken a server in my environment. So this is my TFTP server. I'll configure this server as my TFTP. First, go to the configuration. First, configure the IP address so that it can communicate. I'm taking IP address 10.2 because they have to be in the same network. I don't want to, configure my TFTP server out of my network. That will breach my security definitely. In any organization you guys have been working, you can observe the same in your environment as well. Nobody configures their TFTP server out of the environment. TFTP server is always kept into the environment, because if I kept my server out of my environment or somewhere else, there is a chance of a security breach, because that environment may or may not be under my control. I may not have applied the correct set of security related things for that. So that is why your TFTP server is always kept in your environment. So I have used 10.1 IP address of my router, and I'm using 10.2 IP address on my TFTP server. Go to services, make sure your TFTP services are on. If they are off, please turn them on. Okay. Now go to your router, use the command copy run. That means you're running configuration to TFTP. I am copying my running configuration to TFTP. Enter. What is the address or name of the host? Address of the host is 192.168.10.2. Enter. Destination, let's say CFG. Writing running config. Okay. Okay. Let me close it. Let me reopen it. TFTP. Can you see this, guys? R1.cfg. It is at the top. My configuration backup is done. My configuration backup is done. My configuration is backed up. The entire running configuration is backed up. Now, write erase. See, note it down very carefully. My host name is R1 right now. Write erase, enter. Reload. What write erase does? This command, do not use this command in your production environment because write erase will erase your flash. Your flash memory will be erased. That means after executing write erase command, you will not have anything in your NVRAM or your flash. So no startup configuration will be there. Reload. If I'll do reload, he's asking me to save the configuration because he knows flash is empty, but I will say no. Proceed with the confirm reload. Would you like to do the initial configuration dialog? No. See, I entered into router. My configuration got deleted. Nothing is there. It came to default mode only, like a device built from the scratch. Enable configure terminal. See, if I have to copy anything from my TFTP server, I need to have IP address. Without IP address, I cannot copy. Without IP address, I cannot communicate in my network. So what I'll do, I'll simply provide the IP address. You can use any IP address from 10.0/24 subnet, but make sure it should not be out of that. Exit, exit. Now what I will do, I will do the reverse. Last time I copied the running configuration from, running to TFTP. Now I will take it back from TFTP. Copy TFTP to running config. Enter. Address of the host. Source file name r1.cfg that I need to copy. Running config, accessing TFTP. C. Router R1. Copy, run to start. Reload. I got my configuration back. This is the manual thing. This is the manual thing that we are doing. But in an environment, this is generally done with the help of third-party tools, mostly like SolarWinds, Nagios. So they are the mostly servers that SOC environment or any operation center deploys, guys. I'm using a basic TFTP server that you can use in your lab and you can deploy and you can do the configurations. Okay. So this is something you can do. Any doubts till this point? Anyone? Whatever we are discussing with regards to CLI?
No.
I have discussed many commands today, actually. Let me see whether anything is there in the chat. The wishes, thank you for that. Okay, so if I write the syntax, for copying from router to TFTP first. Router to TFTP. Copy, run to TFTP. After that, it will ask for the address or name of the destination server, something like that. Over there, you can put the TFTP IP address. Okay, then it will ask for the file name in TFTP, that which file name TFTP will use to save your configuration. You can give any name.cfg. CFG means configuration file. Okay, this is the extension of your configurations.cfg. Similarly, if I want to do vice versa, from TFTP to running config, okay, copy TFTP to run, then it will ask for the address of the source. Over there, you will put your TFTP IP address again. Then it will ask for the file name which you want to copy. Put the file name. Once it will be done, then it will be executed in your environment. After that, you can use the command copy run to start to save the configurations in the NVRAM ultimately. You can also use the command copy TFTP to start. You can also do that as well. Like rather than running, you can also directly copy to the startup configuration, but that way you need to do a reload. But if I use a command copy TFTP to run, that way I don't require a reload. Okay, so remember this thing. I think that's it for my first half. Let's talk about remaining things in the second half of the lecture. Okay, if we are good to go, then let's study remote access configurations. Okay, just give me a moment. I think my angle is not correct. Yeah. Okay, so we'll talk about two protocols. Let's talk about Telnet. Many of you are aware about Telnet, but what exactly Telnet does? Telnet is used to take the remote access. Telnet is used to take the remote access of a device. That means this is my router. Okay, this is the internet. This is a Pune location. Okay, and let's suppose you have one device. This is a router or any layer 3 device that belongs to Cisco. This is sitting at, let's say, Noida location. So if I want to access this device Okay. If I want to access this device that is sitting at Noida location in the Pune location, which protocol I'm going to use? I will use Telnet. I think same thing we are doing as well in our daily life as well, that you are logging into your VPN at the start of your shift in your office. Once you log in into your VPN, then you take the remote access of the devices on whom you are working through PuTTY or secure CRT or whichever M remote, whatever XYZ CLI console you have in your environment. Okay. So how we can take the telnet? What is the configuration for it? The configuration that is responsible for telnet or any remote protocol is known as line VTY. Line VTY. Now, what exactly is this VTY? VTY stands for virtual terminal. So if I'm enabling virtual terminal in my device, that means this device is eligible for virtual access. That means anyone sitting over any remote location can virtually access this device. Okay, first thing. Now, how to do the configuration? How to do the configuration? Simply, first we'll talk about telnet only. Log into the global configuration mode. Line VTY 0 to 4. You will write it like this. What do you mean by 0 to 4? That means 5 instances can be created virtually. 5 devices can take the virtual access of my device. 0, 1, 2, 3, 4. So 5 virtual instances will be there. Okay. Line VTY 0 to 4. After that, you need to set the password. Let's say my password is Cisco123. Okay. Then after that, login, exit. Don't forget to use this command. Transport input telnet. Then exit. This will enable telnet. That's it. This is the password for the login that you will set. After that, you will inform that which protocol will be taken up for the remote access, whether it's telnet or SSH. So I'm using telnet. Let's do the configuration as well on our packet tracer. Let's take new devices. Okay, so for telnet and SSH, you need to make sure that your connectivity is there. If your connectivity is not there, you cannot take the telnet or SSH of the remote device. Let's say this is Noida. And okay, let's configure this device first. Interface F0 by 0. No shutdown. IP address 10.10.10.1. Show IP interface brief. My IP is enabled. Okay. Now let's go to this device. Let's change it to something. Let's say Bangalore. Okay, so I'll ping both of them 10.10.10.1. Both the devices are reachable. Yes, both the devices are reachable. Why this dot comes up first? Anyone? Why this dot comes up first? That
Because of
means
ARP
I,
request.
which request?
ARPs or ARP message.
Okay, so why so? So R holds the ICMP, right?
Yes, sir.
So if R holds the ICMP, then why dot? Once the ARP is resolved, then it should send the ICMP packet, the held up ICMP packet. But in this case, it is dropping. In second case, it didn't drop. This is also an interview question. If you know about networking, you should be able to answer this because router doesn't hold the ARP. Okay, sorry, ICMP. The moment router will receive an ICMP packet or it will generate an ICMP packet, and for the destination IP to which it is communicating, it doesn't have a MAC address for that destination IP. It will not hold the ICMP. It will drop the ICMP packet and it will send the ARP request. Once it will get the ARP reply, then after getting the ARP reply, the corresponding ICMP packets will only be sent. We'll talk about this again in the packet flow. Okay. Okay, so I think we have established the connectivity since our so line VTY, how many instances? 5 instances. Login, login is disabled. Password Cisco 123. Login, exit, not exit yet. Transport, input, telnet. So what I did, line VTY 024. I set the password Cisco 123, and what is the purpose of this password Cisco 123? Purpose is for logging in into this Noida device. Through which protocol? Telnet. Exit. Now let's go to our other device. Telnet. It is asking for password. We'll type the password, enter. So from Bangalore, now I'm into Noida device. So that's how you take the remote access of your device. If I try to go beyond this point, I will not be able to, because by default in Telnet or even in SSH, you cannot go from user mode to privilege mode without setting the password for enable. So what we'll do, we will set the password through command enable secret Cisco 123. You can set it anything. Let's come back. Enable. Now I'm entered into it. Show IP interface brief. Okay, you can see that. Let me do some changes into it. Noida 123. I change the host name. Exit. And let me come back to the device. I did change in the through the remote access, and the same change is getting reflected into my main device as well. I hope everyone is clear about the telnet over here. This is the one way of configuring the telnet. Is this clear, guys? Second
Yes, sir.
way, second way is through username and password. Right now we are only using password. Second way is username and password. Okay, this is first. Second is with username and password. Line VTY 0 to 4. In this case, we'll use only single command. Login local. After that, transport, input, telnet, exit. After that, you said login local. What exactly this means? Login local. That means for logging into or logging into for logging into the device, we need to use local username database. Now, where exactly is this local username database? That local username database is not created yet. So you need to manually create it like this. Username, Sumit, password, Ngcloudx, like this. Let me show you. Okay, let me show you. Line bty line bty. Issue seems to be there. Okay, 0 to 4. Transport input telnet login local exit. Now in the global configuration mode, you will create a local database like this. Username Sumit, password Ngcloudx, exit. Now let me try and take the telnet 10.1.10.10.10.1. Now it's asking me for username rather than password. What was the username? Sumit, password Ngcloudx. I'm into the Noida 123. This is the second bit. This is the second bit. You can also check why this way is important. You can also check who is logged into my system. We have someone unmuted. Okay, I hope no echo. Just give me a moment, guys. Okay, I hope no more echo. So show user is the command through which you can check which user is logged in into my system. Okay, right now I'm into the original device. Show user command I used. So I got the information that user Sumit is logged in into my device and he is using this IP 10.10.10.2. This is his IP and he is idle for 1 minute 25 seconds. He's not doing any activity. The moment I'll go back to the device on which I have taken the remote access, I did some enter, came back into original device, idle timeout changed. Idle timeout is reset. What exactly is idle timeout? Idle timeout means how long a device is idle. Okay, how long a device is kept idle without doing anything. Okay, so this is how you can do telnet configuration. But is telnet used in real time? No. Is telnet used in real time? No. Why? Is telnet used in real time? Answer to this question is no. Why? Because telnet exchange traffic in clear text format. Because telnet exchanges traffic in clear text format. In a live production environment where you are doing critical configurations, it is never advised or you should never do clear text communication, right? The only type of communication that you should be doing is the encrypted communication, unreadable communication. So that is why telnet is not used in real time. It is just for the, basic practice, or you can do it in your lab environment. It's for that only. So which protocol is used in real time? The protocol for remote access, which is used in real time, is SSH, secure shell. Whatever communication that you will do within SSH will be in the encrypted format. Encrypted format communication. Okay, no clear text communication. How to configure SSH? First of all, to configure SSH, guys who are working with security or working in VPN, what do we need for encrypting something? What exactly is the requirement of encryption? Anyone?
Algorithm, sir.
Algorithm. Yes, encryption algorithm and key. You need a key. To configure encryption, you need a key. Okay, don't forget. For encryption, two things are required: algorithm and key. Key is the important terminology that we'll use. For algorithm, it will take the default algorithm configured on your device. You can change that as well. But key you need to configure manually. Okay, let's configure the key. So let's exit out. Now I'll take the access via. Now I'll take access by SSH only. Okay. For SSH, you need to do the step-by-step process, which I'll be doing. Line VPY 0 to 4. Same thing. Login local. Exit. Not exit yet. One thing I forgot. Transport input SSH. Rather than telnet, this time we'll do transport input SSH. Login will be local only. Or let me do the configuration once again. Login local. Transport input SSH. Exit. That's it. Username. Sumit, password, Ngcloudx. The previous one will also be used definitely because that is part of my local database. The previous username I have created, but I can create a new one as well. Like username said, password Cisco123. New user database is also created. Now we need to configure two things. First, we need to configure domain. IP domain name. Okay, ngcloudx.com. This will be my SSH domain. Now I need to configure key. Crypto key generate. Crypto key generate RSA. What is the size of the key? Size of the key should be in the range of 360 to 4096, but has to be a multiple of 512. So let's take 1024. Okay, generating 1024 bit RSA key. Keys will be non-exportable. You cannot export the keys. Now my SSH configuration is done. Let's go back to our other device and now let's try and take the access via SSH. SSH -L -L, then username said. Okay, from which device? 10.10.10.1. Enter. What is the password? Cisco123. Enter. This is your SSH. This is your SSH, guys. Show users. If I will maximize it, show users, you can see SID is logged into the device. It won't tell you the location. Why? Because this is the local location only. But if I use the same command in the main device, show users. It's also not showing location, but in the location, it needs to show IP address, guys, like it showed in the previous user order. Maybe this is a packet tracer issue, but it should also show the location. That means the IP address. Okay, in case you want both, I hope Telnet and SSH is clear to you. But in case I want to use both, then you don't need to do anything. Just go to your virtual terminal 9VTY024, transport input both. It's not taking both. All, sorry. Transport input all, not both. Login, local, exit. Now you can take the access via both the means. Exit, telnet 10.10.10.1, username Sumit, password Cisco123. I guess Sumit password I forgot. Okay, exit. If I'll do the same thing via SSH, both SSH and telnet if you want to enable both. So you need to use the command transport input all. So that is it from the remote accesses configuration. I will wind my class today here itself. The reason being is today we have covered too much of practicals. I want you guys to do or to practice these practicals so that we can restart with our theoretical discussion from tomorrow onwards.
Things like running more than your expectation.
Yes, I
Definitely,
agree.
that's we will earn
I
automatically. Things will
agree.
be increased. It's going to be that.
No problem. So
Okay.
let's start.
Sorry
Let's
for.
start for that's okay. That's okay. That's fine. So in TCP, we discussed connection orientation. In connection orientation, we talked about three-way handshake. Okay, that is done. We have already discussed that. After connection orientation, we discussed data sequencing. That is also done. After data sequencing, we discussed retransmission, right? After retransmission, we discussed reliability. How TCP achieves reliability, guys? Anyone? TCP achieves reliability. Yeah, yeah, go ahead.
Using the acknowledgement and
Yes,
buffering, windowing.
acknowledgement. Acknowledgement. In TCP, there is by default in TCP, there is an acknowledgement for every single bit of traffic that is going from one point to another point. By the mechanism of acknowledgement, if your sender will not receive acknowledgement, and it will do the retransmission, and because of sequence number and acknowledgement, data sequencing can also be done. So that is why we say that TCP is a reliable protocol, because no matter what you send in TCP, it will be reached to the destination. Probability of reaching it is very high, because if receiver, even though if receiver is receiving and it will stop sending the acknowledgement, that is an exception case, we can't say about that, but yes, by default it should. Let's talk about flow control. Flow control in TCP. Okay, let's say you have a sender. Okay, and then you have a receiver. They want to exchange some traffic. Your sender has a buffer size of, let's say, 1500 bytes, and your receiver has a buffer size of 1000 bytes. Okay, let's say I have sent 500 bytes of traffic in the first go. Okay, this is the receiving buffer. Okay, every device has two buffers mainly. What is buffers? Buffer is the, what is a buffer? Buffer memory, you must have heard about it. Anyone? Okay, buffer is the temporary memory. Temporary memory where traffic is stored for the processing. So every device has two buffers. First is the receiving buffer, on which it receives the traffic and stores, and then it sends to the device internally, and then device processes it. And second is the sending buffer. There are always two buffers. Okay, so this sender has sent 500 bytes of data to the receiver first time. What is the receiving buffer size? 1000 bytes. So receiver received 500 bytes first. It is processing the traffic, and simultaneously he received another 500 bytes. So 500 plus 500 total will be 1000, right? So now 1000 bytes of my buffer is filled up. I'm still processing the traffic. It's not completely processed. I'm still processing the traffic. Buffer is completely filled up. What will happen at the receiver? If I will send another 500 bytes of traffic to the receiver, will my receiver will be able to accept it? No, he'll not be able to accept it. Why? Because he doesn't has a memory to accept it, right? So in this case, what will happen? The moment the receiving buffer of any device will be filled up 100%, he will send a message of stop, that please don't send any more traffic towards me. Once he will finish processing the 1000 bytes of data, then he will again send the message of go, right? After this, another 500 bytes will be sent, and this time my receiver will accept and process the 500 bytes of next sequence of traffic. This is your flow control, guys. I hope you understood the flow control. Guys, I hope my voice is not that annoying today. Because
No,
my
sir.
wife is because my wife is saying it is annoying.
Everyone wife
No,
say
sir.
same thing.
Yeah, that's true. Next topic of ours is windowing, guys. Okay. TCP is a slow protocol. Before windowing, you need to understand that TCP is a slow protocol. But why? Why? Why TCP is a slow protocol? Because in TCP we have acknowledgement for every single bit of traffic, right? Every single bit of traffic. So anything will go from sender to receiver. Receiver has to send an acknowledgement for it, right? Even it's the slightest or the smallest of the packet, right? So overall, what it does, overall, it does provides us the good features of reliability, sequencing, acknowledge, retransmission. But we have a drawback of this mechanism as well, that is known as slowness in the connection, slowness in the throughput. So s- we came up with a solution for this windowing. What windowing did, windowing speed, it makes the process little more streamlined and faster. How it did that, and overall it also makes sure that the reliability is also there. Okay, this is your client. Okay, this is your server. So what windowing did, let's say your client size is 1000 bytes buffer size. Okay, this sending buffer, and servers receiving buffer size, let's suppose it is 700 bytes. Okay, this is a question for the experienced candidates, and I think I have asked many times in my classes as well. Is window size negotiated or advertised?
Advertise.
It is
Advertised.
advertised by the receiver.
Always, yes, yes. In many of the tutorials, it is wrongly mentioned that window size is negotiated in three-way handshake. Window size is not negotiated. I have every time in a SYN message, the device advertises his window size. Okay, whatever will be his the window size. Okay, let's suppose my client has a window size of 100 bytes. Let's suppose. Let's take 100 bytes of window size. Now, what exactly is the window size? Window size is generally window size is generally window sizes. It is generally size of receiving buffer. That means this much of traffic, this much of traffic can be received without sending acknowledgement. Sorry. Okay. So in this case, your server will say that in the SYN message, whenever the three-way handshake would have happened, in the SYN message, SYN plus ACK, definitely from this side, SYN would have gone, and in this side, SYN plus ACK, and then ACK. So that's how three-way handshake happens. So whenever these two SYN packets must have gone from one side to another side, your client must have told server that I have a window size of 1000 bytes, and server would have told that I have a window size of 700 bytes. So this means my client knows that server's window size is 700 bytes. So that means this client can send, so that means client can send 700 bytes of data to server to server without accepting, without expecting, actually without expecting any acknowledgement. So that means 100 bytes will go first, then another 100, then another 100, 4, 5, 6, and then 7, and then acknowledgement will come from the server. So what it did, it made sure that we don't have to send acknowledgement after every single bit. Acknowledgement is sent only after the window size, whatever was defined in the three-way handshake. Your server doesn't has to acknowledge, or your client or whomsoever is doing the transmission, he doesn't has to acknowledge till the time he feels like he has received a certain amount of data, and that data is known as your window size. Okay, generally it is negotiated in three-way handshake, and we have another field, window scaling factor, that we will talk about in TCP header. I hope you understood windowing over here. Guys, shall I go ahead? Say something.
Yes, sir.
Yes, sir.
Okay. Four-way handshake or four-way close, whatever you can call it. That's up to you. We have a client. We have a server. It is used for what purpose? It is used for graceful termination of the session. Graceful termination of the connection. Okay, so whenever we have to close the connection, the client which initially sent the send message in three-way handshake, now it will perform a four-way close. It will send a finished message to the server. Server will acknowledge the finished message first, and then he will close the connection from his end. And then ultimately client will send him an acknowledgement. That's it. Rest all the process is similar to three-way handshake. That's how a graceful termination happens in a TCP connection. So these are the major features that we have in TCP. The rest we can talk about in TCP header. Okay, so last we were discussing OSI model. So we have discussed every single thing about transport layer and the features of TCP and UDP, and we also discussed what is the purpose of the transport layer. Now let's talk briefly about network layer and the remaining two layers. Okay, at this layer, logical addresses are used. What do you mean by logical addresses, guys? What are logical addresses? Your
IP
IP
address.
address. Okay, your routers and layer 3 switches. I'll also cover layer 3 switches as well. Okay, when we'll cover switching, we will also do practical on layer 3 switches as well. Routers and layer 3 switches work at this layer. Okay, this layer is responsible for transmitting a packet from one network to another network. Whatever the transmission from one network to another network happens, that happens because of the functionality of network layer. Okay, what do you mean by communication in a different network? Can anybody give me an example with respect to IP addresses? I'll ask. Wait. 10.10.10.1 slash 28 10.10.10.20 slash 28. Both these are same network or different network? Okay, let me
The same
ask you.
network.
10.10.10.1 slash 28 10.10.10.20 slash 28. Same network or different network?
The same.
Okay.
That is different network.
Okay.
Different
What
network.
about
Different is it?
Sir, different network, sir.
different network?
Yeah, slash 16.
Yes. Slash 16 ni, block size 16.
Yes, sir, block, yes, sir.
Hmm. So that's slash 28. That means block size 16. Fourth octet. First valid host is for this is 10.1. Last valid host 10.10.10. Last valid host is 14. 15 is the broadcast and 0 is the network ID. Similarly for this, 16 is the network ID. 10.10.10.30 is the last valid host and 10.10.10.31 is the broadcast IP. So that so what I'm trying to say, whenever we have to establish a communication channel between the host of two different network, for example, these two hosts 10.10.10.10.1 and 10.10.10.20, then the layer which does the operational mechanism for us for this purpose is the network layer. Okay, so guys, if you are forgetting the concepts of subnetting, not good. Please go back and start doing the practice on subnetting.org, and you can also revise our previous sessions as well for your understanding. Okay, subnetting is very important. I have iterated it many times. For a network engineer, subnetting should be on his tips. Not network engineer, I would say for any IT engineer who is in any IT domain, whether it's development, whether it's integration, whether it's designing, whether it's architect, you should be excellent with your subnetting. We have a subnet calculator on Google as well, but the time that you will take to open a browser and type Google subnet calculator, the moment you will type that and enter something into that, you can finish entire subnetting in your head by yourself at that time. I have we have discussed this a lot at the time of subnetting. Okay, the main functioning of router work at this layer. Okay, because we are talking about network layer. When a router receives the traffic, what does router does when it receives the traffic? It will forward that traffic by seeing its layer 3 information. Yes, right or wrong? What does router does? The moment router will receive any traffic, the router checks what is the destination IP, whether I have that destination IP in my routing table or not. If yes, proceed with the further communication. Otherwise, drop then and there itself. For experienced candidate, they must be aware about that. But for freshers, guys, you will learn more about this when we will start routing. Okay. Protocols like IP. Tell me about the layer 3 protocols.
ICMP, sir.
Yes,
PSPF,
ICMP, OSPF, etc. Okay, work at this layer. Okay, this is your network layer, guys. Now let's talk about data link layer. Any doubts in network layer, guys? Network layer basically, guys, any doubts in network layer?
No, sir.
Okay, okay. Okay, guys. Data link layer. At this layer, error detection is done. How it is done, that we can discuss in Ethernet header. But see, error detection is done in two layers. One, I'm telling you about data link. Could you tell me the second layer where error detection is done?
TCP, sir. TCP layer.
What is the name of the layer? Which layers of OSI models are responsible for error detection? Data link layer is one, but what about other? Transport layer. Okay, transport layer. Data link layer only performs error detection. Transport layer performs error detection as well as error correction by the mechanism of sequencing, acknowledgement, and retransmission. Okay. It only performs error detection with the help of a field called FCS and by running CRC check, cyclic redundancy check, and frame checksum sequence. Okay, these are the fields of Ethernet header. At this layer, hardware addresses are used. Hardware addresses are used. Okay. Switches and bridges work at this layer. This layer is responsible for forwarding a packet from one device to another device. We can say in a network. Okay. It is up to you. Let's see what is the level of concept clarity you guys have. What is the difference between network layer and data link layer? In the network layer, what I'm saying over here, if you look at it carefully, I'm saying this layer is responsible for transmitting a packet from one network to another network. Okay. But over here, I'm saying this layer is responsible for forwarding a packet from one device to another device. What is the difference between these two statements? Network to network and device to device.
Data
sir.
link layer is for same subnets.
No.
Can say same subnets. I mean, same
You
network.
can say, yeah, you can say, but okay. Why not network layer then? Why network layer is not able to do that? Why not same thing in a network layer?
Yes.
I'll tell you, because of the MAC address. If you want to reach a specific device, what do you need? You need its MAC address, because IP is variable. IPs can never be unique. There is a probability if a particular IP is assigned to me today, tomorrow it could be assigned to someone else. But MAC address is the one which is hard coded on your device. So that is why whenever we are talking about a device to device communication, end to end communication, or you can say, you take the help of data link layer. But if I'm talking about reaching one network to another network, for that you definitely require network layer. And once you reach to that new one network to another network, then inside that network, when you have to go to a specific end device, what do you need? You need MAC address. It is like, see, I have gone from Delhi to Chennai. Okay, and a friend of mine is coming to me from Chennai to Delhi. What aircraft did? Airplane took him from Chennai to Delhi. He came via flight from Chennai to Delhi. But the moment he landed in Delhi, he has to come to my home. How can he come to my home? With the help of address. He needs my physical address to come to visit me, right? Network layer did. Network layer is like an aircraft. Network layer will carry you from one location to another location. But in that location, when you have to reach your end destination, you need data link layer. You need the physical hardware address. Is this analogy understandable for you, which I'm talking about right now?
Yes, sir. Understood, sir.
Okay. Okay. One more thing. This is the only layer which is divided into two sublayers. What are those two sublayers? MAC and LLC. Logic link control. Okay. And Ethernet header is the only header. Ethernet header, the header for data link layer, is the only header which has both header and trail. Okay, that we'll talk about in Ethernet header. What are the protocols that are used in data link layer which are specific to data link layer? Name at least two.
ARPA and ARPA, sir. And
R,
HDLC.
ARPA, HDLC,
Triple P.
triple P, triple POE, etc. are used at this layer. Okay. Last is your physical layer. Okay. At this layer, the simplest layer. At this layer, but most complicated when it comes to hardware communication. At this layer, hubs, repeaters, access points, transmission mediums, etc. are used. Okay. In this layer, data is converted in binary format and put over the transmission media. So this is your OSI model. Okay. What are the PDUs of different layer? First, tell me what are the PDUs? What do you mean by PDUs?
Protocol data units, sir.
Protocol data units. They are the names of the data units of each layer. Okay. Protocol data unit. Let's talk about layer 7. In layer 7, what is the PDU?
Data, sir.
Data itself. What is the PDU at layer 6?
Data, sir.
Data. What about layer 5?
Yeah, same, sir. Data.
Data. If a data is at these layers, it will be called as data. But the moment data will come into layer 4, then
Segments.
or
Chunks, sir.
no. If it is a TCP segment, definitely. But what about UDP? Datagram. Okay. At layer 3, when IP header will be, when the traffic will be encapsulated inside an IP header, then it will become packet. And when the packet will be attached with the Ethernet header and trailer at layer 2, it will become frame. And at layer 1, ultimately, the traffic will be converted into bits. These are the protocol data units of different layer. What about the encapsulation? Encapsulation in OSI model. Okay. What I'm trying to say, when each of the traffic will be encapsulated, okay? Let's say I'm talking about a layer 7 traffic. A generic example of a layer 7 traffic is the HTTP. HTTP header will be there at layer 7. At layer 6, it is also HTTP header. If I'm talking about OSI, at TCP IP, we have straight away layer 4. We'll talk about TCP IP as well after this. HTTP. The moment it will land in layer 4, your HTTP header will be encapsulated inside a TCP header. Okay. Again at layer 3, you have your HTTP and your TCP traffic. They will be encapsulated inside IP header. Okay. Again at layer 2, the same traffic of HTTP, TCP, IP, it will be encapsulated inside which header this time? Ethernet header. At layer 1, data is converted into bits. If I'm coming from top to bottom, okay. See, if I am the initiator, what I'm trying to say, if I have tried to ping google.com, okay, and Google is sending me the reply, Google will send the reply starting from layer 7 to layer 1. When the traffic is starting from layer 7 to layer 1, that is known as encapsulation. Then it will be on the physical media, let's say cables. The moment the traffic will reach to you, the moment the traffic will reach to you, what will happen? Decapsulation. It will go from bottom to top. You will receive in the form of bits. You will receive the traffic in the form of bits. From bits, you will convert it into Ethernet header, from Ethernet to IP, IP to TCP, and so on. So this is encapsulation, and this is decapsulation. One is at the time of sending and other is at the time of receiving, depending upon who is the sender and who is the receiver. I hope it is clear to everyone.
Yes, sir.
Okay, let's talk very brief about TCP IP. I won't take more than 10 minutes because everyone knows it's not much different from OSI. TCP IP. In OSI, how many layers we had? We had in OSI 7 layers. And like OSI, TCP/IP is also a reference model. It is also a reference model like TCP/IP. Sorry, OSI. It is also a layered approach model. Same. It has also same purpose, that is to establish a communication channel between devices of two different vendor. Okay, layered approach. It was developed by DOD. What is DOD? Department of Defense, USA. Okay, it was developed by them. What is the difference between OSI and TCP? OSI has 7 layers. TCP/IP, the form of TCP/IP which we are using today, has 4 to 5 layers depending on which version you are using. First, the updated version which we are using is today for our communication has 5 layers. Basically, so first is the application layer itself at the top. That is your layer 5. Basically, application layer in TCP/IP is a combination of application layer, session layer, as well as presentation layer of OSI model. Then after that you have application, after that you have host to host layer. Okay, this is layer 4, and this is the corresponding of which layer, guys? Host to host, transport layer of OSI model. The rest, all the protocols, TCP, UDP, they all are same. Then we have internet layer, which is layer 3. Only name is different, which is similar to network layer of OSI. Then we have data link layer and physical layer. In the older version of TCP/IP, in the older version, these two were referred to as access layers. Explanation and all are absolutely same. That was the only difference between the two. That was of naming convention. Okay, guys, I need a small break. Actually, I'm getting some irritation in my throat. Okay, so I'm taking break little early
Sure, sir.
today. Okay, so guys, I'll meet you at 13:20. Okay, Nirav, your camera is on, I guess.
Sumit,
Like earlier, I showed you couple of sessions earlier. I showed you Wireshark capture, and in those captures, I did showed you that whenever a traffic is sent from one side to another side, it is sent in the form of OSI or TCP/IP layers, right? And in that, every layer, every layer traffic, every layer traffic is sent with the help of headers. So we'll first talk about the headers of transport layer. Guys, please be on mute. Yeah, thank you. So let's talk about the headers of transport layer. Very important. as far as your interview prospectus is concerned. We have two protocols in transport layer, TCP and UDP. So we'll talk about their headers one by one. First, let's talk about TCP header.
Mudassir, your camera is on. You can turn it off.
Hi, Rohan. Okay, so let's go ahead with the TCP header. Okay, the very first fields of the TCP header are source port. Let me draw it first, then I'll talk about each fields one by one. Then we have destination port. Then we have sequence number. Then we have acknowledgement. Then we have, after acknowledgement, we have header length. After header length, we have reserved fields. Then we have TCP flags. Most important as far as the interviews are concerned, they will definitely grill you on TCP flags, guys. Then we have your window size, which we talked about prior to our break. Then after window size, we have checksum and urgent pointer or your urgent field. So this is the default fields of TCP header. Okay. After that, you have your options field as well, which also I'll talk about today. And after options field, you have your data. Okay. Source port, destination port, both are 16 bits each. 16 each. Sequence number is of 32 bits. Acknowledgement, 32 bits. Header length, anyone? What is the size of header length? 4 bits. 4 bits. Okay. And your TCP flags are 6, 7, 8, 6, 7, 6 to 8 bits, depending upon which flags you are taking. Window size is your 16. Checksum again 16 bits. Urgent pointer 16 bits. Okay. So these are the default fields of TCP header. Default fields of TCP header. Okay, they should be there, they must be there, otherwise your traffic will be considered as truncated traffic and it will be dropped by the destination. So what is the minimum size of the TCP header? If I'll convert it, it will come out to be total around 32 bits. Sorry, it's not 32 bits, 20 bytes. Minimum size of TCP header is 20 bytes. That is the minimum size, bare minimum size. That is, if 1 byte is 8 bits, so how many bits will be there? 160 bits. Okay, that is the bare minimum size. Okay, where every row is of 32 bits, or you can say 4 bytes. and you have 5 rows. 1, 2, 3, 4, 5. And these 5 are the default rows we have. Let's start talking about each one of them one by one. So let's talk about port numbers. Sorry. Okay. Port numbers. As I told you, you should understand what is port numbers first, then we can talk about what is a source port and what is a destination port. Port numbers, again, they are of 16-bit size values, up to 16-bit size values. So that means 2 to the power 16. That will come out to be somewhere around 65536 total ports we have, or 0 to 65535. Port numbers, they are used for transmitting. Port numbers are used for transmitting and receiving data. Okay, and as well as identification of application or services. Application or services. So you have port number range from 0 to 65535, and this range is further divided into two fields. They are well-known port numbers and second is unknown port numbers. Well-known port numbers, also called reserve port numbers, also known as reserve port numbers. What is their range? Their range is 0 to 1023. Okay, and rest of them are, apart from this range, rest of them are unknown port numbers. They are used for transmission purpose. They are used for transmission purpose. Range is 10242 plus till whatever we have 65535. Even though, even in this range itself, we have some reserve port numbers 1024 onwards itself. For example, port number 3978, which is a proprietary port number for Panorama to communicate with Palo Alto. So like that, we have many port numbers as well. 3389, 8443. So we have 1024 onwards also some random reserve port numbers. But yes, overall, this range is specifically used for transmission purpose. What is the transmission purpose I'm talking about? That these values are generally considered in the source port numbers. Whenever I'm sending any traffic from one point to another point, okay? Like whatever my client is communicating with a destination server and he wants to access a service on a particular server. Let's say this is a Google server. Okay. So whatever the source port will be, he's going to use in his TCP header, it will be from this range 10242655535. So source port will be 1024265535. Let's say it is 5005. Let's say any random port. Then you have destination port number. Destination port numbers are generally defined with respect to the application layer. Destination port numbers. Destination port numbers, they are defined with regards to or with respect to application layer protocol. That which protocol I'm going to use at application layer. If I'm using HTTP at application layer, then my destination port will be 80. If I'm using HTTPS, it will be 443. If it is DNS, then it is 53. DHCP, tell me guys, port numbers for DHCP. Anyone?
67
And
67
and 68.
68
FTP
21
2021. Telnet is 23. SSH is 22. TFTP is 69. NTP is 123. Network time protocol. Okay. Then you have further etc etc etc. There are many protocols. So your destination port depends upon what protocol I'm using at the application layer. So it will always be in the range of 0 to 1023 in most of the cases. Okay. So this is your port number, guys. After port number, we have sequence number and acknowledgement number. After port number, we have sequence number and acknowledgement number. Okay, tell me what is sequence number, guys? It's very simple. Anyone? What is a sequence number? Come on. I think we discussed about sequence number in last sessions as well.
Yes, sir. It will tell us how much data we received from receivers.
Not quite, buddy. Okay. It is a 32-bit number. 32-bit number used for data sequencing. Every data that is sent from one point to another point, from one sender to another receiver, whatever data he will send, a sequence number will be attached with the data. Okay, let's say this is your device A, this is your device B, and they are exchanging some data among themselves. Okay, A has sent a traffic which has sequence number 1000 and its length is, let's say, 1000 bytes. So what will be the acknowledgement that B will send to A? Anyone? If you will answer me this, I'll be like, you're done. You know the concept of sequence and acknowledgement number. Sorry for my throat.
1001.
No.
1002.
No. Guys, what you are telling me, that is when That is the case of normal three-way handshake. In three-way handshake, if my sequence number is 1000, then acknowledgement will be 1001. Why? Because I'm not sending any data into the three-way handshake. In three-way handshake, no data is exchanged, thus just the communication parameters are advertised and negotiated, right? But in this case, I am exchanging data length of 1000 bytes. So that means sequence number 1000, and in that 1000 bytes will be sent. Okay, so that means your B end device has received the 1000 bytes of data from sequence number 1000. So that means 1000 is done. So now he is expecting the next bit. So that will be your 2001. Okay. If data length would have been 0, then definitely in that case, it would have been 1001, the way you said. Am I clear? And acknowledgement is always plus one of the sequence number. I hope that everyone knows. Whatever will be the sequence number, in case no data is there, then acknowledgement will be sequence number plus one. But if data length is involved, then data length plus sequence number plus one. That means till that data is received by the receiver. That means my device B has received 1000 bytes starting from sequence number 1000. So sequence number 1000 to next 1000. So 1000 to 2000 he already received. Now he is expecting 2001. Clear or not? Yes or no?
Yes.
Okay. What you said, absolutely correct. Okay. But again, that was the case when no data was sent inside the three-way handshake. So sequence number as well as acknowledgement number, they both are nothing but 32-bit numbers who are just corresponding to one another. Acknowledgement is always plus one of sequence number. In case no data length, and if data is involved, then sequence plus data length plus one. That means till this point, data is received. Now he is expecting this one data to send out to him. Now my B is expecting A to send him sequence number 2001 with data length 1000. Okay. Okay, so this is your sequence and acknowledgement number. Now let's talk about the next bits, header length. Very common question asked with regards to header length, guys. This field is of 4 bits, right? This field is of 4 bits. Everyone knows, as I told you just few minutes back as well, that header length is of 4 bits. But what is the minimum length of my TCP header? As I just told you, minimum length of TCP header is 20 bytes. Guys, again, I'm reiterating myself. Minimum header length I'm talking about is 20 bytes. What is the maximum length? What is the
60.
maximum length? 60 bytes. Okay. 20 to 60 bytes depending upon which option field we are taking into consideration. Okay. So header length is of 20 bytes, but we have to represent the header length in 4 bits only. So how is it possible? Any idea, guys? My header length is 4 bits, but header length field in TCP header is 4 bits, but overall size of the header is 20 bytes. How am I supposed to represent 20 bytes into 4 bits? Anyone? Okay, you can do it with the help of scaling factor. You can do it with the help of scaling factor, guys. You need to use your scaling factor. Generally, whatever is the value of this field, that is multiplied by, I guess the by default is 0101. So 4 scaling factor of 4. So whatever is the value, that means value of header length will be multiplied by 4 to get the actual length of header. So default value of this field is 0101. Okay, multiply it by 4. 0101, this is the binary form. Converted into decimal, this will be 5. 5 times 4, 20. So this is the size of your header length. Okay, so this is your header length, guys. After that, we have reserve bits, and then we have our TCP flags. Or code bits or TCP flag, whatever you can say that. What is the use of TCP flag? First, TCP flags are used for
So fragmentation.
no identifying the purpose or the message of TCP. That what type of message or ident purpose the TCP header belongs to. We have following flags in the TCP flag field. They are first one is SYN, second is ACK, then we have FIN, reset, what else? Push, then after push, what else we have? Urgent, after urgent, we have ECN, explicit congestion notification, and CWR, congestion window reduce. So these are the 8 TCP flags we have. So they are used to identify which message or what is the purpose of the TCP header that you have received. For example, I have sent a SYN message to my receiver. How my receiver will get to know that this is a SYN packet? How? He will check which TCP flags are enabled in my TCP header. If he will see SYN flag is enabled, it is set to 1 and rest all the flags are 0, then my receiver will get to know that this is a SYN message. How your receiver will get to know that this is a reset message, or your sender will get to know that he has received a reset message from the server? By checking the flag value of the TCP. If reset flag is enabled, then it's a reset message. So that is how the flags help us to identify the messages of the or the purpose of the TCP header. SYN, ACK, and FIN. These are the 3 very simple flags that I hope you guys can understand from the naming convention itself, that SYN is used when a sequence number or SYN message is sent, or in some cases like your SYN plus ACK itself, we can have combination of flags as well, which can identify that these messages are used for multiple purposes as well. Like for example, in SYN plus ACK message of the three-way handshake, you have two flags enabled, SYN and ACK. Rest all are zero. Okay. In some cases you will see fin and push, something like that. So that completely depends that what type of communication is happening around you. So multiple combination of flags are also possible. Sin is sent when you want to send some sequence numbers or to send a normal data, and acknowledgement is when that data is acknowledged in the pertaining message or in the following message. And fin is used to send when you are closing a connection. But when exactly we are using these three messages: reset, push, and urgent. Let's talk about reset. Very common if you guys have worked in the security domain. So you guys must have seen in the firewall log, this message is very common. A source and the destination, they are communicating, and in the session end reason you are observing that the TCP reset from the server, TCP reset from the client. Am I right? Yes or no? Have you observed that anytime? I'm
Yes,
talking
yes, yes.
only to the.
We do observe that.
So what exactly that implies, what exactly that means, what could be the reason for that? Do you know
As
the
per my
reason for that?
understanding, there might be some reason that the TCP connection has been reset and it has been terminated by the
Why?
server.
Why
Uh,
server terminates that?
it might be due to might be not, cannot say certificate, but something abnormalities.
Hmm. Okay. It is, it happens when your server receives something which he is not expecting. For example, you are hosting web services on 443 on your server, but for a particular source and a particular destination. But when the same source and destination will try to access the same web server on port 8443, it will cause, in that case, the destination server will ask you to reset your TCP connection when he will receive out of order packets that he is not expecting. Generally, this happens when the destination itself. Let me tell you a thumb rule if you are working in security. The moment you receive TCP reset in your logs, leave it to the destination owner or the application owner itself. That means your firewall has allowed the traffic is entering into the firewall and going out properly. Destination is the one which is not accepting the packet. Because the application which he is trying to access, maybe it's opened on a different port, or maybe authentication error as well. In case of authentication error also, you may receive the reset message from the server. So any abnormality which is out of order will cause your TCP connection to reset. Am I clear with my explanation or not?
Yes, sir.
So next time, the moment you will see TCP reset in your logs, that means the connection is absolutely fine from the firewall end. Destination owner needs to check on his end what is causing the issue. It's not your issue. Okay. So we can say when unordered traffic, when unordered traffic is received by the receiver, when unordered traffic is received by the receiver, it It sets reset bit to get entire data traffic again. In some cases, reset is also used when connection is refused or not opened. Okay, so this is reset. What about push and urgent? Very commonly asked question, push. Anyone? When do we use push flag? Anyone wants to answer?
When
Sorry,
data is being
sorry.
sent.
When I didn't get you. When do we
Data
use
is being
push? Okay, when we have to push the data out. When we have, yeah, we don't want to wait for the buffer to fill up and we want to push the data out immediately from our sending buffer. Like receiving buffer, we also have our sending buffer. What is the name for that sending buffer? Anyone? MSS. MSS. Okay. You don't want your MSS to fill up entirely before going out of your device. For example, telnet. Okay, let's consider an example. I'll give you a very realistic example of the push only. Let's consider the example of telnet itself. What will happen in the case of telnet, guys? I'm sitting in Noida, let's say, right now. I'm sitting in Noida. I have taken the access of a device from, let's say, DC. So DC, I'm talking about Washington, DC. Okay. Let's take the example of Washington, DC because it is very unrealistic and very far away. But I have taken the access of a remote access of a device from Washington, DC. Let's say my that MSS MTU size again, its MTU size is again 1500 bytes, right? Let's suppose, and MSS is my 1460 as usual. MSS. I have in the when I took the I'm talking about, let's say, one of the routers. Okay, I have taken the access of this router and in the router I have typed the command interface fast Ethernet 0 by 0 shut down. Guys who are freshers, guys, you might not be aware, but this command is very simple to write, but in a production environment it can cause an outage or it can prevent from causing an outage. Am I correct or not? Shut and no shut an interface is a very critical activity depending upon the criticality of the device in the production environment. And let's say I have typed shutdown command in one of the interfaces. How, what is the total size of this command? Let's say every single character is of 4 bits. 1 2 3 4 5 6 7 8. So 4 times 8 is 32 bits. That means 4 bytes. So do you want me to wait for my MSS to fill up to 1460 bytes, and then this traffic will go along with the MSS towards the destination? No, we don't want that. I want, or my production environment calls that the moment this shutdown is entered in the system, it should be immediately sent to the destination without waiting for the MSS buffer to fill up and then to send. Because that buffer can take some time to go, and by that time some vulnerabilities could enter into the environment through that interface, provided the interface is compromised. Are you getting my point? Yes or no?
Yes, sir.
So in such type of cases, we enable push bit. Okay. So classic example is telnet, guys. Then we have urgent. Urgent field is generally enabled in case of urgent pointer. In case of urgent pointer field of TCP header, whenever any urgent data needs to be sent, then urgent field is enabled to 1. And whenever urgent pointer and the data traffic that belongs to that urgent is defined in the urgent pointer field of the TCP header. Okay. Where is the TCP header I have drawn? Okay, this one. Whenever any corresponding data belonging to urgent pointer is needs to be sent out, then urgent field in the TCP flag is set to 1. Okay. Then window size we have already talked about, and we are left with two more flags of the TCP, ECN and CWR. Guys, let's do one thing. Let's wind our session today here itself because I'm feeling some irritation in my throat. Let's continue our discussion from this point onwards only from tomorrow. Okay. I'll talk about the options field. Then I will continue talking about the IP header, Ethernet header. Then we'll start with the packet flow. And probably from the next Saturday onwards, we will start with switching. Okay.
Yeah, okay, sir.
Okay.
Okay, sir.
Okay, guys. Thank you so much for joining. I hope you liked today's session. I know it was theoretical, but we covered.
Sure whether it was clear to you or not. Yeah, recording has started. Okay. Okay, urgent flag. Okay, urgent flag, it signifies from where does the urgent data starts in the given segment. Let's suppose you have a stream like this. 1, 2, 3, 4, 5, 6, 7, 8. Let's suppose I have a stream of data like this. Okay. One is going first, second, third, fourth. And let's say your number 5 is the urgent data. that needs to be processed first. So this urgent data will be specified in the urgent pointer field that will be equivalent to 5, and 5 onwards your urgent flag will be set to 1. So that's how it will be. Is it clear now? Is it clear now, guys?
Yes.
Okay. There is one small topic before discussing TCP options: fragmentation and segmentation. Everyone tell me the difference between the two. Difference between fragmentation and segmentation. We say this a lot, that segmentation is there in TCP, it's not there in UDP. Very common thing. But can anyone tell me the real difference between the two? Come on, you are experienced candidates, some of you. Guys, what happened? No idea? No worries. Let's suppose I have 5,000 bytes of data. Okay. Let's suppose I have 5,000 bytes of data. So do you think 5,000 bytes of data will be processed exactly the way it is? It is sent exactly in a 5,000 bits of stream? No, right?
No, sir.
Why?
Yes.
Question is why? Why it happens like this?
Because, sir,
What is the reason?
in TCP, your maximum segmentation size is 1480, sir.
You can change that manually.
Okay.
That is a default. You can change that manually and you can then send it anything. Let's say this is router 1. Let's say this is router 2. Let's say this is router 3. And let's say this is router 4. Behind this router 4, there is a server that you are trying to reach. And here is a client that is trying to reach this server. Okay. They both want to have a communication channel between them, right? Whenever the communication happens in TCP, what is the first thing that happens? First thing that happens in TCP whenever the communication initiates or whenever the communication is started. Guys,
Three-way
three-way
handshake, sir.
handshake. Right. In three-way handshake, what will happen? The client and the server will exchange SYN messages. Client will send SYN and this will send SYN plus ACK. Yes or no?
Yes, sir.
So in SYN and SYN plus ACK, what are they actually exchanging? They are exchanging their communication parameters, their window size and all those things, right? They are exchanging only this client's and server's window size or the other communication parameter. But what about the routers in between? This server has a receiving buffer size of 5,000 bytes. Client has a sending buffer size of 5,000 bytes. That they have already exchanged in three-way handshake. But what about the ingress and the egress interfaces of routers? What about them? What is ingress and what is egress? Anyone? What is ingress and what is egress?
In or out?
Ingress.
Yes. Ingress. Remember this terminology. I will always use this one only. Ingress is
Inside.
inside interface and egress is outside interface. Okay. What about the ingress and the egress? Let's suppose this interface has the capacity to process only 1500 bytes. And how this router will like take and process 5000 bytes? What it has to do? It has to divide it into chunks. Yes or no? This router has to divide it into the chunks. Let's say this has only 1000 bytes. Let's say this has only 800 bytes. So what we need to do with the 5000 bytes of traffic that needs to be exchanged in between these two clients and server, it has to be divided into smaller chunks before sending it out over the internet, right? And this process is known as segmentation and fragmentation. That means what is segmentation? Segmentation is nothing but dividing large chunks of data into smaller chunks. What is fragmentation? That's also same. Dividing large chunks of data into smaller chunks. That is also fragmentation. Then what is the difference between the two? If I'm saying both are same, one and the same thing, then what is the difference between the two? Anyone? Difference lies in which layer they are done. It is done at layer 4, while it is done at layer 3. It is done with the help of a the help of MSS, maximum segment size. It is done with the help of maximum segment size. What is the default value of MSS? 1460 bytes. Okay, while this one, it is done with the help of MTU, maximum transmission unit, whose size default value is 1500 bytes. Now, what is the need to done something at layer 4 and then again at layer 3? I'll tell you. Every traffic doesn't has all the 7 layers or all the 5 layers of TCP/IP or OSI. There are certain protocols that start straight away from layer 3.
For example, your ICMP, EIGRP, OSPF, all these protocols, they start exactly from layer 3. They don't have previous layers. So if I have to divide something that is starting from layer 3, I can't divide the traffic at layer 4. Yes or no? I cannot I cannot fragment EIGRP traffic into smaller chunks at layer 4 because it doesn't has any layer 4. It is starting from layer 3 onwards only. It is starting from layer 3 onwards only. So for protocols that starts from layer 3, we are doing fragmentation. And for the remaining protocols that are starting from layer 7, like conventional protocols, HTTP, HTTPS, FTP, Telnet, SSH, for them we are doing segmentation. Is the difference between the two clear? Yes or no?
Yes.
Yes, sir.
Okay. Segmentation is done for layer 7 traffic at layer 4, while fragmentation is done for layer 3 traffic like IP, EIGRP, OSPF, GRE, etc. Very commonly asked interview question. I hope today onwards you will not forget the difference. Okay.
Yes, sir.
One more thing, MSS and MTU are one and the same thing. Again, how? MSS is 1460 and MTU is 1500. In 1460, I'll add 20 bytes of TCP header. In this, add another 20 bytes of IP header. What will it become? It will become 1500 bytes of MTU only. So this is also a logical explanation that both are same thing. The only difference between them is the layer at which they are respectively done. Clear? Okay. Now tell me about TCP options. TCP options. How many options you know? First, tell me what is the use of TCP options. Okay. When TCP initially came, internet was not that much developed. We had many features that were not included in the TCP header. If you go and look at the diagram of the TCP header from yesterday's session, or even now, if you want, you can open it on Google as well. You will see there are many things that are not covered in TCP header. For example, MSS, which we just talked about. Whenever a device has to advertise its MSS, timestamp. We talked about a feature, selective acknowledgement. MSS, timestamp, selective acknowledgement. What else? Window scaling factor. TCP fast option.
and many more. For all the features that were not included in the original TCP header, they were included in the TCP options field. This field has its size is of up to 40 bytes. So maximum size of TCP header is, what is the maximum size of TCP header then? 20 bytes minimum size. That is without options field. And if I'm using options field to its full capacity, that means 20 bytes of options field, 20 bytes of TCP header plus 40 bytes of options field. So the maximum size of TCP header can be up to 60 bytes. Another interview question. What is the maximum size of TCP header? 60 bytes. Okay. What is MSS? Anyone? I just told you. Let's see how many of you understood. MSS.
Maximum segment size, sir.
Maximum segment size used for segmentation of traffic at layer 4.
Layer, sir.
Okay. What about timestamp? What about timestamp? Timestamp, anyone? Guys, whenever a traffic will go from one point to another point, you need a timestamp, right? Yes or no? I need to know when the traffic was generated. Whenever a traffic is generated and it is going from one point to another point, there is a timestamp associated with it, which specifies the moment the traffic was generated. So that timestamp is mentioned in the TCP header fields, in the TCP options. Same goes for selective acknowledgement. Okay, now tell me what is selective acknowledgement? Now tell me what is a selective acknowledgement?
Associated connection.
Mm-hmm. Sender, and let's say this is the receiver. 1, 2, 3, 4, 5, 6. Okay. What is a normal flow? Let's say 6 is the window size of the receiver. Okay. 1, 2, 3, 4, 5, 6. Okay. So sender sent the 6 packets. All 6 are sent. But from the acknowledgement, I'm getting acknowledgement 2. That means 1 is sent, 2 is missing, 3, 4, 5, 6. Everything is received except 2. Let's say 2 lost in between. Lost in between, let's say. So acknowledgement 2. That means that receiver wants 2 once again. But what exactly happens in a scenario of a sequence and acknowledgement? Acknowledgement means that I have received till this point. Now I'm expecting you to send the acknowledgement number onwards traffic. So the moment sender will get acknowledgement to, what sender will do? Sender will resend 2 onwards entire traffic. So all these traffics will be 2 to 6, stream of 3 to 6 will be resent. They will be resent. What it is? It is wastage of resources and wastage in the utilization. Yes or no? To
Yes,
overcome
sir.
this, we came up with a concept of SAC. Selective acknowledgement. With selective acknowledgement, if enabled, only specific stream will be sent, will be retransmitted. That means if selective acknowledgement 2 is sent, then in reply to that, only stream of 2 will be resent. Is this clear or not? Selective acknowledgement.
Yes, sir. Clear, sir.
Selective acknowledgement, TCP options. Okay. What else? Window scaling factor. What is the size of the window size field in TCP header? Tell me what that. Guys, these options field are very important. Nobody discusses options field generally. So if I'm discussing with you, please try to understand them. Okay, try to get the concept, and you can read about them in the RFCs as well. Tell me what is the window size field in the TCP header. TCP header has window size field of 16 bits. Okay. If you go back to yesterday's session and yesterday's TCP header explanation, in that I mentioned 16 in front of window size. That means what could be the maximum window size? What is the maximum window size? 2 to the power 16, which is 65536. That is 65 KB. That's it. That's it. 65 KBs. The type of transmissions we have in today's era, do you think 65 KBs isn't enough buffer size to process? It's not enough, right? We have, numerous or great lengths of data that needs to be exchanged among two client and servers. And if somebody is saying I can only, process 65 KBs at a time, it will again slow down my entire transmission process. So we came up with the type of devices, the high-end devices we have in today's world, where they can have up to 1 GBs or multiple GBs of, multiple GBs of window size, their receiving and transmission buffer. They can receive and transmit to a great extent. So how we came up with this solution of increasing the window size? Because in the default TCP header, we have this thing of only 65 KBs. So the solution for that was window scaling factor. So to calculate overall window size, calculate overall window size, you need to multiply window scaling factor multiplied by the TCP header window size. So they simply multiplied it to get the actual window size of a device. If a device is sending you TCP in its SYN plus ACK, let's say your backend server is sending you SYN plus ACK, and in that he is saying my window scaling factor is 4 and my window size is 65 KB. So that means its total window size is 4 multiplied by 65K, which is 260K. So that is his actual window size, which was not possible in the lower end devices. Since we are communicating with high end devices, they can receive and transmit a lot because they have huge buffer memories. Okay, so this was window scaling factor. It was used to so that we can, comprehend with the latest high end devices to compensate for their actual window sizes. Is it clear or not?
Yes, sir. Clear, sir.
Google's DNS server, it's huge, man, it's huge. I don't know how much of a traffic it is handling. Probably that's the one thing which is handling the highest traffic of all the devices right now. TCP fast option. You might hear about it, or you may not. Chances are very less. But still, you need to be aware about the TCP fast options field. Okay. TCP in whenever a TCP fast option is enabled. Okay. Or let's do one thing. This is your homework. I will ask you in the next class. Let's see how many of you do your R&D. One, do your R&D. I'll definitely explain it to you in the next class. Is it okay?
Yeah, okay, sir.
TCP fast option field, TFO field. Okay. Okay. Now let's talk about another layer 4 header, UDP. One of the simplest headers. One of the simplest headers that you will ever encounter. Nothing. It has absolutely nothing, guys. Nothing. Source port. Destination port. Header length. Then we have header checksum. That's it. Nothing else, nothing more. One of the simplest headers we have. After that, you have your data. Application layer data. Total size 32 bits. 32 bits. Total is 64 bits. That means 8 bytes. Same source port, destination port, header length, and checksum. Nothing else apart from this. That is why we don't have any concepts like retransmission, sequencing, window size, so flow control, session close. All these concepts are not there in UDP. Okay, now let's talk about one more important header of layer 3. Layer 3 headers, where we'll talk about IPv4. Okay. So IPv4 header, otherwise I have to draw it. Let me take the snip from the Google itself. Otherwise I have to draw. Guys, is it visible? Guys, say something. Is it
Yes, sir.
visible?
Yes, sir,
This
it's
is
visible,
your,
sir.
yeah, this is your IPv4 header, guys. Version, header length. This is your version. This is your header length. This is your type of services. Identification flag, rest all is good. Rest all is okay. Again, same thing as we discussed in as we discussed in TCP header. Okay, 32, 32, 32, 32 bits, 32 bits. Overall, 160 bits. That roughly comes out to be 20 bytes. That is the minimum size of the IPv4 header. What is the maximum size? Again, options field
40.
0 to 40 bits. Sorry, 0 to 40 bytes. So the minimum size is 20. That is the IPv4 header plus 40 up to 40 of options field. So that will come out to be 60 bytes piece IP header. Maximum size of IPv4 header. I hope it's clear. Okay. First thing, let's talk about version. IPv4 header is not that difficult, guys. It's easier than TCP header. Okay. So let's talk about version first. Version field defines what type of IP address you are taking, whether you are taking IPv4 or you are taking IPv6. Okay. If the value of the field is 0100, that means it is IPv4. 8421 IPv4, and if the field is 0110, that means IP address is IPv6. Okay. Then you have your header length. Same concept, header length is there as we have in the TCP header. 4 bits of, again, this is also 4 bits. We will use
Scaling.
a scaling factor to get the actual header length. Same concept. Type of service, I'll explain you at the end. Let's talk about the total length now. What is total length? Total length it will specify what is the difference between header length and total length. Total length, it will specify size of
Header length and header length and data length data.
yes, size of data plus IP header. So that is why we have to use 16-bit field for it. What is the default size of ICMP payload? Entire payload. Anyone? Ping 8.8.8.8.
100 bytes, 100 bits, I think so.
100 bytes. 100 bytes. How 100 bytes? 8 byte of ICMP header. ICMP header is 8 bytes. Okay. Then we have 72 byte of user data. User data that is generated. This is ICMP header. ICMP header plus 72 bytes of user data plus 20 bytes of IP header. So what will it turn out to be? 100 bytes. Okay. We'll talk about ICMP more in packet flow, guys. Now, this 100 bytes of data till IP header, it is going to be advertised in 16-bit field of total length. In this, we can advertise easily 100 bytes of data, that the total size of the payload that this stream of data is carrying is 100 bytes. Is it clear? And header length only specifies length of the header.
Okay, sir.
Okay. Okay, let's discuss type of services only. I guess identification, flag, fragment, offset. Yeah, let's start discussing type of services. Okay. I don't think so. Type of services anyone discusses generally. TOS. Type of services. Generally, this field is more used in QoS, quality of services. Okay. It is of 8 bits. How this 8 bits is written? First 3 bits is known as class of service fields. Then next 3 bits is your DP bits. DP bits. What is the DP? Drop precedence. Then you have next 2 bits, which are your ECN bits, which are known as error or explicit, depending upon the book to book, congestion notification. Okay. ECN and CWR bits, they are also part of TCP flags. which I may haven't explained you yesterday, but they are used in IP header in conjunct in relation with TCP header. I'll tell you how. Let's start from this point onwards. The ECN bits. Okay, ECN bits. They are used. They are used for notification of congestion. Congestion means traffic flow is very high by router on ingress port. Always remember this, ingress port. What I'm trying to say, let's say this is your client. This is your router. And this route is very congested. And this router knows that he is getting huge flow of data per second. So in this case, what will happen? In this case, let's say there are some priority traffic in the congestion window. In this congestion window, there are some priority traffic that needs to be urgent traffic that needs to be processed as early as possible. But because of the congestion in the flow, because of the congestion in the route, your router is unable to perform that specific task. Now, what your router will do? Your router will send an explicit congestion notification. Router will send from this ingress interface only, it will send an ECN notification to the client. What this notification will do, this notification implies from the router that because of congestion, priority traffic let's say this is the priority traffic. Priority traffic won't reach me on time for processing. So every stream of traffic, every stream of traffic will be processed in FIFO format. What is FIFO format? Anyone? Data structure guys, FIFO.
First in, first out.
First in, first out. First in, first out. So in TCP flags, when ECN bit is 1, that means there is a notification. Same thing goes for IP header type of services as well. So this is something which is there in both TCP header and IP header. Why? The reason is same, because there are certain type of traffic which don't have layer 4. Okay, so in those cases of traffic, and even there is a possibility that even if we have a layer 7 traffic, but it is a UDP based traffic. So for such type of traffic, we have ECN bit specifically defined in type of services field in IP header as well. And if ECN bits are set to 1, that means there is congestion over there. Okay, ECN bits are only of 2. ECN is a 2-bit field only. Okay, its value is like this: 0 0 0 1 1 0 1 1. When the two bits are both 0, that means not an ECN. No explicit congestion notification. When it is 0 1, 0 1 means no ECN and ECN not capable. Neither they are capable to perform explicit congestion notification. 0 1 means ECN is capable. That means they can send an ECN capable message. That means explicit notification. This feature is there in the transmission, but explicit congestion notification is not there. When it is 1 0, that means ECN capable. Again, ECN is capable, but explicit congestion notification is there. 1 1 means ECN 1 1. This is no ECN. ECN capable. No ECN and ECN capable. That means ECN not capable and no ECN. I can bet you on this. Nobody will ask you this in an interview because this is something not many people know, guys. Not many people know about this. After ECN, you have next thing, class of services. Again, class of services. Sorry, class of services. We're already discussing. We are discussing type of services. Now let's talk about the first three bits. We talked about the last two. Let's talk about first three bits. First three bits define what type of traffic it is actually. Okay. 0, 1, 2, 3, 4, 5, 6, 7. This means 0, 0, 0. 1 means 0, 0, 1. 2 means 0, 1, 0. 3 means 0, 1, 1. 4 means 1, 0, 0. 5 means 1, 0, 1. 6 means 1, 1, 0. 7 means 1, 1, 1. Okay. 0 means 0, 0, 0 means it's a routine traffic, normal traffic. Guys, I hope it's not going over your head. This is a normal priority traffic. The more is the value of class of services, the higher priority traffic it is. Okay. 2 means immediately processing required. Immediate processing traffic is required. 3 means it's a flash based traffic or voice based traffic. Flash override. These are your calling traffic. Flash override or voice based traffic. 101 means it is a critical traffic that needs to be processed beyond everyone. 6 and 7, these are reserved for your. These are reserved for your network protocols. Your routing protocols. Okay. routers will give priority to higher preference traffic. Whichever is having higher value, they will be processed first. In case there is a tie between two same priority traffic, then DP bits are checked. Then DP bits are checked. DP means drop precedence, last three bits. That means, let's say I have two type of traffics who have class of service value 4. In that case, I will go to DP bits. I will go and check what is the value of their DP bits to see which traffic I'm going to be processing further first. Both will be processed, but which will be processed for the first? DP bits drop precedence.
Uh, Sumit, before that, can you,
Yeah.
is there any use case? Because I'm not, you maybe cover that. What is priority traffic and all immediate traffic? Is there any difference? I didn't get that.
Yes, we do have a case like a voice-based traffic. See, some type of traffics have higher precedence over the others. For example, a government-based traffic. So let's say a confidential traffic is going. Let's say India is sending a traffic that please disable some rocketry operations. Like ISRO is trying to communicate to its rocket over the wireless infra that this rocket needs to hold its launch. So that type of traffic will have a class of service value 5 because that is extremely critical. Even a seconds of delay could cause an issue in that, could cause chunks of money, could cause millions of dollars. So that completely depends on the class of service we are using. When I'm saying all zeros, that is generic routine traffic, your text messages and all, or some text messages which are important. Let's say they are generated in case of an emergency. Like if you remember in the last couple of weeks, I don't know how many of you have experienced it or not, but try Telecom Regulatory Authority of India is testing out an emergency war mechanism feature, that if in case some sort of a war or some a national emergency happens, then how to reach out to maximum of its citizens in that case. So they, you guys must have got some message in the past couple of weeks or 3 weeks time. I don't know how many of you have got it, but I think they did that trial for 10 times, and out of 10 I received it couple of times. I don't know how many of you did it or not. So such kind of traffic are extremely critical. They have high class of service value like 5. Okay, otherwise your normal calling based traffic, that is the flash based traffic, that has value 3, and your normal video based traffic, video calling based traffic, that is flash override value, that has a that is 4. So that completely depends on the type of traffic that is you know you are sending out, and which traffic needs to be processed further first when it is reaching the receiver's queue. or your router's queue. Router needs to process which traffic first of all the traffic that he is receiving in a particular second of frame. Is it fine now?
Yeah. Okay. Thank you.
Okay, there is a proper, topic QS on this quality of services, and in quality of services, we are using these fields only. Okay, I will discuss more about QS, but in the upcoming sessions only. This is only I'm discussing right now with respect to your IP header. And let's say your device has received a traffic which has same priority, same class of service, then which will be processed first of the two? In that case, we will check the DP bits. Again, drop precedence. This is a 3 bits field. 0, 0, 0. This field will remain 0 only, last one, because this is reserved. 0, 0, 0, 1, 1, 0, 1, 1. Okay. Higher DP is processed further. Sorry, later. Higher DP is processed later. So if your router has received, a traffic, let's say it has received two streams of traffic, and both the stream of traffic has flash as a class of service. Now, of the two, which will be processed further? For that, DP bits will be checked. In DP bits, it will be checked who has the higher DP value. Whichever of the two is having the higher DP value, it will be processed second. Lower DP will be processed first. Okay, so that will be checked again. Even if DP bits are also same, if DP bits are also same, then FIFO, format processing, will happen. If everything is same, then FIFO, format processing, will happen. Whichever will be received first by the router will be processed first. That's it, guys, for the first half. I hope you understood it. Guys, can we continue our